That'll be hard to do, boy, Chris. Boy. I will try to do it though. Okay. Are they ready? Are they ready? Are we locked in? Are they locked in? Are they locked and loaded? Are they
Just
ready
a
for
little
it?
man join.
Yes, sir.
Nice. There we go. Are they know this scene? TikTok banned me from going live on my laptop. So I had to go live on my phone. I don't know what it is with TikTok, you know.
Yo,
Hey, look, Romano. Just finished my third advanced session for the day. Hey, boy, Chris, they had a pass advance, boy. They had a pass advance. They had a pass advance. They had to get through that advance. Am I go for all 9 hours? Am I go for all 9 hours today? If I have enough people on thing, maybe I'll 10 hours on thing, but day before the exam, and maybe I might do a 14 hours as well. You know, like from sun up to sundown kind of thing. Yeah, 2023 and 2022 were nice papers. 2017 was real nice. 2017. I think the kinematics from 2017 with like the three different variables. That was a nice question. You really had to think for that one. You really had to think for the, I think it was 2017 or 2019. The kinematics question there. 2017 had some good questions. Oh, Chris, I had to discuss something with you. I will message you privately, but there's this one question that I've been seeing a lot of students and teachers doing wrong, and I wanted to pass it by you. Yeah, a lot of people was doing the when you had to come up with the equation of the curve, you had to consider any. So like when you're finding stationary points and you set the gradient equal to 0, you could potentially divide throughout by a common factor. And so when you're reversing the process, you need to take into consideration that step. So you need to multiply by an arbitrary constant. And all the solutions I've seen online, they have not accounted for that. So I'll send you my solution and you'll see. Nah, Chris, these are beasts. I doubt you make that mistake. I don't think you make that mistake. Here, what? Just message me on WhatsApp. Let me check the WhatsApp messages. I feel like I can make it for 9 to 10 hours a day.
Yes,
I
sir.
want to do real work today, boy. Real work.
yes, sir.
Yes,
That's
sir.
right.
Sir.
Okay, good.
So what topic you doing today?
I want to do the polar integration, finish up that kinematics, and then I'll do Tom's tricks. I see that apparently POV paper 2 leak. Bali was here at some point. I talked to Bali about that, but yeah, apparently I heard out of all papers, POV. Out of all papers, POV. Crazy.
Sir.
And the exam was today?
Yep, the exam was today.
Yes, sir.
So yeah, anybody here is in POV?
No, but sir.
Anybody here wants to leak paper to come?
Hey, let me not encourage anything. Next thing CSEC come for me and thing. Hey. Right.
Excuse, sir.
Yeah, Nikolai?
I was in I went out to my brother parents' day, and the way how them boys was getting on, how they would hide books and those stuff in the washroom to do POV. I suspected that the paper would have been leaked, and that would have been the first people to go and see it, sir.
Oh, based on how everybody was moving.
Yes, sir. They want to hide book. They want to come out. They don't plan on the situation how they're going to cheat for them exams, sir. I want to know what? Oh, your
But
book?
But POV boy, I don't know POV, you know, but from what I've heard, I've heard POV is like on the easier side of things. Yeah, but hey, big up Keen one time. We are come here to lose, we come here to win. Big up Keen one time in the chat. Alright, big up Keen and Chris. And I see Bali was there too. Big up Bali one time. Alright. Alright, let me lock in, guys. Let me lock in. I'll change his head into calculus because we're looking at differentiation and integration. Alright, let me fix up. But yeah, so this was the unit 1 pure maths question we did randomly yesterday. Was fun. Was fun. Similar triangles kind of question. Right, so you know what you seen today? Integration. Tell me guys, integration is a reverse process of
differentiation.
Differentiation.
right. So what are some uses of integration, boy? What are some uses? Let's just say they give us the gradient function, right? Now you should know that the gradient function really is what?
A
What's the
derivative.
gradient? The what derivative? The first derivative, the second derivative, what?
First,
First derivative.
Right, so I could represent the gradient function as dy dx, yeah?
Yes, sir.
You know, or I could say f prime x. That is the gradient function. Now, in the exam, they could give you a gradient function and ask you to find the equation of the curve. So if I have the gradient function and I want to find the equation of the curve, I'm gonna ask you guys this. If I have dy dx and I want to get the equation of the curve, doesn't the equation of the curve look like y is equal to something, yada 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 yada, in terms of x?
yes, sir.
So what would I have to do with dy dx to reverse it to get back y?
Integrated.
Integrate.
Good, integrate it. I'm just going through all the scenarios where integration could come. Obviously, we have definite integration and indefinite integration. We look at indefinite first. Let's look at another important thing of integration. Integration allows us to find area under a
Graph.
right. So take for instance, you had the Cartesian plane here. So which axis is this?
Y.
Y.
Right. Which axis is this?
X.
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 I'm going to draw a random curve. I feel like I could draw a little better, you know. Right, so I have a curve here. This look like a cubic or a quadratic? What do you think?
Cubic.
Cubic.
Yeah, the bad boy, big up on itself. It kind of it kind of hard to see, but you have a maximum here and a minimum here and a point of inflection here. Yeah. Now let's just say I wanted to find the area under the curve bounded by this is x is equal to what? Or would this be x is equal to what?
0.
0.
Yeah, because it's passing through 0, and we could potentially call here x is equal to I don't know. We call x is equal to 1. And we call the function f of x. So here what? And you could see that as a result of me having, by the way, I should say this. You see how we have x is equal to 0? We typically call that the lower bound. And what do you think I'd call x is equal to 1 then?
Upper bound.
Upper.
Upper bound.
And this would be called indefinite integration or definite integration.
Definite.
Definite.
Yeah.
Indefinite.
When you think of definite, don't you think like within a range? Definite.
Yes,
Definite.
sir.
Yes.
Definitely.
Definitely. Definitely. Yeah. So as you could see, we have a curve here given by f of x. We suspect is a cubic. We have the line x is equal to 0, and we have the line x is equal to 1. Can't you see that there's an area bounded by the curve, the lines, and the x-axis?
Yes, sir.
Yes, sir. Yes,
Good.
sir.
So if I wanted to find that area, I would have to integrate f of x with respect to x. And to generalize this statement, I could call x is equal to 0 a, and I could call I could call this what?
B.
I could call this b. Good. So when this is our mass, and so when you're finding the definite integral or the area under a curve, what you want to do is, okay, I have a question. What do you think will go here, the upper bound or the lower bound?
The.
Lower bound.
The.
It kind of intuitive, right? Because isn't this like lower than this one?
Yeah.
Yes, sir.
Well,
It kind of intuitive as well. So this will be the lower bound, and the lower bound will be what? X is equal to what?
0.
0.
What
Wait, I forget about that. I
A.
forget about
is A?
I'm trying to generalize it. I'm trying to generalize the statement. So the lower bound here would really be A, and the upper bound really be what?
B.
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 Good. All right, so you see how we have common f of x? If I using this notation and I integrate, well, it's gonna turn to capital f of x. Then that would be BA, and then that would be f of B minus f of E. Any of you guys learn this in school?
Yes, sir.
Yeah.
Yes.
Yes, sir.
And this is the area I'll find for. Cool. So that is definite integration as well as area on the graph. Let's look at another process where integration is useful. So we could actually use integration to find the what generated. Like, I don't know if I know I'm going with this, but see if you can finish my sentence. The what generated.
Volume.
Volume.
We could use integration to generate volume generated by a rotation of
Y-axis.
360 degrees about the which axis?
Why?
Well, here what, right? When you do tertiary, like higher level maths, you'd realize that you could really use integration to find the volume about the y or the x axis or any intermediate steps. But at this level, we just learn the volume generated by rotation of 360 degrees about the x axis. That's where you typically learn at this level. But when you do higher level maths, if you wanted, here what I'm saying, right, guys? If you wanted at higher level maths, you could technically find the volume created by revolving this around. We could probably call this x is equal to 7. You could do that if you go to pursue maths at a higher level, and you'll see how cool those stuff are. And really, really cool. Maths is really, really cool. And so here's what. To give you a quick explanation, call this y, call this x. Let's consider for a second that we had this function over here, and I graphed the function. And let's call this function f of x. Can we see that it forms a finite area over here? Are you all seeing the area we're talking about?
Yes, sir.
Yes, sir.
So if I take this 2D shape, if I take this 2D shape, right, and I rotate it 360 degrees, what shape would I make?
The same shape.
Nah,
A cone.
a cone. Yes, I'd make a cone. Let me see if I could find a good resource to show you all what I mean. Right? Massacre. Um. Oh, co-host, I'll do all the job now. Don't like wait. Like I see in some people
Yeah.
joining, yeah, and I see y'all not adding them in.
Yes, sir.
Uh,
Then I mean,
all right, screens. Okay, let's see in the screen here. Let's see my screen or not.
Yes, sir.
I'll ask a question, right? What shape is this? What shape
A
is that?
triangle.
Yes.
A triangle.
is a cone, sir?
Is a cone? Is a cone? Is a
Quadrilateral.
cone? A cone. I am seeing. What am I seeing? I'm seeing a cone. I'm seeing a cone. So if you take a triangle and you rotate it 360 degrees about the x-axis, you are going to get
A cone.
you're gonna get a cone. You're gonna get a cone, right? You will get a cone. So by rotating a finite area 360 degrees, you are going to create a volume. Wait, give me a second. Anything? All right, good. You should be able to see my screen once more.
Yes, sir.
Good. So do you all understand that when I rotate this 360 degrees, it's going to create a what kind of shape?
Full rotation or a circle.
Now, Nikolai, just show you.
A
What shape
cone.
is this?
A cone.
Conical
A
shape.
cone. A cone. A cone. This is a cone. Right? This is a cone.
Yeah, but wouldn't it be a circle when you rotate it 360?
It wouldn't just be a circle, Nikolai. Remember, this is a triangle, right? And you're rotating the triangle 360 degrees. Here, the best way for you to understand this is to see like a visual. I need to show you a visual so you'd actually understand what the heck going on. Because like I could describe it to you how much, but if you don't see it, you wouldn't believe it. Looking for a good give me a second. I'm looking for a good interactive example. I'm finding a good resource. Hey, boy. I'm gonna try to share my screen so you could understand, Nikolai. These are all the visual aids I'm seeing here. But this is essentially what's gonna happen. Like if you have a triangle and you rotate it 360 degrees, you're going to create a cone. You will create a cone. I know it's kind of hard to see. Uh, Let me see if I can find a good resource because I look I'm in here to not be confused. I don't want to confuse you guys at all. Okay. I find it. Good. Okay, you will hopefully not be confused after this. Give me a moment. Nikolai, you will be uncooked. So rotating a triangle about right, so Nikolai, ready?
Yes, sir.
All right, guys, this is exactly what's happening, right? Look at this carefully because this is what is happening. Not that. Look at this. Stay with my guys. Watch this. Watch it. Look at it, right? So Nikolai, you can see that's the right angle triangle, right?
Yes, sir.
He's gonna rotate it. He's gonna any minute now. Any minute now. Nikolai, what shape is that?
A cone.
You understand it?
Yes, sir. I was just stating that the fact that the radius when you rotate it 360 degrees, it would have been a circle.
Oh, yeah. It would create a circle, but the full shape would be a cone. That's correct.
Yes,
Would
sir.
be a
But I also understand this, sir.
okay, good. Everybody understood the visual. So let's give a certain summary. Anybody know about tree, blue, one brown hunting?
What?
A tree, blue, one brown, and like number 5. Or like
Mm.
those math people. I
Yes,
forgot
sir,
what
I know is that. I used to watch that.
Okay, nice. Peak, peak.
Well, let me be peak two now.
Oh,
I want to be peak two.
math vibes is peak as well. Don't worry, you're watching peak here. They're fine.
Yeah.
So how, generally speaking, how would we find the volume of this? Well, we typically say that if you want to find the volume, it's going to be pi. And remind me, which goes first, the upper bound or the lower bound?
The upper the
The
upper
upper bound. You can call the upper bound B, and the lower bound would be what?
A.
E. Good. And this would be f of x. What's another way I could represent f of x? Instead of writing f of x, I could write what?
Y.
Y.
And you guys will learn this as well, right? If you want to find the volume, it's pi integral b a y squared dx. Yes or no?
Yes, sir.
Yes, sir.
Okay, cool. If I make any mistakes, you tell me, right? I don't be using any textbooks or anything. Everything I teach is just strictly from my brain. I don't use no textbooks or anything. So if I make a little mistake, you just let me know. I don't think I will make a mistake because I'm confident in my ability. But if I do, you'll let me know. So these are all of the 3 use cases of integration. To find the equation of a curve, to find area under a graph, or to find volume generated by rotating the curve 360 degrees about the x-axis. Does everybody understand the use cases?
Yes, sir.
All right, make sure you
Yes,
have a
sir.
scripture for this. And let me start some questions because you know they're real simple. Yeah, this is hard maths. All right, cool. And I'll move on. Let me integrate some basic things. We're gonna start off with indefinite integration. So So if it's an indefinite integral, do you think there are limits? Do you think there's an upper and a lower bound?
No, sir.
No, sir.
So let me explain something. I'm going to give you all an example of something. Check this out. Consider we originally had a function y is equal to 7x squared plus 9x plus 3. If I were to differentiate this with respect to x, what am I going to get, Tom of us?
14x
14.
plus 9.
14x plus 9.
That's not
Okay. And if I wanted to get back the original function, what's the opposite of differentiation?
Integrate.
Integration. Integration.
Integration quickly. So if I were to integrate dy dx with respect to x,
There'll be 14x
wait,
squared.
on the left hand side, if I integrate dy dx with respect to x, what would I get?
Y.
I would get y
Y.
here. And on the right hand side, if I integrate 14x, remember, you're not seeing it, right? You're not seeing it, but it's understood to be a power 1 here. So when you integrate, you add 1 to the power and then divide by that new number. Isn't that the opposite of differentiation? And in differentiation, they will multiply and then minus 1 from the power.
Yes, sir.
Yes, sir.
Make the connection, guys. It's just the opposite. Right, so add 1 to the power from
X squared.
Squared.
and let me divide by 2 now. Okay. If I integrate 9, what would that be?
X.
Yeah.
Divided
Yeah,
by
let me I don't think you guys know you should probably write what there. If it's indefinite, you should write where. What should you write? You should write.
plus C.
Constant.
Let me leave all the plus C for now and see what happen. Look at Optimus Prime come back. Alright, where's 14 over 2?
7.
7x squared.
X squared.
But there's a problem, guys. And integration supposed to undo differentiation.
Yes, sir.
Yeah. So when we integrate this, we're supposed to get back y is equal to 7x squared plus 9x plus 3, right? We should
So
have,
I
right?
get the 14x plus 9.
No problem. So I'm giving you an example here. So I'm showing you that integration is supposed to undo differentiation. So I would have differentiated this, right? Do you remember how to differentiate?
No.
No? Okay, I have problems. You gotta check out the first live, right? But let me explain it to you quickly. When you're differentiating, you multiply by the power, and then you take away 1 from the power. So what is 2 by 7?
14.
Right? And if I take away 1 from the power, that's going to be 2 minus 1. What's 2 minus 1?
1 would just be x to the power.
14x, right? And if I differentiate 9x, if you apply the same rule, 9 by 1 is 9, then you would minus 1 from the power, So it'd be x to the power 0. Anything to the power 0 is what?
1.
Right. And so just 9 by 1 is 9. And if you differentiate a constant, it's just 0. So
Okay.
if I differentiate this, I'm going to get 14x plus 9. Guys, if you're somebody here and you're coming into integration without knowing differentiation, you might be a little cooked, you know. You might be a little cooked. Yes, my in-depth explanations would help, but you are counting on you to know differentiation, moving into integration.
Just a little cook, sir. Just a little bit.
Hey, I do the whole of differentiation in the two lives, eh? Like the first live, I do 90% of integration. I mean 90% of differentiation. In the second live, I speed through differentiation and do a bunch of past paper practice. And I started integration. So go watch them two lives on it in 2 times speed or something. So okay, when I integrated this, I'm supposed to get back what?
Y.
Y.
Which is y is equal to what?
The
7x squared plus 9x plus 3.
Okay, but something missing though. Something missing. What missing?
That's 3.
The constant.
The constant. So whenever you're doing indefinite integration, you need to put the plus c to cater for any constants that could have been lost in translation. So this solution would actually be plus c. And this would be a general solution. That would be a general solution. If I gave you a point, however, that is on the actual curve, could you then use that information to find for c?
Yes, sir.
Yes, sir.
Yeah, you could have. You could have. So here, what? Anytime you do an indefinite integration, this is the prime reason why you need to put plus c. Because, remind me, guys, if I differentiate a constant, what comes to the constant?
It will be 0.
Will be 0.
It will be 0.
It will cease to exist. So when I integrate it now, will integration cater for that constant term that would have vanished?
Yes, sir.
Yes, sir.
Yes, that's why I put the plus c. That's why I put the plus c. Right? That's why I put the plus c. So you understand what I'm saying, right? That integration is the opposite of differentiation.
Yes, sir.
Yes, sir.
Right. Now let me give you all a quick example of something. So say I give you this point. Say I gave you this point and I told you that the point lies on the curve. So let me just give you a point real quick. Let's just say I give you a point 1, 19, and I said hence find for c. Could anybody tell me how you would do that?
By putting the
Just
x
plug
down.
in
Substitute
X
for
and
X
Y
and
values
Y.
into the function.
Okay, we're cooking, yes. For those of you guys that don't know, if a point lies on a graph, what will it do to the equation of the graph?
It will change it.
Satisfied or
Satisfy, yes. If a point lies on a graph, then it means when you plug in a point, the left-hand side is supposed to be equal to the
right hand side?
good. So if you're confused, could you at least tell me what x or y is over there?
1
X
is
is 1,
X
Y is
is
19.
1 and Y is 19.
Right. And I know what x and y is, so is the only unknown here truly.
C.
C.
So let's do some quick substitution and find the c, right? So I'm telling you that y is 19. Cool. We know x is 1. Let's see what's gonna happen here. So it's gonna be 19. It's gonna be 7. It's gonna be 9. What's 7 plus 9?
16.
If I were to find for c, what would I do?
Subtract the 9. The 16.
So c would be equal to 19. And this is I move across the 16, so minus 16. The 19 minus 16. 19 minus 16 is what?
3.
Oh, whoa. We see that somewhere. Wait, watch. Let's see it.
Yes, sir.
Yeah. So if they give you the gradient function and they give you a point that was on the original curve, you're going to integrate to find y. But remember, that'll be a generalized solution. But you need to find a specific value for c, so you'll plug in a point, and that would help you find for c. So here what, guys? Now that I know what c is, what would my final equation look like?
It will be the 7x squared plus 9x plus c.
Remember,
Plus
what is
2.
plus 3? Good. Remember? This is what we got from integration, but does integration directly cater for, if you leave out the C, right? Does integration directly cater for any missing constants that would have been lost in translation?
No.
No, it doesn't. To cater for that, you put a plus C and you look for a point on the graph. You plug that in and then you solve for C. That's the concept. Yeah, cool. Are you guys okay with this basic? Well, I don't want to say basic because I know some people will struggle with it, and that's fine. You're here to learn. But the point is, guys, if I'm given the gradient function, what can I use to get back the original function?
Differentiation.
Differentiation or integration? If I'm given the gradient function, what will I use to get the original function?
Differentiate.
No, guys,
Integrate.
integration.
Integrate.
Isn't the gradient function dy dx?
Ah, yes.
Yes, sir.
Yes, sir.
Don't forget that, guys. Remember, dy dx literally means change in y over change in x, which is literally the definition of gradient. So dy dx is a gradient function. So to get back y, I'll have to integrate. But anyways, this was just a practical example of integration. Let me do some quick indefinite integrals. Okay. Let's just say we wanted to integrate something like x to the power 4 with respect to x. Remind me, when I'm integrating, what am I doing to my power?
Add in 1.
Add in 1, sir.
And then to the denominator.
And then I would divide by?
In
New power.
denominator, which is the
Power.
power.
Right. And remind me, integration is a reverse process of differentiation, but we must always cater for, we always have to cater for what?
The constant, which is c.
Yes, we must always cater for any constants that will be lost. You know what I mean? So we always put plus C. If you don't have bounds. Are you guys seeing a upper are you guys seeing a lower and upper bound?
Yes, sir.
No, sir.
No,
Oh,
we're
no,
not
no,
seeing-
no.
No, we're not seeing that. If you're not seeing that pressure in the camper, you have to put the plus C. To cater for any constants that would be lost. Okay, so you're gonna end up with x to the power 5 all over 5 plus C. Are you okay with this example?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Let's just say we had to integrate something, just 7. What do you think that would be? If I integrate 7.
7x plus c.
Yeah, that would just be 7x plus C. If you don't understand it, right, here's a way you could understand it. Now, 7 is the same thing as 7 multiplied by x to what power?
1.
Nah, no 1.
Oh, 0.
Zero.
And if you're confused, remind me, guys, x to the power 0 is what? Where's x to the power 0? X to the power
That would be 1.
1.
1. Correct. X to the power 0 is 1. And 7 by 1 is?
7.
7. So wait. I feel like somehow you're confused, which is fine, but I need to rectify that. So does everybody understand that 7 is the same thing as 7 by 1?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes, sir.
And what's another way I could represent 1 in terms of x?
X to the
X.
0.
X is 0. 0.
Good. So 7 is the same thing as 7x to the power 0. And so now we're trying to figure out what would the integral of this be. So when you're integrating, what do you do with the power?
Yeah, add on to the
Add
power.
1.
Right, we add 1. And so if I add 1 to 0, then that's going to turn to what?
7x.
7x to the 1.
So, power.
And I would
Or
divide
just
by?
By 1.
1.
What would that be, guys? What would that be?
7x.
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 So I probably understand. But we don't do all of that, right? Like generally speaking, if I'm integrating a constant, I just slap on the variable to it. That's all. That's all. So let me give you a slightly different example. Consider you had 9d theta. If I integrate 9d theta, what will I do? What will I do there?
9 theta plus
9
plus
theta plus c.
Exactly, 9 theta plus c. Good. Are you all okay with the basics so far?
Yes,
Yeah,
sir.
sure.
Yes, sir.
Even if you not understanding, that's fine, you know. It have people it have a good bit more people in class than before, which is good. Happy to see the numbers increasing. But just because somebody understand, I don't mean you understand it. And you don't have to feel shame about that. I would hate for somebody to leave here not understanding because they were scared to ask. Are they okay, right?
Yes, sir.
Yes,
So
sir.
I just have one thing, right? The
Sure.
X representing the one, that is why it there.
In which example?
Like when you say 7, and you put the brackets and you say 1, and then you say how another way to show that is x to the power 0, and then you add the 1. Is it that x represented the 1?
Well, x to the power 0 is 1. And let me show you something, right? Let me show you something. Because, like, it might be like, oh, so, how? Bro, what are you talking about? You know what I mean? Where the guy was like, bro, what are you talking about? Probably how you're thinking. Let me show you something, right? So, Mariana, a to the power 0, where's that?
1.
Right. 9 to the power 0, what's that?
1.
Okay, let me try minus 2.50 madness. To the power 0 is?
1.
So, Mariana, anything to the power 0 is?
1.
So, x to the power 0 is?
1.
Good. So this is the same thing as 7 by 1, which is the same thing as 7 by x to the power 0. No, x does not represent 1. What does represent 1 is something raised to the power 0. So the x to the power 0 is what actually represents 1, right, Mariana?
Okay.
You probably don't understand why that is the case, right? I should probably clarify that. Mariana, you know why something to the power 0 is 1?
No.
Now you just started to memorize it. Let me show you something, right? Consider I had this example here. You had 9 by 9 by 9 by 9 all over 9 by 9. What would happen there, Mariana?
2 of them will cancel on the top and on the bottom.
Yeah,
No.
and you're gonna put 9 to what power?
2 squared. So,
9 squared, right? Now, question. On the top you had 9 by 9 by 9 by 9. That's 9 to what power?
9 to the power 4.
And then you were dividing that by
9 squared.
And you realize the final answer was just 9 squared. So what do you think I would have done with the powers then?
Subtract.
Right? So
Receive.
and like that's a short way to get the answer as well. Let's see if this rule holds for another example. So like let's just say 5 by 5 by 5 by 5 by 5 madness. They were madness, but we're good. 5. Right. So Mariana, before we do anything, right? On top, you see how much 5s?
5.
5. So that'll be 5 to what power?
5.
And I'm dividing that by.
5 to the power 3.
So what my answer supposed to be?
5 squared.
Good. And if you do the long way, you'd see that, that makes sense because 3 of the 5s in the bottom would cancel off with 3 on top. And that would leave you with 5 to what power?
5 squared.
Good. So generally speaking, Mariana, we can make a general rule. Anytime you have the same base and you're dividing, what do you do with the powers?
We subtract it. Yeah.
And you understand this logically, right? None of memorization or anything, but like you actually understand it, right?
Yeah, it's like basically you're taking out the, like you wouldn't count something twice, so you just take it out.
So
If
like
that makes
yeah, so like whatever in the denominator that would cancel off with what was on the top, effectively
sense.
subtracting, effectively taking it away. Yeah.
Yeah.
Now Mariana, let me cook, right? Let me cook. If I just had 9 by itself, right, then that would be 9 to what power? Okay, you're probably
One?
confused, right? Yeah, 9 to the power 1, right? If you had 9 by 9, that would be 9 to what power?
That's 2, 90 squared.
Good. So if I just had 9 by itself, that would be 9 to what power?
1.
Exactly. So if I had something like 9 to the power 1 all over 9 to the power 1, what you know the answer gonna be? Before you even do anything, what you know the answer gonna be? What's 9 over 9?
1?
Yeah. And if you use the rule we just come up with, anytime, isn't this 9 to the power 1 divided by 9 to the power 1?
Mm-hmm.
And we know the answer will be what? We know the answer will be what?
I
Oh, we
think
know
it's
the
a
answer.
trick question.
It's not, no, I don't try to trick nobody. What we know the answer is.
1.
We know the answer is 1. But if we use the rule we just come up with, or I just show you, anytime you divide in and you have the same base, what do you do with the powers?
We subtract.
So in other words, 9 divided by 9 means the same thing as 9 to the power 1 minus,
1.
which is 9 to what power?
0.
Which we know is,
1. Oh,
yeah.
anything. Oh,
And I could show you another example first. Consider I had 8 to the power 9 all over 8 to the power 9, right?
Mhm.
We know the answer gonna be. You have 8 to the power 9 divided by 8 to the power 9. What the answer gonna be?
1.
It gonna be 1 for sure, right? 1 for sure.
Mhm.
And if you use the rule you just now learned, then this would have to be equal to 8 to the power 9 minus what?
9.
Which is 8 to what power?
0.
Which is, in fact, 1.
It equals. Okay. Okay.
So anytime you see something to the power 0, what it really means, okay, so you see how I say 9 to the power 0 here? What I really mean, that really means 9 over 9. That's what it means. If I see 7 to the power 0, what does that really mean?
7 over 7.
Exactly.
Or
So
1.
anything exactly. So if I say x to the power 0, what I really mean?
X over X.
And x over x is?
1.
Damn.
Okay.
Big up yourself. Vibes. You understand? You understand?
Yes, sir.
And I have another way you could see it that I think is easier for students. Here's a quick way to visualize it. Imagine I had 27, I had 3, I had 9, and I had 3, right? To go from 3 to 9, I would have had to multiply 3 by what?
3.
To go from 9 to 27, I gotta multiply by what?
3.
So understand something. Over here, doesn't this represent 3 to the power 1?
Mm-hmm.
What does 9 represent? 3 to what power?
Squared.
And 27, what does that represent?
Cube. 3 cube.
Good, you with me so far?
Mm-hmm.
So here what? If I wanted to go from 27 to 9, instead of multiplying by 3, what I go do?
Divide.
If I wanted to go from 9 to 3, what I go do?
Divide again.
So if I wanted to go to the next thing before this, I would do what?
Divide again. Again,
Where's 3, where's 3 over 3?
1.
And if you're following the pattern, 3, 2, 1, what was after? I mean, what was before 1? If you're following the pattern, watch. 3, 2, 1. What should come here?
0. Oh, 0.
So 3 to the power 0 is?
1.
Yeah. So anything to the power 0 is?
1.
Good. Anything to the power 0 is in
Have
fact
it.
1. Nice. So don't get confused, right? Oh, x does not represent 1. What does represent 1 is the fact that x is raised to what power?
0.
Good. But you know how to do all of that, eh? Like if you see the integral of a constant, just slap on the variable and then your GT and get through there. Alright, so let me look at a combined example quickly. So let's just say the integral of 9x squared plus 7x and to the power just 7x plus 5 dx. Alright. This is not a specific paper. I just drilling the concept here. But all of this could come in the exam. So Mariana, let me see if you fully understand integration. So when you're integrating, what are you gonna do to your power? What are you gonna do to your power?
We add in 1 and dividing by the new in the C.
Good. So we're gonna add 1 to this. So that new power will become what?
9x cubed over 3.
Yeah, 9x cubed over 3. Good. And then we're gonna integrate 7x. What would that be?
7x squared over 2.
Okay, if anybody is confused in the slightest, you're not seeing it right, but this is understood to be raised to what power?
0. No, 1, 1, 1.
Oh, Nicolai, you me scared there, no? You're a little scared there. little. Un poquito. Yeah. And so if I add 1 to that, that'll be 2, and I'll divide by 2. Mariana, tell me, if I integrate 5, what would that be?
5x.
Yeah, that'll be 5x. And since it doesn't have a lower or upper bound, this is indefinite integration, so I add c. I have to say add c. What is 9 over 3?
3x
9 over 3,
cubed.
right?
No.
3.
Oh.
And well, let's just be 7 over 2. I feel like I'm okay with the basic premise of integration chat.
Yes, sir.
I now realize I'm not seeing YouTube people. I don't even think you have people on YouTube. Let me check. Let me check the YouTube live, see what's going on there. Oh, we have 23 people watch it.
Yeah,
That's
have
more than
22 people, sir.
I said that again.
I was going to tell you, have 22.
That's surprising. More than I thought. Watch out, the numbers gonna be insane night before the exam. But when I was doing this leading up to the exam, I had like a little bit of people. Then suddenly, before the exam, it gonna be a ridiculous amount of people. People interested in it. When you had the time, you gotta take the time to fully understand the thing. You can't just expect to learn the whole thing night before. You know what I mean?
Sir.
Somebody should record me and like make a clip. And I'll go play it for them when I have real people and they join in and they asking the question and thing. Yeah, but anyways. Cool. Let's look at some harder ones to integrate. Let's say we want to integrate sine x. If I integrate sine x with respect to x, what am I going to get?
Minus
Negative.
Minus cos x.
Some of you guys might be confused. So, how you know that? You pull out that from a rabbit hat? From a magic hat? No, I did not. Let me explain something, guys. Remind me, if I were to differentiate cosine x, what would I get? If I differentiate cosine x, what would I get?
Minus sin x.
Minus sine.
Okay, if I multiply both sides by -1, what would I get?
Minus cos x. Positive sin x.
So I have a question then, only I have a question. If I were to integrate sine x, what would I get?
Minus cos x.
Yes, which is what this says. Because, again, integration is the reverse process of
Differentiation.
differentiation, yeah? Okay, I put the fish at the first. I will figure out something. Like, what's your idea today? Sure, no, I watch Chinese food, are there?
Yeah, no.
Nah, good, sir. My belly done full already.
So I would roast the fish.
You want the fish?
Yeah.
I'll get the fish, sir.
All
Alright. Okay, so let's look at the other one that you need to know. If I integrate cosine x, what am I going to get?
Sin x plus c.
Plus c, yeah.
And if you think I just pull out this magically, no, I did not. Remind me, if I differentiate sine x, what am I going to get?
Cos x.
Minus cos x.
I'm going to get cosine x. So if I integrate cosine x, what would I get?
Minus. Minus sin x.
Somebody
Minus.
say minus sine x now. What if I integrate cosine x?
Yeah.
I just get
Just
sine
like-
x.
Yeah.
Yeah. So what's showing you here is like the reason also how it works, right? But I could just memorize this. It's fine. So if I integrate sine x, I'm going to get.
Minus cos
Minus
x.
cos
If I integrate cosine x, I'll get.
Sin x.
minus
Good. What's gonna happen now if I have to integrate something like sine ax dx? Wait, before we continue, I want to just bring you guys' attention back to differentiation, right? Imagine I had to differentiate let me run through the rules for differentiation, right? So say I had to differentiate sine 5x. Anybody remember how I would differentiate this using a shortcut?
Yeah, but
It'll be 5 sine 5 cos 5x.
Yeah, I remember that. So you would differentiate the inner function, you differentiate 5x, put that on the outside. Then you differentiate sine. If I differentiate sine, I'll get cosine. And you write back the inner function. So 5 cosine 5x. So I have a question for you guys. I have a question. If I wanted to do the reverse process, I wanted to integrate. How would I reverse this to get back sine 5x? Could any of y'all think about how we could do that?
So can you just repeat the question?
Could anybody tell me how I would reverse this to get back sine 5x?
integrate.
I would have to integrate. So,
Integrate, yeah.
Christopher, could you tell me as to what I would have to do here to get back sine 5x?
So you would just integrate 5 cos 5x, but it would cause it to divide since it's the opposite.
So I divide by
Yeah.
5. I would divide by 5.
divide by 5.
And I would change cosine to?
Sine.
Good, I'll change it to sine. Nice. Cool. If I don't understand that, I'm gonna call on somebody here. Maya. If you have 5 cosine 5x, right? And I want to get back sine 5x, what would I have to do with this to get back sine 5x?
Divide by 5.
I gotta do that for sure, right? And I gotta do what? What next?
Integrate cos 5x.
Yes. Big up yourself, Maya. I would have to integrate cosine. If I integrate cosine, I'll get
Sin 5x.
yes. I'll just sine. Yeah. Hey boy, I'm learning boy. Big up on yourself. So here what happening, right? If I want to integrate sine ax, it's a very similar process to this. Real similar. But here what I'm saying. Here's what's gonna happen, right? I'm going to write the answer on the screen for you guys, and then you all will help me with the next one. So I'll say negative 1 over a what?
Cos yeah.
Cos x.
Right, plus c. And okay, so somebody help me with this one. If I want to find the integral of cosine ax dx, does anybody have any suggestions?
That would be 1 upon a sine ax plus c.
Yep. Are they okay with this or not?
Understood.
So you can actually like go over it again, please.
All right, so Nasya, stay with me, right? Stay with me. All
Okay.
right, let me go through the basics first, right? If I integrate sine x with respect to x, what will I get?
Negative cosine x.
So what I'm saying is if you integrate sine ax, it's going to be really similar. It's really going to be similar. So here what I'm saying. I'm going to show you 2 ways. Here what I'm saying, right? You're going to put back the negative. You're going to, if you integrate sine, what I would turn to? If you integrate sine, what would it turn to?
It'll be negative cosine.
Right, so I have the negative already, so that'll be cosine. And
Yeah.
I'll write back the ax. But here's the only difference. You're gonna differentiate the inside. What's the inside?
Ax.
If you differentiate that, what you get?
A.
A. And I will divide by that. So it'll be minus cosine ax over a. can you agree that that's the exact same thing as minus 1 over a cosine ax or nah?
Yeah.
It's the exact same thing. Exact same thing.
Yes.
So when you integrate, it come like almost the same thing, you know. It come like almost the same thing. The only difference is I'm going to write minus cosine ax and I'm going to divide by what?
A.
Yeah, that's all. Which is the same thing as what?
Negative 1 over A by cosine x. AX plus
Good.
C.
Good. Yeah, you're fine,
I think so.
right? But we typically just write minus 1 over a cosine ax.
Okay, thanks,
And
sir.
no problem. And if I integrate cosine x with respect to x, what would that be?
Sine x. No, wait, so yeah, sine x plus C.
So if I have to integrate something like cosine ax, it's going to be very similar. It's going to be very similar. So you tell me what you think it's going to be.
1 over A cosine A, sine AX plus C.
Yep, that's it.
Okay, cool.
You have it?
Yeah.
Okay. If somebody don't have it, just talk to me now, you know. I will go over the thing and make sure you understand it. But these things are most those things you have to remember. But understanding the intuition behind it is good. Are you guys ready to move on or nah? Talk to me.
Yes, sir.
I only hear like one person. I need more people to tell
Yes,
me.
sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, good. Cool. So please, if you had to take a screenshot, please do so. I feel like I should group it accordingly. So like, give me a second. Let me just group this thing. So I'll just put the sines together and I'll put the cosines together. Alright, so let's take a screenshot of this. You have to remember that.
Yes, sir.
Okay, let's move on to another case. You would have to learn how to integrate. So I have a question. Again, we know that integration is a reverse process of differentiation. So a lot of the times, if you know how to differentiate, you can think backwards, you can reverse engineer it to figure out how you would integrate. So I have a question, right, guys? Consider I had something like y is equal to x plus 1 to the power 9, right? Consider I had something like that. How would you typically differentiate this using a shortcut?
It will be
Put the power 9 as you
derivative
the
of
power
the inside, so it will be 1 by the original function.
So what power, Nikolai?
8.
8. 8. So I'll stay with me, right? Again, I'll get fed up saying this. The integration is a reverse process. So Nikolai, if I wanted to go from here back to here, what would I do?
Add 1 to the power and divide.
Exactly. Earlier, big up W's in the chat for Nikolai, boy. W's in the chat for Nikolai. I'll understand what Nikolai say, right? If I want to go from here back to the original thing, wouldn't I have to add 1 to the power? If I add 1 to the power, 8 is going to turn to what? 8 is going to turn to what?
9.
And if I divide by 9, what's going to cancel off?
The 9 on the top and the underneath.
And we're going to end up with
The x plus 1 to the power 9.
bam. Bam. So a lot of these things are you could figure out in the exam, you know. If you forget, you could just look at differentiation and work backwards. So that brings me to the second rule. One of the other rules you need to remember. If I have to integrate something in the form ax plus b to the power n dx. Remind me, Nikolai, what am I doing? What am I going to do there? It's the same thing I just tell me, you know. Same thing I just tell me. I had to add 1 to the power and
Divide by the power. Well,
exactly so.
when you add the power.
So what would I write here? Tell me.
You put ax plus b n plus 1 divided by n plus 1.
Big up your whole self, Nikolai. Plus C. Don't forget the plus C. All right.
Yeah.
I know for a fact a lot of you guys before this would have just have to memorize this. But now that you could work backwards, if you forget it, you could kind of figure it out in the exam. So I'll go through the reverse engineering one more time. Because reverse engineering is good. Have anybody here that willing to understand anything? I will take the time to explain it back to you. Nobody willing to learn anything?
I wouldn't mind.
Yes, sir.
But Nikolai already figured it out though. Nikolai already figured it out.
I go.
Alright, so Mikhail, here what I'm saying, right, Mikhail? Consider you have something like y is equal to 7x plus 8 to the power 9, right? How would you differentiate this using the shortcut of the chain rule?
I would multiply by the power, so it'll be 9 in front of bracket. The derivative from the bracket would be 7. And then I would multiply by the original function.
Also, Nikolai, you forget something here. We had better. This was to be a by n plus
Yeah.
1. Yeah. So Nikolai, you can see what I mean. So Mikhail will run it, right? So it'll be 9 by 7, and then by 7x plus 8 to what power?
8.
8. And then 9 by 7. We can leave it like that. We can leave it like that, right? So here what? Here what, right, Mikhail? Mikhail. Integration is supposed to undo what?
Differentiation.
So here's what I'm saying. How would you go from here back to here?
I would add 1 to the power and divide by it.
So you'd have to add 1 to the power, so that would turn to 9. But remember, you have 9 by 7, right? So you go put 9 in the bottom. What else you had to put?
By 7.
And that will give you the original thing.
Yeah.
So, Mikhail, let me apply that to this process. So if I had something like ax plus b to the power n, the first thing I had to do what to the power?
Add 1 to the power.
Right? Put it over here, and then you're going to multiply by?
The power that you added 1 to.
You're going to multiply a by that.
Oh, yeah.
Yeah, because okay, watch this again, right, Nikolai? Watch this again. I'm not saying Nikolai, Mikhail. Watch this again. If I had to integrate 9 by 7, 7x plus 8 to the power 8, what do I know I'm supposed to get back? What am I supposed to get back, Mikhail?
7x plus 8 to the power 9.
I'm supposed to get that back, right? I'm supposed to. So wouldn't we first, number one, or we'd have to do what to the power?
You have to add 1 to it.
Right? And then I would divide by?
The power and by 7.
Good. And that would cancel this off to give me back the original thing, 7x plus 8 to the power 9.
Yes, sir.
So you understand how we come up with a rule then? It's
Yeah,
ax
sir.
plus b, you add 1 to the power, so I say n plus 1, and then over a by n plus 1, which is the same thing you did over here. Is that not what you did? You said 7 by 9.
Oh, yes, sir. The n plus 1 would be the 9. Yeah, yeah.
Right, so if you're cooking?
Yes, sir.
Bet. Ladies, are you understand or not?
Yes, sir.
Alright, Nasia, you understand the reverse engineering or not?
So, yeah, I think you lose more like 2 minutes ago.
Okay, you know about you go with differentiation.
Are good enough?
You remember the shortcut version of the chain rule?
No.
You're not good enough then. You need to know, you need to go back and hit the books for differentiation. Right? Let me explain it. So how does the shorthand version of the chain rule look like? How does it look like? Well, the first thing you gotta do, you gotta take the power, you gotta multiply. So you see I say 9. So you see I put the 9 outside?
Mm-hmm.
Then we're gonna differentiate the inside. If I differentiate the inside, what are we gonna turn to?
That would just be 7.
Right? 9 by 7. And then we're gonna write back the original thing, and we're gonna do what's with the power.
Subtract 1.
Good. So here what I'm telling you, Nasia. Integration supposed to undo what?
Differentiation.
So I think okay, I have this, but I want to work back to this. How are you doing that? How are you doing that? That's the
Good
question.
question. Good question.
Well, we could start off in a real simple place, right? We could start off in a real simple place. What's the difference between the powers?
1.
So what could add to the power?
Yeah, add 1.
Okay, good. I could add 1. And then in the denominator, I could say 8 plus 1. That's 9, right? It would cancel off with what on top,
D9.
right? And I also had a cancel off what?
D7.
Right? And we're getting a 7. Look over here. We're getting a 7.
The coefficient of x.
Yeah. Yeah. Isn't that okay? Watch. So I'm telling you, if you integrate ax plus b to the power n, all it's going to be is going to be ax plus b to the power n plus 1 all over a by n plus 1. Which isn't that what we come up with over here? I feel like you're probably not seeing it, but it's there, it's there, it's there.
I think I understand. I don't know. I might have to go back to the chain rule. I know the chain rule, I don't know the shortcut.
Okay.
Yeah.
But like watch it again, right? If I want to undo this, for sure I have to do what to the power?
Yeah, add 1 because is the opposite of differentiation. And
Right?
differentiation, subtract 1.
And then I will say 8 plus 1. I will divide by 8 plus 1, which is 9. Cancel off there.
Mm-hmm.
And then I'll multiply by what's in the bottom.
Well, the other number that being multiplied, so 7.
Which comes from what? If you're comparing it, right? Ax plus b. Then where's a?
A is the 7.
Right. So I say, so in the denominator, aren't I essentially saying n plus 1, which is the power plus 1, multiplied by a?
Yes.
Right. So that's why I say in the rule is, okay, watch, right? So the first thing I have to do is what to do to the power?
Yeah, add 1.
I add 1 to the power. Yes, I add 1 to the power. And then in the denominator, and we had to put that down there as well.
Mm-hmm.
And then I gotta multiply that by
By A.
which is the coefficient of
X.
good. Yeah.
Okay, I got you. I got you.
Okay, good. In ad maths, if you don't talk to me, you're gonna get lost, and you're gonna get lost, you're gonna get left behind. You have to talk to me. Okay. Anybody else want me to explain it back to them? The reverse process?
One question, sir. I saw we had the 9 times the 7, right? If you multiply that, but you didn't multiply like the underneath as well. Okay, no, let me explain that properly. So you see like how you had the 9 plus the 9 times 7, right? But then you have the 7 times 9 on the underneath.
Yeah.
Right. If you did multiply the 9 times 7, which is 63, right? But you didn't multiply the 7 by the 9 because you add 1 to the power and you divide by the power, right? That would be wrong.
No, from what I understand, I think that would be correct because I mean, watch 9 by 7 is 63 here, and this will work out to be what?
No, you're not multiplying the 7 by the 9.
Well, yeah, how do I multiply the 7 by the 9?
Right, that was my question. Like, if you didn't know that you were supposed to multiply the 7 by the 9, but you
Yeah,
only okay,
but you only know what?
the adding 1 to the power and dividing it.
Well, it will work out either way, you know, Nikolai. It will work out either way because in the calculator, if you do okay, in the calculator, Nikolai, if you put 9 by 7 over 7 by 9, we calculator will tell you.
1. But no,
What?
what I'm trying to
Yeah.
say is that you didn't multiply the 7 by the 9 by the denominator. You just left 9.
Oh, that wrong for sure. That's definitely wrong. That's definitely wrong. Because I wouldn't undo the thing completely. Nikolai, if you only had 9 there, would it fully undo? Would you get back the original thing?
Let's say you'd have this, when you divide the 9 by the 63, you get 7.
Yeah, we can't have that, so that would be wrong. Right?
Yes,
Yeah,
sir.
so I went through all of the rules you need to remember. So let's just do a quick recap over them, right? So, remind me, what is the integral of sine x?
Minus cos x plus c.
Everybody with me? Minus cosine x plus c.
Yes, sir.
Yes,
Yes,
sir.
sir.
If I
Yes.
integrate sine ax dx, gonna be similar. A bit different though, but very similar. What would that be?
Minus 1 over a
1 over negative 1 over a cos x.
cos x
Cos
ax
x. Cos x or cos ax?
cos ax
Oh,
plus c
right. What is the integral of cosine x?
sin x plus c.
Right. Somebody else. What's the integral of cos ax dx?
1 over
1
a.
over a
1 over a
sine ax
sin ax
sine ax plus c.
plus c.
Yes. Right. Please remember this. Please. I am very doubtful this is going to come, but in the off chance it does come, you should know it. What is the integral of 1 over x? Does anybody know what the integral of 1 over x with respect to x is?
Is that a natural log? A
Yeah,
natural
that'll
log
be
of
the,
x plus c.
that'll be the natural log.
So what?
Did any of you guys learn this in school? I don't think it.
No.
No, sir.
No.
Never
No,
seen that
sir.
before.
No, sir.
What is
Hold on.
No, sir.
I don't think. Let me just verify if it's on the syllabus, but CXE moving kind of sus.
Wouldn't they ask a
Yes,
question with the integral of the square root of a
Sir,
number?
just ask ChatGPT if it'll come.
Yeah,
Oh,
but
yeah.
sir,
Alright.
my question
Somebody
is,
asked. Yeah, Nikolai?
wouldn't they ask the integral of the square root of a number, like square root of x plus 7 or x plus 9 or something like that?
Yeah, they could do that.
Okay.
But that way just tell me just now, like literally way just tell me, right? Like way just tell me just now, right?
Yeah.
That's this rule over here. Watch. If they ask me the square root of 9x plus 7, isn't that the same thing as 9x plus 7 to the power a half?
Yes, sir.
Isn't that in this form?
Yeah. Oh, yeah.
Where's A? Tell me fast, where's A?
9,
Where's B?
7,
Where's N?
the half.
Exactly. Right? That's on that form.
All right. I was just remembering all the stuff that they could ask, seeing that they going a new route.
No problem.
But they could ask you for the root of a negative number to be imaginary.
Yeah, discriminant. They go ask you the discriminants. That's in a different section, though. But they could ask you that. But they wouldn't ask you to calculate it because you don't know imaginary and complex numbers at this level. I'm not seeing anything that would be against it. But it's not hard. Okay, look this in over here. Yeah, this is what they want. This is what they want. I'm not really seeing that. But in the off chance it does come, well, I mean, it's not hard, guys. It's not hard. The integral of 1 over x is just ln x. And ln is just the natural log function. That's like log base e. That's log base e. Right? So if I integrate 1 over x, so what?
So I
What?
think
Let me
my
show.
teacher would say that teacher said that there's a modulus of like x.
Good. Is the modulus of x? Because you guys will remember, can you find the log of a negative number?
No.
No,
No,
sir.
No, sir.
No. If you're all good with logs, you'll remember that the log function, it tries to find the power you could raise a number to get the argument. Is there a power is there any power you could get that would give you a negative number?
No, sir.
No, sir.
No.
Sir.
Over here, if you're confused, right? Something to the power of 0 get what?
No
One.
one.
Right. Something to the power of a whole number. That'll give you a bigger number. Right? A fractional number would give you a root. A root is some power. Negative powers give fractions. Would any power ever give you a negative number?
No, sir.
No,
No,
sir.
so you can't find log of a negative number. So that's why you would see the modulus of x written here to indicate that, okay, let me give you an example of what modulus means, right? So like if I put modulus of minus 7, then the calculator will see that as just 7. Yeah? Just see just 7. If you see modulus of minus 15, that would you would interpret that as just what?
15.
Just
15.
15. Yeah. And I hope you understand why it's important when you're writing log functions, because you can't find the log of
A negative number.
exactly. So in the off chance it does come, let me look it right in the hard integral of 1 over x ln x. I see Maya raise her hand. Maya, talk to me.
Sir, I don't understand the get us now say.
This is one of the known integrals, like a known integral. It could prove it, but it would be a bit beyond the level to prove. Yeah. The integral of 1 over x is ln x. Yeah, see Nikolai talking to me. Let me see what you say, Nikolai.
I don't know what topic that is, but I realize that has given me some problems. And I know we didn't add much, but I feel like that's skipping ahead of time.
That's
Because
not a
we
problem.
did education.
Nikolai, that's like a maths question. They're just asking you for the pointer intersection. If I take two functions and I put them equal to each other, then I want to know what value. Like I essentially asking you to solve the system of equations. So I'm looking for the pointer intersection, Nikolai. Anytime you put one function equal to another function, I'm looking for the pointer intersection between the two graphs. That's what it means. So if you draw the graph and all you're doing is looking for the pointer intersection, that's all. And I'm thinking that's 2025. The question above that would have been to draw the graph. You're just looking for the pointer intersection. I think the solution was like pi over 8 or something. Or something so. Something so. But anyways, these are the known integrals I need to remember. So if I integrate sine x, what would that be?
Cos x.
Negative cos x.
If I integrate sine ax, what would that be?
Minus 1 upon a cos ax plus c.
Right? If I integrate cos x, what would that be?
That'll be sin x plus c.
Right? If you integrate cosine ax, what would that be?
1 upon a sin ax plus c.
Right? And I'll put a little asterisk by this. I don't think will come, but just for you guys to know, right? I mean, you're gonna be seeing it at anyways if you do, 1 pure maths. So the integral of 1 over x dx is ln x plus c. All right. Cool. And well, the other one that you should know is the integral of ex plus b to the power n is what? Mariana, what is the integral of ax plus b to the power n?
It'd be n plus 1. Wait, no, ax plus b, n, close bracket, n plus 1 over the new, no, a multiplied by n plus 1.
Good. I thought I'd catch you lacking, but big up yourself. W's in the chat for Mariana. Right. So are they good?
Yes,
Is
sir.
that-
Yes, sir.
So we essentially have everything down for definite integration. So let's do a bunch of questions now. These are the list of ones you need to remember. So I don't know if you want to take a screenshot or something, but go ahead. Everybody here, are there? I did have some people here that wasn't that see the ad mats on the lives and enjoyed. How much of you guys were in that population?
So me.
Me, sir.
I was one.
Okay, are you ever come to any lives or anything before? Like, I don't know about one now.
Yes. Well, you see the graphic that they post, the big tree?
The big. Oh yeah.
Yeah.
I saw edit. And
Oh
I was
yeah,
like,
yeah.
I also saw everybody with a blanket on their head.
Ah, yeah, Nikolai and Romano. Yeah. I'm a blanket right here, right here. Yeah. Math Vibes is the future, guys. I'll hear about Math Vibes a lot more often in the near future. And we on our rise. We're on the up. We're on up. We're in
So
a
maybe
positive
you'll
gradient.
become like a whole company and you'll need tutors, and your old students will be your tutors and thing. You
Hey,
know?
I already find people that go and start to teach maths when I get older now. Like I already find people that qualify that I see that real good. Big up Sarah one time.
So you're done saying you're old already, sir?
Well, I still like when I get older now, like 60, 70 and I'm pushing. I don't think
That's
I'll have that
the
energy
that's
anymore,
not
you know what I mean?
cost.
Yeah. I need to find qualified people that share the same energy and patience and thing. You know what I mean? Alright, so cool. Let's do some questions. So let me tackle this one now, 2023. Light work stuff, light work, people. Who wanna help me with this question?
Yes, I don't mind.
Alright, bet.
I see Christopher, Mickey, Mike. I keep going. Let Christopher go.
Boy,
Oh,
Christopher,
nah, bro.
Christopher got this thing. Christopher gonna get distinction in odd maths anyways. What you have to me head for? I don't know Christopher gonna get distinction in odd maths.
You
Yes,
sure, sir?
Christopher is literally Jinwoo right now. Solo in odd maths. Solo leveling.
Oh, so you watch anime?
Yes, I watched solo leveling like 3 times with my partner, boy. Hey, solo leveling is
3
peak, boy.
times, sir?
Eh?
3 times, sir?
Yeah, boy. Tivon did come by me Christmas. We real watch solo leveling though. Hey, that was real vibes. Yeah, boy. Hey, it's how we mash up the
Yeah,
thing.
baby, right?
Like
That fight scene was just wild. I think I watched it about like 6 times.
yeah, boy, that fight cool, boy. Hey. And like the other fight, the other hunter from Japan just get like one tapped.
Yeah.
Man just get one tapped. Anyways, yeah, yeah. I'm young, you know. I just watch real anime and thing, you know, One Piece and all that.
So I never say no, but the amount of times, sir? Like
It,
somebody still watch it 6 times, sir?
nah, Nikolai, if you watch Solo Leveling, you understand what I mean. You understand Solo
That
Leveling is
fight
peak,
scene was
boy.
epic.
So I
That
could do
fight
that
scene was
after
epic.
CSEC. So I could do that after CSEC. Right now I
Uh,
had a good
I can believe I watched the whole of One Piece in Form 4.
Form 4. And
Yeah,
you
boy.
are CSEC coming. So you are CSEC coming and you're watching One Piece, sir?
Nikolai, to be fair, the only thing I didn't get distinction in is Spanish, and I did 10 subjects.
So you make them feel bad.
Hey, that is not to say I didn't work hard. I work real hard and I make sure I understand everything. Like you see how I reverse engineering stuff and thing. I teach another. I try to transfer my skills to you guys. Literally, this is what I would do if I forget things in the exam, and that's how I do so good because I understand. I understand the whole concept now. Not just like the formula and thing. I understand the thing actually. If you guys actually understand the thing, you could achieve the same performance. It's not without reach. But if you guys just memorize the formulas and you're moving like the average student, well, you would expect average results. You gotta think a little more. You gotta go a little beyond. You gotta go plus ultra. You know what I mean? You know what I mean?
Yes, sir.
My Hero Academia mentioned.
Yeah, boy, yeah, boy. Big up, MHA. Right? Big up My Hero Academia. Hey, I don't want to spoil this, but until then, see what happened to Darby in the end.
Oh
Yeah.
my,
Yeah,
I
boy.
cried. I cried.
Yeah, I love MHA so much, bro.
Hey, boy. Darby. Hey, boy. I was hoping he got redemption arc, but he didn't get redemption arc. Loki. Alright, let me continue. Um, I will have a meet and greet soon though, like after exams, I'll do a meet and greet with like all the students, probably like C3 or something. And like, yeah. Nikolai, I will see you on Romano for sure.
Yes, sir.
Right, so Mikkel, let me tackle the first question. 2x plus 3 squared. What form that in?
Yes, sir.
I mean this one really easy, you know. If you wanted, Mikkel, it could literally just what?
You can use the half.
You could use well, you could use this, but see, now this to the power 2.
Yeah.
You could just
Uh,
what?
multiply by 2 in front. The derivative of 2.
Yeah. So here what, right? Guys, could we see that this is to the power 2?
Yes, sir.
If it's to the power 2, would it be that hard to expand and then integrate?
No, sir.
No, sir.
No.
Also, let me try that. So 2x plus 3 by 2x plus 3 dx. So let me expand this thing now. So 2x by 2x. What next, Mikhail? I'm a fast.
2x by 3. And then 3 by 2x and 3 by 3.
Right. When I expand anything fully, I'm going to get 4x squared plus what?
4x squared by 4x squared plus 6x. Oh, yeah, what
Right?
the final?
6x.
Final.
Yeah. So 6x
Um,
plus 6x is,
12x.
right, 12x. And then 3 by 3 is,
9.
right. And we could integrate that real easy.
Yes, sir.
Sir.
How am I going to do that, Mikhail?
Add 1 to the power. That'll be cubed over 3. It'll be 12x squared over 2. Plus c. Yeah.
Whoa, 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 whoa.
Don't forget to do one
Whoa.
thing already.
Oh, take your time. Take your time. 9 what?
9x
Right. Right. 9x. Plus c.
plus c. Yeah. 12 and 2 could cancel, be 6x squared plus 9x plus c.
I think I'll let that begin. I'm full marks or not?
Yes, sir.
Yes,
Yeah.
sir.
Guys,
The
guys,
calculus marks are rising.
say that again?
The calculus marks are rising.
For sure, for sure. Calculus is easy. Calculus is light work at this level. Right? If I move on to multivariate calculus, something I'll go scratch on their head, but this easy. And when you have to find volume for when you have to find volume of like a cone or a cylinder in 3 dimensions, you just have to like find the triple integral and thing.
Oh,
Yeah.
I've seen that before. Isn't there like a contour integral as well? Where you're like
Christopher bad boy. They got Christopher boy. Yeah. It have div, cool, grad,
So
and
you've
have
ever done a triple integral?
yeah, well in engineering maths just had to look at triple integral and thing.
So you think I'll have to look at that in computer science? Or
Probably, yeah.
oh
I think
Lord.
so.
I want to go into engineering, so I have to try not to lose my hair.
So just
Well,
scan and you can escape.
nah, it's fun stuff, guys. It's fun stuff. Hey, big up Gene one time, big up yourself, Gene. All right, so let me try to do this question the other way, the alternative way. All right, so how could I do this the alternative way? Well, remind me, this is essentially in what form, Mikhail? What form is this in?
Ax.
I see you looking back there. That's okay.
Look
Ax,
at my
ax,
later.
ax plus b to what power?
The n.
All right,
Oh,
so
yeah,
if right, so this is in the form ax plus b to the power n dx. And so tell me, Mikhail, if I integrate that using that form, what would happen?
it'll be n. Yes, n by ax plus b.
Wait,
N plus 1 over a.
wait, nah, it go be,
Oh, ax. Yeah. So it'll be ax plus b n plus 1 over
but
a
wait,
by
what is ax plus b in this question? What is ax plus b?
2x.
2x plus 3. So that would
Yeah.
be 2x plus 3 to the power.
2
Nah.
plus 1.
Oh, okay, yeah. 2 plus 1, which is 3. And I would divide that by
3 by n plus 1, so it'll be
so n plus 1
3.
is the 3. N plus 1 is the 3, right? N
Oh
plus
yes,
1.
yeah, let's be 3. Yeah, let's be 3.
Nah, 3 by is a by n plus 1. So what was a? A is the coefficient of what?
X.
Right, so what's the coefficient of x?
2.
2. So 3 by 2.
So isn't that like you differentiating the inside basically?
Yep, it is. That's exactly what it is. That's exactly what it is. Now, guys, both are correct, but which one easier? Like, which one easier? Memorizing this rule or just expanding it on different, I'm integrating it like normal?
I find
First one,
Memorizing the rule.
Yes.
yeah, but I mean, if you have an understanding, if you do remember the rule, you could use that.
But generally speaking, I only recommend using this rule if it's a power that's greater than 3, or it's like a fractional or like a negative power or something.
Excuse me.
Yeah, Nikolai?
On top would be easier to understand, but longer to take because you had to differentiate and then you had to integrate by plus and division and then find out which one had to divide and everything.
Yeah, true. Well, it's whichever one you want to do. But either one is fine. And if you hear what, right? If you're using this, right? If you're using this, I recommend somewhere, like I recommend somewhere to the side, you say that the integral of ax plus b to the power n dx is equal to ax plus b to the power n plus 1 all over a by, remind me. Okay.
Oh, sorry.
Oh, that's okay. Yeah, put it somewhere to the side if you're using this. So you can show them that you know this. Right? Are you guys fine with both methods?
Yes.
Yeah.
Okay, good. That's a cool 2 marks. All right, let's move on to this question. Any volunteers for this one? Any volunteers for this one?
I don't mind.
All right, no problem. And I do teach chemistry. No, I don't teach chemistry. I was supposed to go through some rules for integration, right? I didn't go through. But like you see how we have a constant here, 5 times cosine 2x.
Yes, sir.
If you
Yes.
wanted, you could have pulled out the 5, You could pull out the 5. You're allowed to pull out constants. Then you
Yes,
can work
I
that.
remember that with the pi as well.
Yeah. Once it's a constant, you can pull it out. But I didn't bother to do that. I said, let me just show you the hard thing and done one time. But yeah, if you wanted, and if you have the integral of 5 cosine 2x dx, and if this would make it life a little easier, yes, you could take the 5 and you could bring it outside the integral sign. And it would now become 5 times the integral of cosine 2x dx. Do you all prefer it like that, or do you think you want to work it in one shot?
The 5
Hey,
outside.
I learned it like that in school, so
Okay, no problem. Like when I used to do these questions, I got what I just say 5. 5. If I integrate in cosine, that'll be what?
A half sine
Yeah.
2x.
Yeah, and I'll just put the answer one time and done. But this would make it a bit easier for some students, for sure. For sure.
Oh wait, I could have done that. Okay.
So if you want, and another thing too about integration, if I have something like 5 cosine 2x plus 7 sine 3x, for instance, if you want, what you could do is you could actually split up this into like multiple smaller integrals. So I could say 5 integral cosine 2x dx plus 7 integral sine 3x dx, and I could work that separately. I could work each piecewise. Yeah. Because, integration and differentiation is like a linear process. You could break each part separately and do it like each parts. But you could just use it in one shot, that's fine. But anyways, tell me guys, if I integrate cosine 2x, what would I get? If I integrate cosine 2x, what would I get?
Would it be a half sine x?
Correct yourself. It's a half sine.
No, not
2x.
sine 2x. Sir.
And
Plus
as
c.
plus C, right? And I'll multiply half by the 5 and I'll get what?
5/2.
Guys, we're getting these 4 marks for sure now.
Yes, sir. But sir, is it a good idea
Okay.
to just go through the past papers? Or just do the procedure that we talked about before
What's that?
using AI?
Oh well, I have a paper, I have a predicted advanced paper. We could do it.
Predicted, okay.
Well, it was ready for last year, but anyway, CXC moving on. You know what I mean? Watch. Let me show you the predicted paper. Predicted papers. I make a bunch of different ones. And I make like an insane gigachart level one. A real tough. For instance, a biologist models the population of an endangered species using the equation P of t is equal to P0 by 3 to the power kt, where Pt is the population after t years. P0 is the initial population and k is a constant. After 2 years, the population doubles. Show that k is equal to ln 2 over 2 ln 3. Then I have determine the time it takes for the population to increase tenfold. Solve the inequality. P of t is more than equal to 100 PO. So I have this insane level test for like, yeah, I mean, like an insane level test. So if any of you all want the insane level test, sure, I can send it to you. But a good balance would be advanced. So if you all want, we could run through the solutions for this quote-unquote predicted exam.
Yeah.
I don't think it's the most accurate thing, but I think it'll give us like a good gauge as to what CXE could bring.
Yes, sir.
Yes, sir.
Right. So one of these days, here, let me just keep grinding, right? We'll go to like 10 hours, we'll see how much we could finish. Tomorrow might be another 10 hours. We just go in, right? We just go in. Are they essentially getting like a free crazy level crash course? Big up all yourself. And are they staying? I say once I stay in, and I'm willing to learn, I'll be here now. I'll be here to help all you. Right? Once you put in the effort, I hear. So here, let me give you all another question quickly. Suppose I had the integral of minus 3 cosine 2x plus 8 sine 7x dx. Anybody want to help me integrate this?
Me.
Okay, no problem, Nikolai. So Nikolai, you want to use in one shot, or you want to break up this into a bunch of smaller integrals?
Well, we tried one shot.
Okay, no problem. So Nikolai, you see the constants, you can write back the constants. So like you see minus 3, I can write back minus 3. If I integrate cosine 2x, what would I get?
A half sine 2x.
Okay, cool. So I've done that first part. If I integrate 8 sine 2x, again, you can just write back the constant. And if I integrate sine 7x, what's that going to turn to?
Minus 1/7.
Yeah, minus 1 over 7, what?
Cos 7x. Make sure I remember that sign and cos thing, you know, sir.
Good. Hey, if you see what I was stressing Nikolai out yesterday, boy, and then I was saying plus C. Yeah.
Excuse me, sir. How you got minus 1/7? I understand the 1/7, but I don't understand why it's minus.
Okay, no problem. Remind me, when I integrate, just forget about AX, right? If I integrate sine x dx, what I'll get?
Minus cos x.
Right. So if I have to integrate something like sine AX, that will be what?
1 over e is
minus
1 over a cos ax.
Right. Look at it.
Oh, okay, I understand.
You good?
Yeah.
Okay, good. So Nikolai, a bunch of fellow educators, right? I was chat with them on WhatsApp like normal, and they was telling me, sir, well, let's saying, bro, the amount of time I see Nikolai in the videos, Nikolai is like his son. And I was saying, yeah. Yeah, boy.
Seriously, sir.
All them,
Sir, I come here to grind on us, sir. How to get them
Right.
And
And
sir,
I'm
I don't mind coming after CSEC and all too.
That's good. So if I expand that, what I'll be? Well, if I simplify it, what I'll be?
It would be minus 3 over 2 sine 2x
And
plus,
what next?
no, not plus, minus
Yeah, minus 8 over.
8 over 7 cos 7x plus c.
All right, are they okay with this? Are they
Well,
okay with this?
Yes,
Let me
yes.
know. Let me know. Chat. People on YouTube. People on TikTok. I don't really how much people on TikTok, but people on YouTube. Are they understand? And again, if you wanted, you could have broken this down into a bunch of smaller integrals. Nasia, let me know if you understand.
Yes, sir.
You sure?
Yes, sir. I understand. I understand. I understand.
All right. Nasia, every time I look at your profile picture, I think that meme where like the Smurf, like carrying like walking, carrying like the
Yes, sir. I know exactly what you're talking about. I don't know. It's not that I don't understand it. It's just like it's all the rules and then like people just have like different ways of teaching things. So I just catching up.
for sure, no problem. Well, let me do an example now.
Okay.
All right, let me tackle this. So again, so Nasia, if you see any constant values, you could just put it, figure out it, like split it, and then integrate the function like normal. So say we have
Okay.
9, if say we have 9 by sine minus 2x,
Mm-hmm.
I can
So
write the 9 here.
I would
Yeah,
have I would have brought break it down into two separate integrals. So I
that's not
would
a problem.
oh
I said that's not a problem. You know, say the integral, you'd probably say 9 integral sine minus 2x
yeah.
dx plus 8 integral cosine 3x dx. Yeah, that's not a problem.
Yeah, that's how I would integrate it.
Let
And
me try. Well, let me try to stress free brain. Let me try to stress free brain. Let me try to stress free brain.
why?
Hey, the more you stress your brain, the smarter you become. Smarter you become. So I just write back in 9 there, right? I got a bracket here and I'm gonna integrate sine minus 2x. If I integrate sine minus 2x, what happen?
Sine minus 2x, that would be 1 over
Wait,
negative 2. So negative a half cosine ax.
not quite, eh? Not quite. If
Cosine.
I integrate sine, what do I get? If I integrate sine, what do I get?
Oh, wait. Negative cosine.
Yeah.
So
So
it'll be positive.
exactly, it will be positive. So it'll be negative. So put the negative there. And it'd be 1 all over. You see, we stressing my brain now. We like getting smarter for this. So it'll be negative 1 over minus 2, right? And that's going to be cosine minus 2x. Okay. And that's going to be, I'm going to write back the 8. If I integrate cosine 3x, what would that be?
1 over 3 cosine, I mean sine 3x.
sorry for them short people to put in these brackets. Sir.
And that's fine. We don't need to plug this into our calculator. Right? So Nasia, like you said, we have a negative here and a negative here. A negative by negative will give us a
Positive.
right, positive. And you have 9 multiplied by positive a half. What's 9 by positive a half?
Hold on.
You don't need a calculator, I promise. 9 by a half. What's 9 by a half?
9 by a half is 4.5.
Yeah.
4.5.
4.5.
We typically leave our answers fractions, right? So it'd be 9 over 2, but 4.5 isn't wrong. So it'd be 9 over 2, cosine minus 2x. And then you have 8 by a third. What's 8 by a third?
8 over 3.
And 8 over 3 sine 3x plus c. So this is one way you could have worked it out. And if you do enough practice, you could just jump straight to this line. If you want though, we could break it up into a bunch of smaller integrals because integration is a linear process. Right? So if we were to split this into a bunch of smaller integrals, then it would look like 9 sine minus 2x dx. And then I would say plus the integral of what?
8 cosine 3x dx.
And then if you want, you could pull out the what?
8 and the 9. You could pull out the 8 and the 9.
Pull out the 8 and the 9. Yeah, this is our maths. So that I would write that as 9 integral of sine minus 2x dx plus 8. But I feel like this is so much work. Wait. I feel like this is real work. Right? And if I integrate sine minus 2x, what that'll be?
Negative a half.
Negative.
Negative cosine x. So positive a half cosine negative 2x.
Because it'd be negative,
And
then
negative.
it'd be negative, and then it would be 1 all over negative 2 cosine what?
Negative 2x.
Then it would be plus 8. And if I integrate cosine ax, that'll be 1 over a sine ax. So that'll be 8 by
8 by 1 over 3 cosine 3x. No, sine 3x, sorry.
so you would end up getting 9 over 2 cosine minus 2x. And I'll explain something just now, right? There's one step further you could take if you wanted. And that has to do with trigs. So can you guys see how we have cosine minus 2x?
Yes, sir.
Yes, sir.
So like, I don't know if I know this, but the cosine graph is symmetrical about which axes?
Why?
Yeah,
No.
it's symmetrical about the y-axis. So like, watch this, right? In other words, the positive and the negative values gives you the same what?
Same thing. Well, not the same thing, but
The same output. So in other words, cosine minus 2x would give me the same result as cosine what?
2x.
Yeah, cosine 2x. Yeah.
could you just use when you're finding out for the integration, you just use trigonometry. Like when you're looking for sine x is no, you can't do that.
Now, what's in here? I'm saying that, okay, from the way the cosine function behaves, it's symmetrical about the y-axis. And so what's saying is cosine minus x is literally the same thing as cosine x. So what's saying. So if you wanted, but this is fine, and this is fine, but I'm saying if you wanted, and you could think of the extra step, what would also be a feasible answer is if you said 9 over 2 cosine what?
2.
Cosine
2x.
2x, yeah. Plus 8 over 3. Unit 1 Cape students can benefit from this a lot, low key. So like here what I say again, right? And I know they don't believe me now, so I'll show you proof. I will show you guys proof, because proof is in the pudding. That's what it say. So here what? I can graph the cosine function. So y is equal to cosine x. Can you guys see that it's symmetrical about the y-axis? Yes or no?
Yes, sir. I see.
Yes, sir.
So like, watch this, right? We get in 1.57079, and the output is what? Remember, the output is given by the x value or the y value. What is the output given by?
The y
value.
Y value. The output here is what?
dx.
Nah, what's the
Not
output?
The y will be 0.
Right, the output here is 0 because the y value is 0. Whoa! So the negative x value gave us the same output of?
The positive x.
Zero.
0, it gave us the same output of 0. Let me
Oh,
give you, watch. I could say x is equal to 1, and I could say x is equal to -1. This will prove my point, right? This will prove my point. So when x is 1, what is the value I'm getting there? When x is 1, what's the y value?
0.54, all that stuff.
That would be 1. No?
No, Nikolai,
0.54,
take
right,
your
right,
time.
right, right.
Remember,
I
It'll
would
be
say 0.54.
0.54.
remember, guys, x comma y. So the y value is 0.54, and my input is 1. So Nikolai, when x is 1, what is my output?
Be 0.54.
Right. When x is -1, where's my output?
Same 0.54.
Good. So all you understand what I say when I say like the okay, cosine minus x is the same thing as cosine x, because the negative and the positive value would still give you the same output because it's symmetrical about the y-axis. All you understand what I'm saying or not?
Yes, sir.
Yes, sir,
Yes, sir.
understand.
Yes, sir.
If you still don't believe me, you know what? I could try it for x is equal to 2 and x is equal to -2. Nikolai, where's the output here when x is 2?
Negative 0.42. Well,
Right.
0.41.
Where's the output when x is -2?
Negative 0.42.
So does it matter if it's positive or negative?
No, sir.
No, you get the same answer because it's symmetrical about the y-axis. And so cosine negative x is the same thing as cosine x.
Actually,
So,
sir,
yeah,
wouldn't
Nikolai?
I have to draw something like that? Like cos x or cos 2x on a graph?
Yeah. If you have cosine 2x, it would just mean that your amount of it's just gonna have two graphs within the same period. Because if it's cosine 2x, then you'd have a full range from 0 to what?
So 2?
Nah, 0 to 180 degrees.
Oh, I talk about angles, okay.
Because Nikolai, think about it, right? If it's 2x, any angle I put into cosine is gonna be multiplied by
2.
So then if I plug in 180, 180 by 2 is,
360.
and I know a full revolution happens from 0 to
360 degrees.
exactly. So if it's cosine 2x, then I will really traverse 0 to what? So if I plug in 360 into 2 by x, if I plug in 360 there, Nikolai, what would that be? What's 2 by 360?
6, no.
That'll be 720. So like, okay, like I just take another detour, right? If it's cosine 1x, then I have one period. I just have one full oscillation between 0 to 360. If it's cosine 2x, I'll have two oscillations from 0 to 360. If it's cosine 3x, how much oscillations do you think I'll have from 0 to 360?
3.
3, exactly. Yeah. So I understand what I'm saying, right? Like cosine, you saw it for yourself. Does it matter if it's negative or positive, or will it give you the same answer?
No, it gives the same output.
With the same answer.
Exactly, because the cosine function is basically is reflected about the y-axis. So that's why. Yeah. So I probably understand that. I mean, if you wrote this is fine, fine. But if you could go this extra mile, they show them that you understand more, right? Okay. So, are they prefer to do this or all of this?
First one. Definitely first.
I tell you, but do whatever you understand, right? Nasir, if you could master this, you go save some time in the exam. It will save some time in the exam.
Okay, yeah. That looking like the routes.
Yeah, but nothing is wrong with this. If you want to break it up into a bunch of smaller parts, that's feasible. That's completely fine, right? Okay, let's do some more past paper questions. I want to give more specific here.
One question, sir.
Yeah, Nikolai?
Didn't they change the syllabus when didn't they change the format of how they did it from 2020? Would it be right?
Nah, 2018.
Oh, 2018, so I should finish. I should do up to 2018.
Do as much as they could, but yeah, mainly focus on that. Anybody want to help me with this question?
Sure.
Christopher, you just
What?
trolling at this point. You just trolling at this point. Christopher, you have it on lock already.
This guy.
Here what Christopher. Do the question, and he will tell me if you get that same answer. That's what I will tell you.
Alright,
My,
cool.
I feel like you can look at this and tell me the answer. Right? Oh, look, let me check Nasia now. Let me check Nasia. Let me see if Nasia have it unlocked.
Really, really.
Yeah.
Okay,
Really,
okay,
really, yeah. So, I promise it easy. It's real easy. So we have
okay.
2x squared plus 3x dx. How would I integrate this?
So first, I would add 1 to each of the powers, so it'd be 2x cubed plus 3x. Wait, hold on. I didn't reach there yet. I'll do that. Don't worry. We'll get there. Right. Plus 3x squared. And then I'll divide both of them by their new powers. So it'll be 2x cubed on 3 plus 3x squared on 2 plus
Okay,
c.
good. Good, that's correct. Easy marks, right? Real easy marks, Olia. Olia, that's real easy marks. Olia, can I agree, right? That's real easy marks.
Yes, sir.
Mm-hmm.
Yeah, sure.
2 marks for that? Yo, you know how hard I had to work for your 2 marks. Quote unquote, that culinary question in the 2025 maths paper. 2026 maths paper.
Yeah.
I can guarantee I did not get those 2 marks.
I mean, I got to do the hard thing on the when I was doing the solutions. It was real simple. You just have to find the equation on the line and make sure that the points satisfy the equation on the line, or you can just make sure gradients between corresponding points is the same. Real easy. I got to do the long thing. I proved that, OA, I'm finally vectors, and I showed that they were scalar multiples and whatnot. The full long thing. Ugh. But anyways, 2 sine 3x. Another simple max. Tell me, Nasia, how would you work this out?
So first I would pull out the 2 because it's a constant. And then I would have 1 on 3 negative cosine x, no, cosine 3x. So
So
negative 1 on 3 cosine 3x dx.
Yes, sir. One question, sir.
plus
And
CME, not dx. If you integrate, there will be no dx.
actually, sir, when you say cosine, isn't that cos with sine? So you're supposed to say cos?
What?
Cosine. Oh no. No, sir, I'm mixing it up, sir. When I
Yeah.
heard cosine, I thought it was cos and sine together.
No, 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 no. No, 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 that's the full name. That's the full name. Cosine is the full name. Yeah.
Cosine is the government name.
Yeah, yeah. That's like the way to say it. Yeah. And so when you multiply this by 2, it's gonna be negative 2 over 3 cosine 3x. Everybody okay with this?
Yes,
Yes.
sir.
Yeah, sure.
All right.
Yes, sir.
All here, 5 marks there. 5 marks. 5 marks. Hey, you know how hard I took 5 marks on regular maths? Yeah, boy. And so again, that 5
No.
marks?
Mm-hmm.
Yes,
Yeah,
sir.
boy. Okay, let me just throw a question on top of you guys quickly. So after today, I don't want to hear you having any problems with, integration and differentiation because we cover that. So I'm gonna sprung a question on you guys. So like, let's just say we had 1 all over the square root of 7 plus 8x dx. Alain Nikolai helped me with this one. Nikolai had asked me about this. So I'll let Mr. Nikolai McLeod help me with this one. Yeah,
All right.
yeah. What's the first thing I should do?
Change the square root to 110.
Should change the square root one time. Change it to what?
It's supposed to be, well, I would put the 7 plus 8 in brackets to the power of a half.
What would you do next?
I would carry it up to the numerator.
I would do the same. So far, you're going real good. And I would say 1 by 7 plus 8x.
To the power of minus a half.
Do I need to put the 1 here, or is it like unnecessary?
It would be considered unnecessary.
Because like 1 by anything is anything, right? So like 1 by 5 is 5, a million by 1 is a million. So you don't have to write the 1 here.
Yes, sir.
All right, what to do next, Nikolai? What form is this in?
Can't remember what's the name of it, but I know I'm supposed to add 1 and divide by the thing.
Anybody else seeing that as well? Anybody else seeing that you would have to add 1 to the power and then divide?
Divide by the power, yes, sir.
Yes, sir.
If you're not seeing it, that's okay. You're here to learn. Can't I rewrite that as 8x plus 7 to the power of negative a half?
Yes, sir.
Yes, sir.
I only hear like 1 or 2 people out of like 30 people. What going on there? Chat, what going on? People on YouTube, are they following?
Yes, sir.
All right. And this is in what form? Somebody remind me. I had like a specific rule when it integrates in
So I have your answer.
Oh, sorry.
ax plus b
You
to what
forgot.
power?
And
All over.
A.
Wait. We jump in the gun. 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 Right? And the final answer will be ax plus b to what power?
N plus 1.
N plus 1.
All over.
A mod.
A
A by
times
N
n
plus
plus
1.
1.
Michaela, hey, in a long time. Michaela, you talking there?
Yes, I was talking all the time.
Okay, good. Michael, you one of the boys, you know. And I'm a boy, so like we had to show them, right? Yeah. Yeah, show them what we about. Cause like I find out see generally it's a general observation. And Nikolai, I think you realize it's like most of the advanced students is mainly girls. You see like less boys doing advanced for some weird reason.
So even in
So
the
I think
course as well, so it only had like
so
3 boys and a whole set of girls. So. And it was
our,
embarrassing me.
our
No,
female
like
teacher once told me boys can't multitask. That's why they don't do hard math.
I'll be real though, like I feel like this might be a bit controversial, but I feel like okay, women just better at multitasking than guys do. I feel because like no, here what I'm saying, right? Here what I'm saying. My mom, like a little side story. I grew up essentially single parent, and my mom had to be this, do that. You know, I see my mom do so much things. Yeah, so much things by
Yes, sir.
herself.
Preach.
It's like she had to work, she had to like submit to lessons, she had to take care of my sister, she had to do this, she had to do that, she had to manage the household. Ooh, yeah, boy. Yeah. So like we handle this, right? So could everybody see that, this is in this form? Well, this is in this form.
Yes, sir.
Yes, sir.
What is E? What is E?
A would be
8,
8.
What would B be?
7,
And what would N be?
minus a half.
Minus a half. And generally speaking, too, you find like girls excelling in academics. Like girls typically excel in academics compared to guys. And it's not that guys not smart, I just feel like they feel like Mikkel, Mikkel jumping. Hey, Mikkel, remember yesterday? Hey, no, Nikolai and Nikolai and Mikkel literally tell me what he was doing. And in front of everybody, Nikolai and I true. Mikkel tell me what he was doing,
So disrespecting the male generation here, so.
No boy, no.
So everybody used to slack off here and in school. You can't lie.
That's true. I ain't gonna lie. That's not true. That's true. Like when I wasn't upper six, I used to struggle to do homework, boy. Not gonna lie. Hey, I used to struggle to do homework. Whew.
People do homework.
Whoa. Okay, Michael, you see, it have like equality. You know what I mean?
I used to, for ad maths, the big textbook, I used to go and just copy the answers from behind the book.
You talking
And when
about this?
the Yeah, I have it on my shelf. And when the teacher would ask me for, so like, what you working? I was like, couldn't answer, you didn't miss.
Wait, boy. Wait. That why Miss Priya and them boy. He said, get on a case. Wait, boy. But yeah, I'll have this Bible here.
Yes, sir.
Hey,
Yes,
Yes,
sir.
sir.
I never.
Yes, sir.
Yeah, boy. If all they don't have a copy of my formula booklet, all they will just tell me, I'll see if I can send it to all you. I have
Sir,
everything
I don't have
in.
a copy.
Just send me a message on WhatsApp. I will send it to you.
Okay.
My formula sheet have everything. Like, I feel like Santa Claus, you know. I feel like I just giving away a bunch of resources. You know what I mean? Feeling like Santa Claus. Yeah.
You say you'll be blessed in life, don't worry.
Like all the formulas here for like section 1, section 2, section 3, section 4, and they have like okay, watch this, right? I make sure to include what. So like what does it do? It tells you the nature of the roots. When would you use it? You would use it before solving to determine if roots are real or complex and why. Because this formula should go to boy. This formula should real go to. Like it telling you why, what, everything. Like when would you use it? Why would you use it? Badness, some badness there. Right?
Oh,
Cool.
actually.
So guys, we see that it's in the form ax plus b to the power n. So how are we gonna handle that?
Well, we do the same
Add
procedure
1
like
to
I
the
said before.
power.
Just add 1 to the power. Yeah, Nicholas, we add 1 to the power, and now it's into what?
Yes, sir. Yes, sir. You say me or Nikolai? I didn't say Nikolai.
Yeah, Nikolai.
Oh,
Yeah. Don't worry, Michael, I'll get a question to do just now. Don't worry, I forget you. I
so
forget you.
the way how you say that just now, I thought you was talking to Michael just now, you know, sir.
Don't worry, Michael, I have a question for you. I have a question loaded there. Right, so yeah, Nikolai.
That would be a half. Well, the minus a half plus 1.
Right, minus a half plus 1, and that would be a half. Yeah. All over what?
A half multiplied by 8.
Is anybody confused as to how we get the half by the 8? If you are, that's okay. I will try to make you understand.
See, I am, sir.
You're confused?
Yes, so could you please go to what?
No problem. So here what? Anytime you have something in the form ax plus b to the power n, you would add 1 to the power, and then you would divide by the coefficient of x by the new power. So you're probably saying, sir, I don't see what you mean. I'm looking at the ax plus b to the power n, and I'm looking at this, and it's not looking like the exact form. That's probably what you're wondering, right?
Yeah. Yes, sir.
Okay, so Lani, if I have 7 plus 8x, right? To the power negative a half. Instead of writing 7 plus 8x, is there any other order in which I could write that?
8x plus 7.
Well, I was asking Lani. Lani, is there any other way I could write 7 plus 8x?
8x plus 7.
Copy man, saying it.
Yeah, Lani, 8x plus 7, right? And if you're wondering why, Lani, let me give you
Yes,
an
sir.
example. Lani, where's 1 plus 2?
3.
Okay, where's 2 plus 1?
4.
Nah. 2
I mean
plus 1.
3. Sorry.
That's okay. Man turned into a big shack then. Big shack.
I want to know where he get the extra 1 from.
Ah, boy. That extra 1 is the one he going to get. All are we going to get ones in? All are we going to get ones? Pick up on yourself. Lani, you're manifesting it. That's good. So, Lani, 1 plus 2 is 3 and 2 plus 1 is? Lani, don't feel shame on thing, you know. All are we learning here is fine. Mistakes happen. That's okay. I see you mute yourself. Lani, you okay?
Nah, we were just joking, you know.
Nikolai, you're scaring people. Lani, you okay? Lani? I see you unmute, man. I hearing you. Okay, I will try to explain it here. So The point I'm trying to make is when you add in, the order doesn't matter. So if I have 7 plus 8x and I write that as 8x plus 7, it doesn't matter. So when you look at this and you look at this, does it look like it's in the same form now? Well, I don't hear you, but I hope you could see it. Could anybody tell me what the A is?
8.
So what we have ax plus b to the power n, and we have 8x plus 7 to the power negative a half. So you can see that a is 8. What is b?
7.
7.
And what is the power?
It's
Negative
minus
a half.
a half.
Negative a half. So it's exactly in the same form. And so anytime you have something in the form ax plus b to the power n, you would add 1 to the power and you would divide by n plus 1 times the coefficient of x. So when you look at this problem here and you add 1 to the power, so you add 1 to the power, what is minus a half going to turn to?
A half.
That's going to turn to a half. So we have a half here. And in the denominator now, you're going to have the new power, of course, a half by multiplied by the coefficient of x. What's the coefficient of x here?
8.
8. So I say a half by 8. I hope you understand, Lani. I really do. If you don't, yeah, you can tell me. I'll try to explain it back again. Right? But you will get 7 plus 8x to the power a half all over 4. So I see somebody say how we get a half. So when you're integrating and you have something in the form of this ax plus b to the power n, you would add 1 to the power. So what is minus a half plus 1? Child, I'm not sure your name, but yeah, Mikey, I see POB get leaked, boy. Out of all the exams too, POB? Hey, boy. Yeah, what's minus a half plus 1, child? Don't know your name, but what's minus a half plus 1? So minus a half plus 1 is a half, right?
Half.
So you get the half. Good. Hope you understand that. Yes, so that's the answer. And if you wanted, instead of writing to the power of a half, what could you have said?
0.5.
No, that's not what I mean.
Square
Something
root.
Square root.
Yeah, square root. So I could rewrite that as 7 as the square root of 7 plus 8x all over what?
4.
And don't forget your plus c, eh?
Yes, sir.
So CXC could bring on a question like this, eh? CXC could totally bring on a question like this. If it does come, well, you gotta remember Rajiv. So Rajiv, you remember.
Yes, of course.
Question like this will come. File 4 marks. So, remember this. Way boy. TikTok ban. Well, TikTok say your life is restricted in recommendations and search results due to low quality content. That was crazy. TikTok sticking by. I'm to TikTok, boy. Yeah. Do you guys fully understand this example?
Yes, sir.
Yes, sir.
All right, bet.
Yes, sir.
So I feel like are you okay with definite integration? I mean indefinite.
Sir.
Yes, sir.
I say yes and no.
Yes,
Very
sir.
good. This is why when I ask that question, I had to think about it before you answer. Because okay, are you want to jump off a cliff?
No, sir.
Nah.
You see what I mean? You see what I mean? And I had to watch while they say like, okay. Next thing I say something controversial and I say yes. You know what I mean? Somebody say right now maybe. That's crazy, child. What about that? All right. So let us look at finding the equation of a curve and when I say gradient function, what do I mean? When I see gradient function, what do
First derivative.
The first derivative.
yeah. Gradient function just means dy dx. I'm here. What if you want to get into the Zoom? Just send me a message. My message is on my TikTok profile. Just find my number, send my message, and I'll add you. So, Alia, let me run through the process, right? If I differentiate y, what would I get?
dy.
ui.
I get dy over dx.
Oh.
And if I integrate dy dx with respect to x, I'll get back what?
Y.
Right. So this process here is differentiation, and this process here is what?
Integration.
Integration.
Yeah, all these topics on my YouTube. Yeah, integration. Cool. So let we just jump into the questions. You already know how the badnesses go. I explained the concept already. Let we start. All right, let me tackle this question. Copy. Hey, look, Leon, big up yourself, Leon, one time. Hard maths, calculus is peak. All right, so the point 24 lies on the curve whose gradient is given by dy dx is equal to minus 2x plus 1. Now, guys, anytime I do indefinite integration, right? Remember, integration it undoes differentiation. But when you're differentiating, you could potentially differentiate a constant term and the constant term could get lost.
Yes, sir.
Yes, sir.
So that is why when you're integrating, you just slap on what? We just slap on.
Plus C.
Plus C.
Yeah, slap on the plus C. And then you look for a point. If they give you a point that was on the original curve, then you could plug it in to find for
C.
Y.
C.
C, to find for C. Good. So they're giving us the gradient function here, dy dx. What's the first thing I had to do to find the equation?
Integrate.
Integrate.
Right, so I have to integrate dy dx with respect to,
X.
right, I
Then
have
we
to
could find
integrate,
Y.
right, integrate dy dx with respect to x, and I'll have to integrate the whole function. That'll be minus 2x plus 1, and I integrate in that respect to x. So on the left-hand side, if I integrate dy dx with respect to x, that would just produce what?
Y.
Right, that would produce y. And if I integrate minus 2x plus 1 now, what's going to happen there?
2x squared over 2.
Right, that'll be minus 2x squared because I'll add 1 to the power. So 1 plus 1 will be to the power of 2. And I'll divide by 2. And then if I integrate 1, what would I get?
X.
But we
C.
must not forget, or
Plus
what
C.
must we not forget?
The
Plus C.
constant C.
Plus C.
Good, let's simplify. And so y is going to be equal to minus 1x. Do you need to put the 1? Do you need to put the 1?
No,
Yeah.
sir.
Now, if you want, you could just put minus x squared plus x plus c. So I'll live with more now.
Yes, sir.
Yes, sir.
People in the Zoom, give me some feedback. Will you
Yes.
understand everything so far?
Yes, sir.
Yeah.
Good. Now, if only I had a point on the curve, if only I had a point on the curve. If only.
They didn't give any point.
Dude, look at how a point right there.
Have to add on there.
All you need to understand sarcasm, boy. Oh my god. I was like, if only it had a point on the curve, boy. If only.
They took it like you didn't see it.
Well, actually, cannot blind. If I take off my glasses, I can't read what's on the screen. I cannot. I'm not blind. So, what is the point given to us?
2, 4.
2, 4.
And so, what is x and what is y?
X
2
is
is X and Y is 4.
Cool. So, I'm going to plug this into my equation, and what will that'll be 4. 4 is equal to what?
minus 2 squared plus 2.
Plus 2. Plus C.
Right? So, what is minus 2 squared?
4.
Oh.
Take your time. Take your time.
So
It
I was
is.
done. No, I was done. Good to see the answer already with the
Are you-
minus 2
Wait,
squared plus
I
2.
think I think some people thought that was negative 2 squared. No, look how it's written. It's minus x squared. So what's the only thing being squared?
Oh, just the
Yes.
two.
Just the 2. Just the 2.
Like,
So that's minus 2 squared. 2 squared is 4. So minus 4 plus 2 plus c. What's minus 4 plus 2?
Minus.
2. Minus 2.
-2.
And to find for c, I'll have to do what?
Make C the
Add
subject.
to 4.
C6.
To C
Right.
is 6.
So c is 6. So therefore, my full equation is what?
Y is
Y
equal to minus x squared plus x
plus
plus
6.
6.
And seeing is believing.
Yes, sir.
All right, let me go to the graph now. Let me go to the graph. We go. Anybody here grow up watching Little Einstein something or not?
Yes, sir.
Yeah, I do.
Yeah, boy. Like when you grow up watching them thing, you know, like your brain has developed a little more because it's not brain rot. Like hey, I just be hearing these little children nowadays. If they hear what I be saying, boy, oh my god, they'll be like skibbity skibbity. I'll be like, what?
Oh,
What? It's
You
like
know,
the brain rot.
So apparently, Tung Tung died.
Tung
Apparently.
tung die. How tung tung die? How tung tung die?
I don't know, but apparently it did.
How tung 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 Sahur can't die.
so these trend these days, you know that meme with like the brain with no the polished brain?
Yes.
That's them.
The
It's
what?
sad though. It's sad. It's sad. So
The
like
what?
Nikolai, the grooves in your brain, there's a correlation between the grooves in your brain and intelligence. So like a smooth brain would imply that, you know, you have
Yeah.
like
Okay, yeah, I
yeah.
understand.
So here what? If we are correct here, then what point should be lying on this curve?
The 2, 4.
The 2 4. The 2 4. So let me do that. 2 comma 4. Whoa, let's go. Let's go. Let's see the 2 4, right?
yes, sir.
Yes, sir.
Yeah. So we good. We good. We are good.
Sir, I have a way more niche one, sir. You ever hear about Kumizumi, sir?
Nah.
Nah,
Yes, I love movies.
I don't know about that one. No, I don't know about that one. Hey, catch more guard. All right. I'll hear the new Drake album, Iceman.
You listen to Drake too.
Oh,
Not yet.
Nah, say it tough, say it tough.
I'll listen to it, right? On my speaker system, I have like a whole speaker, like a whole like I have like a 12-inch subwoofer right beneath my feet right here.
This is one question.
Yeah.
You know when you're playing songs, you know your parents is listening to it. When you're playing a
Yeah.
song, your mother don't come in and say, "What the hell you listening to?"
Not really. Like when you're
Okay.
paying when you're like helping paying bills and things, as we move out it's moving out a little different, you know what I mean? A little different. When you're paying bills and thing, you know, and you're contributing to the
Privileges,
house.
the extended privileges.
Yeah, the extended privileges.
So
But
I hear in surround sound speaker and thing I hear in party after CSEC by Sir or
by me, no boy, no boy. Nah. All right, so I'll let get through.
Yes, sir.
Hello, okay with this?
Yes, sir.
Yes, sir.
Right. If a question like this come on, how to get through, I feel like it's guaranteed marks. So let me give all you one to do. I'll give all you 3 minutes, 3 or 5 minutes, and all you have to get through with it in that time. Somebody tell me fast. If I want to find the stationary points, what do I do?
Put that equal to
equate the
0.
YDX to 0.
But yeah.
Right, put dy dx is equal to 0. So I have to differentiate and put that equal to 0. Good. Um, aha. Yeah. Tackle this one. Tackle this one, guys. But I'll give all you 5 seconds for this.
What? 5 seconds or 5 minutes?
Oh, what's in? Wait, 5 minutes, 5 minutes. Even I know that bad. Even I know that bad. 5 seconds.
So I went and get stuff. Which one are we doing?
2023 question 4E. It's a nice question. A really nice question. Every shot, big up yourself. Yeah, boy. This is a nice question. Nice question. Let me see what they're gonna do about that stationary value part. Let me see. Fun. Anyway, could you just remind me how stationary points operate on them?
Stationary point is the turning point of the curve. Well, not necessarily the turning point, but
Yeah,
was
that's fine. You can think about it later. That's
Yeah.
fine. And is where the water is equal to 0.
The derivative of x is equal to 0. So dy dx is equal to 0.
Right, the derivative of y. Yeah.
Yeah, that.
Yeah, so fix up. Okay, I have some time with that try. It really don't how much advanced students, boy. Right now, like 30 on the YouTube and 30 in the Zoom, like so about 60 people all together. And like 3 people on TikTok, boy. What the advanced people there, boy? And like
In
advanced
my
people,
school, it have 3 classes and we have 40 students combined
40 students all together doing advanced.
all together doing advanced. Out of like 200 students in total.
Yeah, and not a lot of people do advanced. How much
So
school is
you
this?
think the curve does be low or the curve does be high?
No, I don't think it is be that bad. I feel like most of the students are doing hard maths, typically already strong in regular maths. So I think the pass rate for hard maths is like 60%. If not a little higher sometimes. I'm so excited to see how they're gonna tackle this question. Michael, no ChatGPT, eh? I remember yesterday you tell me when I was doing the question, it was like, sir, talk to tell ChatGPT, and I said, no, all the answers are within your brain. You just had to dig around. Hey, look, search, boy. You done. I fully understand. Yeah, boy, big up yourself, boy. People on YouTube are getting through this question. I see James, Game Dude. Big up yourself. Randy, my pure math students. Well, the students I would have taught art maths to. I did one thing for them, and a lot of the art maths, the pure math students say it was real good. The unit 1 students say it was real good. Thank God. And the unit 2 pure math students, they say it was real good as well. $40 remaining on the clock. Okay. Let me check my WhatsApp.
Sorry, the only question, just in case if I want to review it, that's it.
Okay. Time is up. Time is up. Nikolai, you think you're correct?
I can send more information like I wasn't finished.
Okay.
But like an a flip pad thing. You know, just flip the page on
Yeah, yeah.
the notepad, yeah.
Yep.
So I sent you the remaining answers.
Okay. It have a Nia in this class? Hmm.
No, so you don't have a near in here.
Oh. So guys, let me tackle the question now. Who wants to do the question with me? Wait, no, I have a volunteer. Mikkel will help me with this question. Mr. Mikkel. Mikkel, all this is for the betterment of you. You know what I mean? All of this is the betterment for you. So Mikkel, give the question a read for me.
A function given by y equals ax squared plus bx plus c has a gradient of 9 minus 1 over 2x at a stationary value of 5. Determine the values of a, b, and c in the function. Determine the nature of the stationary point.
Alright, so Mikkel, let me run through the procedure, right? So in the question, they're giving me the gradient function. So in other words, in the question, they're giving me dy dx here. We're able to figure out that there was given a dy dx.
Yes, sir.
Right, and dy dx will be equal to what?
2ax plus b.
No. What was it has a gradient of? They said it has a gradient of
That has a gradient of 9 minus 1 over 2x.
x. Right.
Oh, then I did it wrong then, so.
Let me check what the rest of you guys did. Let's see what Nikolai do. Yeah. Right. Well, let me continue then, Mikhail. So yeah, Mikhail. They're telling us what dy dx is. So dy dx is 9 minus half x.
Oh, now
And here what happening, right? Here what happening. So Mikhail, stay with me. So, and it's saying at a stationary value of
5.
What does that mean? Well, stationary value. Do you think that corresponds to the x value or the y value?
Stationary. The
And
x
why?
value.
Right, so Mikhail, and do you understand that a stationary point would have an x value and followed by a y value?
Yes, sir.
Right,
Or that would be y.
yes.
Yeah.
So this is 5. So remember, you typically would integrate a gradient function and you would need a point to plug in to find for what? When we have a point, we typically plug that in to find for what?
For y.
Now why?
C, sir. Yeah. Then.
See, right? So here's what, right, Mikhail? I'm thinking to myself, okay, the element has a stationary value of 5. That's the y value. What else do I need to find if I want a complete point? So I have the value, I have the y value. I know the y value is 5. But what other value am I missing?
X value.
Wait, this is Mikhail's question. Mikhail, I wonder if you're seeing that, we're missing X. Do we have the X value for the stationary point?
No, sir.
So, Mikhail, talk to me. How could I find the X value at the stationary point?
Plugging in the
All right.
Y value
Now, so Mikhail, tell me, at the stationary point, what do we know?
equal to 0.
What is equal to 0?
dy dx.
Good. So in other words, if I wanted to find for X, I could set dy dx equal to what?
0.
So I could set this equal to
0.
and then I could solve for.
Oh.
Solve for X.
Yes, sir.
And so if I'm solving for X, how would I do that? I promise it not hard. Simple rearranging. Talk to me. How would I make X the subject of the formula? Wait, I want Mikhail to answer this. So Mikhail, how would I
I
make
was talking, yeah. So put the 9 minus a half on the next side. So you divide by a half.
wait, so I'll move across the 9. I'll move across the 9 for sure. You can't move across the minus half. The minus half is attached to the X, so you can't do anything with that right now. So I move across positive 9. So that would turn to what?
Negative 9.
That would turn to negative 9. So negative 9 is equal to minus a half X. So what next?
You divide negative a half.
So yeah, you divide both sides by negative a half. So what's negative 9 divided by negative a half?
So negative 18. Oh,
Is positive 9 over 2.
Nah. So it's going to be
negative
positive 18.
18.
Now, watch this carefully, guys. If I have negative 9 and I divide it by negative a half, that will turn to negative 9 multiplied
1.5.
by minus 2 over 1. So tell me, Michael, what's minus 9 by minus 2?
Positive 18.
18 over 1, which is 18.
Yes, sir.
So minus 9 divided by a half, and how would you plug this into your calculator, you guys might ask? So to plug that into your calculator, you could say negative 9, right? Divided, open brackets. I'm assuming you guys have a sharp. If you have a sharp, you're gonna have to put this. You could say negative 9 divided, open brackets, minus 1 divided by 2, close bracket, and it should get 18. If you would do this if you have a sharp. Are they okay?
Sir.
Let me know if are they okay. Sharp people.
So I'm
Yeah,
not
Mariana.
confused with the you could just go over it one more time.
All right, so let me explain this thing one more time for you. So, Mariana, let's go through the general procedure, right? If you want to find the equation of a curve, and you would typically integrate the gradient function, yeah, and you would integrate the gradient function,
Yeah.
and you would end up with y is equal to something plus c, yeah?
Yes, sir.
And to find for c, you need a what on the graph? You need a what on the graph of the curve?
Of y value or x.
No.
The coordinates you need a point, no?
You need a point that lies on the
Curve itself. So
exactly.
you could see.
You need a point that lies on the curve itself. In this question, it's a bit harder to find that. So, Mariana, when you read the question, they are telling you it has a stationary value of 5. Well, what exactly does that mean? Well, that tells you at the stationary point, the y value is 5. But we're still missing something. What are we still missing?
The x value.
Good. So remind me, Mariana, at the stationary point, what do we know? Right. So I'm going to show you what I'm talking about. So the stationary point for this curve would be right here. What's the gradient at the stationary point? If it's a perfectly horizontal line, 0. So in other words, at the stationary point, dy dx is equal to
0.
good. So at the stationary point, dy dx is equal to 0. So remember, what were we missing? What were we missing here?
The x value.
Good. We were missing the x value, but they're telling us that it has a gradient of 9 minus a half x. I need you to remember that the gradient is dy dx. So they are telling me what dy dx is. So dy dx is equal to 9 minus a half x. Understand?
Yeah.
So someone real confused. Okay, let me run through the whole thing. I don't want anybody to be confused here. All right, so let me go all the way back from the basics. So, what exactly does dy dx find? It finds you what?
Change in y over the change in x.
Right?
No?
Which means the same thing as what?
Change in y over change in x is just
Acceleration.
take the power.
Wait, nah. All right, okay.
No?
So change in y over change in x. That sounds very similar to something you learned in maths, right?
Gradient.
Yeah. Gradient of
Gradient. So when you find dy dx, you're finding a gradient function. So dy dx really tells you the gradient. Understand? You're sure you understand this one? You're something unsure.
No, that's true. I understand.
So dy dx tells you the
Gradient, the function.
gradient function. And
Gradient
at a
function.
stationary point, what do you suppose the gradient is?
0.
Good. So at a stationary point, the gradient, which would be given by dy dx, is equal to
0.
So at a stationary point, dy dx is
0.
good. Good. You have the unlock, right?
Yeah.
So Mariana, what I
it.
want you to do is after today, well, when you get time, go look at the first life. The first life I went through this in extreme detail, as well as the second life. Go check it out. So remind me, at any stationary point, what do I know?
That the gradient function is 0.
So I would say dy dx is equal to
0.
good. I would say dy dx is equal to 0. Now in this question, they said that a function has a
gradient of 9 minus a half x.
good. So what they are giving you there is a gradient function. And we know the gradient is given by what?
Dy dx.
Good. So that's why I said dy dx was equal to 9 minus half x. You understand?
Yes.
And we're talking about, and notice it says stationary value of 5. So here what? If they say stationary value of 5, that means at the stationary point, your y value is 5. Do we know what the x value is though?
No, we don't.
No, we don't. But we know that at the stationary point, the gradient is
0.
good. So I could replace dy dx, which is gradient, with
0.
right, because at the stationary point, the gradient is
0.
good. And so now all we have to do is just solve for
X.
yeah, that's all. And that would allow us to figure out what x is.
Yeah.
So we moved across the 9 and it turned to negative 9. So we have negative 9 is equal to negative a half x. So Mikhail, to find for x, what did we do again? To find for x, what did I do?
You divide minus 9 by minus a half.
Exactly, divide minus 9 by minus a half, and that is going to give you what?
18.
So in other words, guys, x is equal to
18.
right. So Mariana, do you understand that x is equal to 18?
Miss, sorry, I saw some the female teachers. So, how? Okay, I understand how 9 change, right? Because you're carrying it over. But why? Where we get the division? Like,
Okay, no problem. Mark, that question, right? If I had 5x is equal to 10, How would I find for x?
10 divided by 5.
But ain't you technically doing that
Oh,
on both sides?
yeah, so they cancel.
Exactly. So consider you had negative a half x is equal to negative 9, right? I know it's looking a bit different, right? But if I divide both sides by negative a half, what would happen on this side?
The a half will cancel the negative a half. Or just
Right.
leave it. Okay.
9 minus 9 divided by negative a half, which is 18. Yeah.
Yes. Thanks.
If all you want, you don't have to write it as a fraction, you know. Instead of writing minus a half, what we could write in
Negative
decimal.
2.
You could write negative 0.5x and enter a half is 0.5, guys.
Yes, sir.
Mariana, enter half is minus 0.5.
Yes, sir.
So I mean maybe this might be a bit easier to see. So you can see that we had to divide. We could divide by minus 0.5. And if I divide both sides by minus 0.5, what's gonna happen?
They'll cancel out and we'll get the x value.
Exactly. And minus 9 over minus 0.5 will give us what?
The 18. X equals
Right.
18.
You ready to be mind blown?
Sure.
So x is what? What's x?
18.
All right. Well, when we finish the question, I will blow your mind. You can see. You can see. But Mikhail, do you understand how we got the x value for the stationary point?
Yes, the way the question was worded is what threw me off. Normally it is say like given the gradient function or given the first derivative, but this is just say has the grade change it up now.
Yeah. See, that's why I do the question because I gotta prepare for things like this, you know. I gotta prepare for things like this, you know, Mikhail. You gotta prepare. So,
Yeah,
Mikhail,
because I was in 2024 and it had a question, but it say given the gradient function. I didn't see a question like this now.
yeah, so a good thing we doing this. So, they said you have a function, right? Clearly, the function we're dealing with is a quadratic. You have a quadratic. And they're telling you it has a gradient of 9 minus half x. If this is the case, then that would tell us that dy dx is what? Mikhail, tell me. It's saying gradient of 9 minus half x. So dy dx is
9 minus a half x.
9 minus half x. And then they're saying at a stationary value of 5. Now, for a stationary point, all points are made up of an x and a y value. Now, stationary value tells you the y value. So the y value is 5. But what we missing? Mikhail? Oh, yeah. Y'all hearing me or not?
For a moment, I wasn't hearing you until you came back, but I'm hearing from Mikel now.
Guys, can you guys see that we have the y value here and we're missing x?
Yes, sir.
Yes, sir.
Mikhail, we not hearing you at all, you know. Mikhail, we not hearing you at all.
Now hearing you, now hearing you, sir.
Oh, okay. Yeah, so Mikhail, this over here is giving us the y value or the x value. What is giving us?
The y value,
Oh, what are we missing?
the x value,
Good. Now we need to remember that at the stationary point, the gradient is
0,
0. So dy dx could be replaced with
0.
right. And if you forget it, if you forget it when you're looking back at these notes, please remember that dy dx represents gradient. So at the stationary point, so I'll write it here literally, at stationary point, the gradient is
0.
0.
good. So I'll probably understand why I replaced dy dx with 0, right? And so, Mikhail, I tell you that dy dx is 0, so what I had to solve for over here now?
X.
That's all. Move across the 9, that's into minus 9. The minus a half confuse some people, so I change it to a decimal. So minus 0.5. I want to find for x, so I divide both sides by minus 0.5, and I find x to be 18. So, Mikhail, do I now have the full stationary point?
Yes, sir.
Good. I see Nikolai raise his hand. Nikolai, talk to me.
So did I just find another way to get 18? Because I sent you mine, but mine
Let me
was
check.
different until I saw you got 18.
Right? So dy dx would be 20x plus, I mean, it would be 2ax plus b, yeah. And I see I said 2a is equal to negative a half, and I say b is equal to 9. So far, that's correct. So a would be negative a quarter, and b would be 9, right? Oh, no, you do the same way as me. You said 9 minus half x is equal to 0, and I said a half x is equal to 9. You do the same way as us, Nikolai. Yeah.
I was watching the top part of my workings now, but I didn't see it like how you did it here. So I assume that I found another way how to do it.
I'll go over your method just now, but what you did not wrong. Not wrong, just a different way you could do it.
Oh, okay.
I would recommend this, so I recommend this. So let's continue. So guys, do you all now understand that we have a stationary point? We have the x value and the y value for the stationary point.
Yes, sir.
Yes, sir.
Mariana, talk to me. Mariana, I know you had some trouble. Are you okay now, Mariana?
Yes, sir. I think I just don't understand. Like, put the word in with stationary value, and then the fact that dy dx is 0.
Ah, yeah, it cannot phrase all weird, right? Stationary value. Yeah.
Yeah.
So here what? Now we could actually, since we actually have a point, we could actually integrate and then find for c. So if dy dx is equal to 9 minus a half x, and we are trying to find for y, what will I have to do with this?
Integrate.
Right. So I'll have to integrate dy dx, and Mariana will help me with this. I want to make sure she's okay with this. Yeah, so Mariana, I've got to integrate the left-hand side with respect to x, and I'll have to integrate the right-hand side with respect to x. So Mariana, if I integrate dy dx with respect to x, what would I get?
Y.
Right? If I integrate 9, what would that turn to?
0.
9 squared over 2.
Nah. Now, that would turn to 9x.
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 Oh.
Yeah. So Mariana, anytime you integrate a constant, just slap on the variable to it. You can think of it like that.
Okay.
So if I integrate 9 with respect to x, that turns to 9x. Then we have minus a half x to what power? This is understood to be x to what power?
1.
Yes.
0.
Now 1. If something is to the power 0, then it'll be 1. But we have a half x. So this would be a half x to the power 1. And so I'll have to do what to the power?
We add in the 1 there
I
and
see.
then divide them.
Yes. So that would now become x to the power 2. And I'll multiply by
2.
I'll multiply by 2, or I'll multiply by 1 over 2.
2.
Okay, now.
So why integrating again?
Okay, why integrating? We
Because
want
they
to find
actually
we want to find the original values for a, b, and c for the function, and we are given the gradient function. So if you have the gradient function and you want to get the original function, you have to integrate to undo the differentiation to get back y. Watch. To go from y to dy dx, you differentiate. If I want to go from dy dx back to y, I integrate. And of course, y is the original function. Yeah. Let me try to make sure nobody confused. So when you're integrating, right, you add 1 to the power and you
divide by the new power.
divide by the new power. So over here, I'd have to divide by.
So you forget the
2.
constant.
Plus
No,
2.
no. Wait, I just trying to after explain this part and then I'll put the plus C. Right? Yeah. So Mariana, divide by 2. Dividing by 2 means the exact same thing as multiplying by what?
A half.
Exactly. Exactly. So I can write minus a half x squared multiplied by a half. And then I will put plus C. So because you understand what I mean, like, okay, I hope you can understand what I'm trying to say. Like, if you put divided by 2, it might look a little complicated.
Yeah.
Or you
Understand.
prefer to write divided by 2.
I just, I don't know, when I stick to the formula, I just remember the rest better. So like how accustomed to saying the plus one divide by the new in the C, I would take it as divide by 2. But understand changing it, it could look easier.
Okay, good. So let me try to rerun the whole thing again to make sure you actually understand this. So, Mariana, if I integrate 9, what would I get?
9x.
Good, I'll get 9x. And if I integrate, so forget about the minus half, right? Forget about that for now. Forget about that for now. Yeah, I'm going to try to teach you in a different way. That might be a little easier for you. So I'm just going to write the minus half there. I'm going to write minus half there. Now, let's integrate x to the power 1. If I am integrating x to the power 1, what will I have to do to the power?
We add in the 1 and then we divide them by the new indices. So x squared over 2.
And then I'll say plus c. That was confusing or you was with me there?
I was with you.
Yeah, sure.
Yeah.
So now we could write this as, so then we have, if I were to write it like this, you can see that we have minus a half by x squared over 2. So you have a negative by a positive, so your final answer is going to be a negative. What's 1 by x squared?
X squared.
And in the denominator, you're multiplying what by what?
2 by 2.
2 by 2 is?
4.
Yep. Plus c. Yeah, you try what more? You or not?
No, I'm okay, don't worry.
If you're confused by the slightest thing, Mariana, you just tell me and I'll go by the whole thing. Just to make I here to help all in anyway, you know. But once I'll get a little confused, just tell me and I'll go by the whole thing.
Miss this wait, sorry, again. So this way just to write is the same as 9x minus a half x to the power 2 by a half. It
Correct. It's
equals
the
the
exact same thing. Watch, I'm gonna show you. If I had negative a half by x squared by a half, tell me, what is minus a half by a half?
minus a half by half is now 1. No, hold on, that's wrong. Just positive a half? No?
Nah.
A
What is
negative a
minus?
quarter.
That one.
Yeah, that's okay, but I want Mariana to help me, alright? So Mariana, what is negative 1 by 1? So negative 1. And what is 2 by 2?
4.
Yeah. Negative 1 by x squared is negative x squared over 4, same thing.
Okay.
It's the exact same thing. But I feel like you don't understand this a little better, so I try to share this different way.
Yes, yes.
So like again, we had x to the power 1, so I had to do what to the power?
We had to add it. We had to add 1 and then
So it's
divide by the new power.
right. And I had minus a half on the outside, so I had to multiply the x squared by the 1, so I got x squared, and I multiplied 2 by 2 and I got
4.
4. Yeah. So you understand?
Yes,
Now, guys, Mikhail, is this a complete equation or am I missing something?
Missing C.
Missing C. Do I have a full point that I could plug into that now?
Yes, sir.
What point I could use to plug into?
18, 5.
X and Y, 18 and 5.
Yeah, boy. Virginia hot on the way, boy. Hey, I still feel like Virginia trolling.
No, I'm not. Then you speak to my mom.
Yeah.
See, I'm
Maybe,
really
maybe,
uncomfortable.
maybe your mom in on it too. Cause
Nah.
you moving like you gonna write that exam. You moving like you gonna write that exam.
So she could wait. Oh no, it don't have no January in advance.
So anyway, you see why you're gonna write what instead.
5.
5.
So Mariana, help me with this now. Help me finish this. So Mariana, I replace y with 5. What do I replace x with?
18.
Yeah, I replace x with 18. I replace x with again. What I replace x with?
18 again. And 18.
Cool. So what is 9 by 18?
162. That's okay.
Right? Somebody can verify that too. 9 by 18.
Yes, sir.
An easy way to do that. You could say 9 by 20 is 180. And then you can say 2 by 9 is 18. 180 minus 18 by 162. Yeah. If you want to do some mental maths. Then you have 18 squared.
Wait,
What is 18?
mommy. 18
What is
squared
it?
is 324.
And 324 divided by 4 is?
324 divided by 4. I got 81.
I mean 81, yeah. And 162 minus 81, I think is 81 as well. Because 81 by 2 is 162. And if I move across the 81, I will end up with 5 minus 81 is equal to C. So C is equal to what?
Negative 86.
Now, what is positive 5 minus 81?
Wait, 80, 79, 78, 76. Is it 74?
Now, that'll be minus 76.
Sense.
All right, that's okay. So, Mariana, a way to think about this, right? Imagine you was owing somebody $81 and you only paid them $5. You still had to pay them $76. Yeah, think of negative as owing. So imagine you was owing somebody $81 and you pay them back $5. How much you still owing them?
76.
Yeah, so if you're still owing them, negative. And of course, you can just plug that into your calculator, and if you put 5 minus 81 into your calculator, you should get a minus 76. So yeah, so guys, what is my final equation? Someone wake up.
The same equation?
Yeah.
Y equals
equals
9x minus x squared over 4.
And you could also write as a quarter x squared.
Yes, sir.
Yeah. And I could say
minus 76.
And if I wanted to put any form of a quadratic, I would say, what would I have to write first?
Minus a quarter x squared plus 9x minus 76.
Good. And so they said that the function was in the form ax squared plus bx plus c. So could you tell me what a, b, and c is?
A would be minus a quarter, b would be 9, and c would be minus 76. So I worked it out. When I'm corrected, man, I get the same answer.
Badness. Now, there's an easy way to see if we answer correct, and I can show you. Let me show you mathematical badness fast. If we are correct, though, then our function is supposed to pass through which point?
18 and 5.
18.5.
It should. So I'm gonna put 18.5 somewhere over here, yeah. Mariana, I must get a little trouble in school. Little trouble.
Yes, sir. No, plenty trouble.
That's okay. I'll try to be in depth so I can get the benefits. That's okay. If you're confused by anything, let me know. As well as anybody. I know it's like to be confused, so if you're confused, just tell me. So guys, so does the mathematical badness legacy continue?
Of course, sir.
Watch. So the point was 18,5. Whoa! Does 18,5 lie on the curve?
Yep.
Yes,
Sir.
sir.
Yeah. And it is at the maximum turning point, which is in fact the stationary point. Yeah.
So would you be able to run it back?
Sure, that's not a problem.
Because I know my way, I feel your way a bit better than mine's. So
Well,
I like to learn your way of how you would answer the question. That's it.
your method not wrong. So like, let me see if I could. At least this is what I think you do, right? You have ax squared plus bx plus c, and you know they told you that dy dx. They tell you that dy dx was 9 minus half x.
Yes, sir.
That's what they tell you. Therefore, dy dx would be equal to 2ax plus b. And so if that is the case, then 2ax plus b had to be equal to minus a half x plus 9. So then 2a would be equal to negative a half, and b would be equal to 9. And so a would be equal to negative a quarter. And so for the quadratic thus far, you would have negative a quarter x squared plus 9x plus c.
Oh, wait. Which one chose mine's?
Yeah, yours is it's a really good way. Like it's really ingenious. It's really ingenious. Meaning like it's a compliment. And if you have dy dx is equal to 9 minus half x, and you want to find the x value, you're just going to set that equal to 0. So 9 minus half x. When you solve for x is going to be 18. And you know that the y value was 5. So plug that in. So I say 5 is equal to minus a quarter by 18 squared plus 9 by 18 plus c. When you make c the subject of the formula, you will get minus 76. And that's it. Y is equal to minus a quarter x squared plus 9x minus 76. A is equal to negative a quarter, B is equal to 9, and C is equal to minus 76. Which is what you do, I presume.
Yeah, because when it's a stationary point, I know everything had to be equal to 0. So I thought of doing the ax squared plus bx plus c and put it, well, differentiate it first.
But what you did was perfectly correct and an excellent example of thinking different. Big up yourself.
Thank you.
Right? Big up Nikolai. Double is in the chat for Nikolai. Nikolai bad. I'm my son, you know. Nikolai is my son, you know what I mean? Yeah, boy. Yeah. They grow up so fast. Oh, yeah. Anybody else thought about it like how Nikolai thought about it? Or no?
So when you originally asked me to start to do the question, I was doing it like this, but when I say dy dx is 2ax plus b and you look thing, I say, all right, that was wrong one time.
It wasn't wrong. It was definitely different, but it wasn't wrong. It wasn't
So
wrong.
I was going correct then.
Yeah. It was going correct. It was going correct. I just stopped you prematurely. Yeah, maybe you could have also gotten through this. I think you could have. So let me run through the conventional method. The conventional method. So, guys, in this question, they tell us the general form of the quadratic. It's going to be ax squared plus bx plus c. And it told me it had a gradient at what?
9 minus a half x.
Guys, if they tell me the gradient is 9 minus half x, right, Mariana? If they tell me the gradient is 9 minus half x, and that would have to represent what?
The first derivative,
Correct. The first derivative. So I would say dy dx, right?
right?
Yeah, because Mariana, the first derivative is represented by dy over dx, which
Mhm.
represents gradient. Yeah.
Yes, sir.
So I would say immediately I'm going to write that dy dx is equal to 9 minus r of x. You follow?
Yes, sir. I do.
You,
I do.
you okay?
I'm feeling to cry.
Why are you feeling to cry? Is this all right?
To add maths is please.
Wait, sir. There. You will be okay. You will be okay. You'll get through. You'll get through. Yeah. You will be okay. There. Right. So, Mariana, um, if I talk about gradient, the gradient is going to be given by, like you said, the first derivative, and that represents what?
dy dx, the change in y over the change in x.
Good. So dy dx is equal to 9 minus r of x. That's what I know. I know that.
Hmm?
Then they're trying to confuse your brain, and they say at a stationary value of 5. What do I mean? That means the y value for the stationary point is 5. That's what it means. So like the stationary point. So you see a lot of people doing the past doing this here, they get so confused when they see this. So Mariana, the stationary point has an x and a y value, but in the question they only give you
The y value.
exactly. But we could figure out the x value, because we know at the stationary point the gradient is
0.
yeah. So at the stationary point, what could be equal to 0?
The gradient. No. Yeah,
Yeah,
the
the
dy
gradient.
dx, the gradient.
Yes, the dy dx gradient will be 0. Yes. So you could say that that is equal to 0. And then from here, just have to solve for what?
X.
Good.
X.
If the fractions tie up your brain, you could just write it as a decimal, and it might make things a bit simpler to work out. So I move across positive 9, it turns to negative 9. Then I change the negative a half to negative 0.5, and I divide both sides by negative 0.5. The negative 0.5 will cancel off, and that would leave me with x is equal to 18. So therefore,
So I
Mariana,
have a,
yeah, talk to me.
no, I just, okay, I know the, if a stationary, the stationary point is the turning point on the curve, right? That is what is it like, if you have a set x value, could they put that the stationary point and it ended and it on the x-axis or no?
Say that again.
Like if the curve was like if they was to bring a question similar to this one, and the stationary point is on the x value instead of the y.
Oh, that's not a problem. If that is the case, the dynamics of the question would change because here I was saying, right? You would know what the x value is, but okay, typically, right? If you have the x value and you want to find the y value, you would take the x value and plug it into the
Formula, the equation of the line.
exactly the equation or the curve or something. So I don't think they would do that now. I don't think they would do that. Because if you are trying to find the equation, if you are trying to find the equation of the curve, right? Then how would you find the y value if you only had the x value? You understand?
Yeah. So okay.
I was saying that will happen. That would change the dynamics. If that does happen, then they would have to give you two stationary points where they give you the x value, and you would have to come up with a system of simultaneous equations and solve. I think. Yeah.
Okay. So it's like highly likely they'll bring something like that.
Highly unlikely, yeah. Because if all they could understand, right? Here was saying, guys. If they give you a stationary point and they only give you the x value, and you are trying to derive the original function, you'll only have an x value to plug in. So that would mean y is one of your unknowns, and what would be your other unknown?
C.
C. So you have an equation there with how much unknowns?
2.
2. To solve a system with 2 equations. My brain is autocorrect. Like my brain does like say the answer. If you have 2 unknowns, to solve that, you need to form 2 equations. So the only way you could solve that question is if you have another stationary point where they give you the x value alone to formulate another equation to solve simultaneously. So that would have to most likely be for a cubic with 2 stationary points. Yeah. So
Okay.
that's unlikely though. So yeah, Mariana, once you have x is 18, now you would have your full stationary point. Your full stationary point would be 18,5. And matter of fact, when I plot the graph, over here, and I tap the stationary point, what's the stationary point?
18,5.
Partners.
Partners rolling.
Which is what we figured out. We figured that out. And you can see it on GeoGebra, and it makes sense. And so here we're saying, right? Until now we have a full point, and you have a point on the graph now.
Yeah.
We have a point on the graph. That point is 18,5. That point is 18,5. So we have that. And now we need to find for y. So remind me, what would undo dy dx? What would undo that?
That would integration.
Good. So I would integrate dy dx. I would do that. I would undo. To undo dy dx, I'd have to integrate. So I'm going to integrate both sides. And if I integrate dy dx, that's going to give me y. So I'm going to get y. And I would also have to integrate this side as well. So if I integrate 9, what is 9 going to turn to?
9x.
Mom, you're correct. Because this one is going to be a bit more complicated. So here what to do, right? Here what I want you to do. I want you to like put the negative a half aside here and just lock in on the x to the power 1. So when you're integrating, what do you do to your power?
You add 1 and then you divide by the new power.
Good. So you're going to add 1 to 1. Where's 1 plus 1?
2.
2. Right? And you divide by?
2.
Good. Say what must over?
Yes, sir.
And since it's indefinite integration, you don't have an upper or lower bound, you're going to have plus c. And so you're going to write back 9x, then you're going to simplify this. So you have minus a half by x squared over 2. That's going to give you minus x squared over 4. Because 2 by 2 is going to give you the 4. And well, 1 by x squared is just x squared. So let me know if you're okay from here to here.
Yes, I understand.
And well, from here, you could plug in your points. And you have a point on the graph?
Yeah, 5, 18, and 5.
So I'll plug in x is 18 and y is 5. And then therefore, I'd only have an unknown of c. So to find for c, I just had to make that a subject of the formula. And I get minus 76. And so your equation would be y is equal to 9x squared minus a quarter x squared minus the 76. That's what happened. Yeah.
Okay, sir.
Yeah.
I have one more.
Right, let me answer the other question. Everybody okay with that question like this if they try to tie up with the complicated language?
Yes, I gotta do over this question 1 or 2 times again.
Yeah. So if you see stationary value, what is the x or y value?
Y value.
Y.
Good. If you want to find the x value, what you gotta do? Come on, guys. If I wanted to find the x value, what would I do?
Integration.
When dx equals to 0.
Good. Mariana, I'd have to set dy dx equal to 0. Because at the stationary value, at the stationary point, right? At the stationary point, dy dx is equal to what?
0.
Exactly. So you put dy dx equal to 0 and you solve for?
X.
Yeah, you solve for x. Bam. Hopefully you're with me. And if I want to check the nature of the stationary points, what ought I do?
Find the second derivative.
Yeah,
No.
I got it. I would have to find the second derivative, right?
Yes, sir.
So remind me, what was dy dx?
9 minus a half x.
So if I differentiate this another time,
Just be
half
half.
a half x.
it will be minus half. Watch. If I differentiate that constant, guys, if I differentiate 9, what's gonna happen?
There will be 0.
That'll be 0.
That
If I
disappear.
differentiate minus a half x, what that's into?
Minus a half.
Yeah, minus a half. Are you okay?
Yes, sir.
Yes.
Now, since the second derivative, since d2y dx squared is less than 0, it's a what?
Maximum.
So I'd say 18,5 is a maximum. Yeah. And if the second derivative is more than 0, it would suggest that it's a what?
Minimum.
Good. Nice. We okay?
Yes, sir.
All right. Let's tackle this question. This one more question now. Get us 3 marks. I'm gonna time you 3 minutes. Please get it correct. I know you can do it. Start. Go. So if dy dx is equal to 6x minus 10 and x is equal to 0 when y is equal to 12, find the equation for y in terms of x. Handle that. Yeah. Sometimes when I'm reading, I was going to flow states. Michael, I'm the next M&M, and I'm the next rapport, but yeah, well.
Sir, rhyme a word with derivative.
Say that again?
Rhyme a word with derivative.
Derivative. Primitive.
That was quick.
Yeah. I used to rap and thing back in the day in secondary school, you know, like low-key. Like some low-key type. Yeah, low-key. Yeah. Like the fast part of rap word now. Or like Busta Rhymes, you know what I mean?
Oh, okay.
How real low behind my pipes, you know? Real low.
It's all finished.
Okay, nice. Big up yourself, Liam.
I'm finished too.
Okay, nice. Mariana, looking at you now, Mariana. I seen ya. You had to get this question correct, for sure. You could do it.
So when we start in tricks.
When we start some tricks, after this, I had to look at, well, until you know that finite integration is just area, and well, volume is just
Pi.
Pi integral b a, or a, yeah, f of x
Yeah.
squared. We know that, and
Yeah.
so that's not hard. So as soon as we finish with this, I want to move on to kinematics. I wanted to do kinematics. That's
That with
kinematics.
SVA, right?
Huh?
That with SVA.
Yeah.
Oh.
That's that's where they give you an equation in terms of time when you have to
Take our next
integrate.
one. Yeah.
So I wanted to do that and then move on to tricks.
Not hard. All you have to do is integrate and substitute.
It's not hard, but sometimes it's phrased a bit weird.
Yeah.
And then sometimes it would give you information. You'd have to draw a graph. And in one particular year, I think it was 2017 or 2019, it's a really hard question. So I want to do that one in case something like that comes.
Yeah.
All right, so the time is running out. Amelia, you want to help me with the question?
I can try, sure.
Amelia, here, like a slight accent. You're from Trinidad or like representing a different country?
Another country.
Which country is that?
Jamaica.
Big up Jamaica. One time, big up Jamaica. Right? So in the question, they're giving us the gradient function. What's the gradient function?
6x minus 10.
And so if I wanted to find y, what would I have to do?
Integrate.
So I would say the integral of dy dx with respect to x. Don't forget the with respect to x part of dx, don't forget that. So the integral of 6x minus 10 dx. What would the left hand side turn to?
Y.
Right? And if I integrate 6x, what I'll turn to?
6x squared over 2.
Minus 10 will turn to?
Minus 10x.
Right? Plus c. We could simplify that though. That'll be what?
3x squared.
What we need to find for over here though, like something is missing.
C.
Amelia, can't you see any C missing? So how could I find for C? Tell me, Amelia, how do you it?
Plug in the 0 and 12.
Because when x is 0, y is 12. We know that. So x is 0 and y is 12. So I'll say 12 is equal to
3 0 squared minus 10 0 plus c.
that really is this one really comes up here, boy. Anything by 0 is 0, so we just end up with 12 is equal to
C.
So what's our final equation?
Y is equals to 3x squared minus 10x plus 12.
Amelia, you get through?
Yes, sir.
So you
Right, how
see
much
what
of,
I mean?
yeah. How much of you guys in class got the answer?
You
I
see?
did.
Yes, sir.
Yes, I get.
Mariana, were you able to get through with it? Be honest.
No, I make it through the first half and then I didn't write the ending.
Oh, okay. Tell me, which part confusing?
When I was writing it, how could I put it? I tried to differentiate the 6 and the 10 together. To ask me
Wait,
why, to ask me how. I
nah.
just remember one.
So again, when you integrate, so like we have dy dx, so we gotta integrate both sides. When I integrate dy dx, I get y. When I integrate 6x, what's gonna happen there? Well, I have 1 here already, so I'm gonna add 1 to the power. So that's gonna turn to 1.
2.
And then I'm gonna have to divide by
2.
and that's how we get the 3x squared. If I have minus 10 and I integrate that, what do I get?
The 10, just 10x.
Yeah, just minus 10x. Yeah, plus c. Yeah, plus c. Like how some people distracting you.
I just
I
watching my little brother.
yeah, but distracting you.
Nah, he quiet.
You still in
Oh,
class?
oh.
Yes, I'm still in class. Shh.
Sorry.
He learning hard maths, don't worry. He want to learn hard maths. You can't hold him back from greatness. He want to learn hard maths too. Yeah. So once you get this part, you realize that you're missing C. So to find for C, you look for a point that is on the graph. In the last question, we actually had to find the x value. But in this question, they're being nice. They're telling you what y is when x is 0. So you have the point, you just replace x with 0 and replace y for 12. From there, you find for C, and you write your final equation. You just have to replace C with what you're finding for. So we find C to be 12, and that's it.
Yes, sir.
All right. Cool. Cool.
So would
So
you be able
Martin,
to, my apologies for interrupting, right? But would you be able to explain the one that I sent you about? Because I still feel like I not understand what you're telling me.
okay, no problem. All right, so Nikolai, you talking about this one, and
Yes, sir.
all right, so let me understand something. They said using the grid below, draw the graphs of sine 2 pi, well, sorry, sine 2x and cos 2x, right?
Yes, sir.
So Nikolai, we would have had to graph two functions, and those two functions would have been y is equal to sine 2x, and what was the other function they wanted us to graph?
Y is equals to cos 2x.
Okay, so Nikolai, if I wanted to solve this, so I have two equations here. You see, now I have two equations. I have equation 1 and I have equation 2.
Yes, sir.
If you wanted to solve for x naturally, what would you do? What would your next step be?
Solve for x.
Yeah, but
Switch.
both of them are equal to y. Both of them are equal to y. So what you can do
Put one
directly.
in front of the other. Like cos 2x is equals to sine 2x.
And then you would essentially be solving what? Starts with S. You'd be solving what?
Simultaneous.
You what?
Nikolai, since you have two equations with two unknowns, you'll be solving one.
Oh, simultaneously.
Right. Isn't this just the substitution method?
Yes, sir.
So Nikolai, here what I'm trying to do, right? So Nikolai, if I set these two equal to each other, I'm trying to find the value for x that would make this one equal to
Sine 2x.
good. Here what I'm gonna run back again. I have a system of two equations, and I'm trying to solve them simultaneously. So I'm looking for the value for x and y that will satisfy
The two, the y.
two of them, yes. So I can say sine 2x is equal to cosine 2x. So Nikolai, can you understand that since we're solving simultaneously, graphically we're looking for a point of what?
Intersection.
Good, we're looking for a point of intersection. So if you see a question like sine 2x is equal to cosine 2x, and you're really looking for a point of
Intersection.
because you're trying to figure out the value for x that would satisfy both of them.
Yes, sir.
You understand or not?
Yes, sir.
You sure?
Yes, sir.
Okay. So Nikolai, when you draw a graph, how much points of intersection is seen here?
2.
Right, I see in 2 points of intersection. I see one over here. That's pi over 8. And I see another one over here, which is 5 pi over 8. So Nikolai, ready for some mathematical badness?
Yes, sir.
Check this. So again, let me split these functions into two separate functions. So the first function will be y is equal to sine 2x, and what would the other function be?
Y is equals to cos 2x.
And I was trying to figure out the value for x that would make these two functions what?
Satisfied?
Yeah, make them equal. Watch. Nikolai, and I'm literally putting them equal to each other over here.
Yes, sir.
So the value of x that would satisfy this would make sine 2x equal to cosine 2x. So let's test one of our answers. So one of our answers was x is equal to pi over 8. All right. So Nikolai, wait to plug this into your calculator.
Should I leave it in degrees or change it to radians?
Whichever one you're comfortable.
I know certain questions they would ask you to put it in radians.
Well, in this question, they wait in radians because they give you the range in radians.
Ah, okay.
Now, for some of you eagle-eye viewers, anybody here real like trigonometry and good in trigonometry? Anybody here? All right, so Maya, you'd probably remember that if you have, right, so like, let me explain. If you have sine A here, this will be equal to cosine 90 minus A. You understand? You know that or not?
I'm not following.
Okay, do you know that complementary angles give you the same result? So like like sine 30 degrees. You know that sine 30 degrees gives you the same thing as cosine 60 degrees? Or not?
Understand what you're saying?
You knew this or not?
Yes, but like I didn't revise it yet. So like you know, you revise it in a while. Well, like I knew it. Yes.
Because when you add 30 and 60, where you getting back?
90.
So if I have sine 45, you reckon that sine 45 will be equal to cosine 1?
90.
Nah, 45. Because the two angles must add up to.
Oh, the must add up to 90. Okay, I understand.
So when I look at this question, I can see the answer immediately. Watch. This would have to be 45, and this would have to be 45. So if 2x is equal to 45 degrees, then x would just be equal to 22.5, which is in fact pi over 8. Because pi is 180. What is 180 over 8? Plug it into your calculator. It was 180 over 8.
22.5.
Badness, you see? Yeah, so Nikolai, what you get for this?
I got root 2 over 2.
I root 2 over 2. Nikolai, a way to plug pi over 8 into that.
Oh, pi over 8 for that. I thought it was only 5 pi over 8.
It doesn't matter. I give you the same answer.
Okay, I got root 2 over 2.
So Nikolai, can you see when x is pi over 8, you're getting the same value?
Yes, sir.
So Nikolai, in other words, when x is pi over 8, isn't sine 2x giving you the same thing as cosine 2x? You can put them equal to each other.
Yes, sir. But how you didn't know if it was pi over 8? Could you just remind me?
So again, you have a system of two equations. Anytime you're trying to solve a system of two equations, you're looking for the point of
intersection.
When you draw the graph, what was the point of intersection?
The first one and the second one.
It doesn't matter. All the points of intersections would work.
But no, what I'm trying to say is like how you know that the first point of intersection would have been pi over 8.
Oh, all right. Over here is 0, and over here is pi over 4, right?
Yes, sir.
So Nikolai, if you count the spaces, right? 1, 2, 3, 4 spaces, right?
Yes,
You
sir.
notice that this is in the middle. Yeah?
Yes, sir.
So if it's in the middle of 0 to pi on 4, wouldn't you just find half a pi on 4?
Yes, sir.
What is half a pi on 4?
It'll be pi over 8.
Right. Pi over 8. This other point now, this other point is over here. Can you recognize it's in between pi over 2 and 3 pi over 4?
Yes, sir.
So what you can do is you can add pi over 2 and 3 pi over 4 and divide it
by 2 to find is like the midpoint.
Yep.
Oh, okay.
And let me explain something. Nikolai, anytime you have one function equal to another function, you are solving simultaneously. You are trying to find the point of intersection. So let me give you an example. Like say you had a function y is equal to sine x, and you had a function y is equal to 9 plus 2x. If I tell you, Nikolai, if I say 9 plus 2x is equal to sine x, and I'm trying to find the value for x, that would make the left-hand side equal to the
right-hand side.
right. And graphically, that would just be the point of intersection. So like if you see something like 9 plus 2x is equal to sine x, then you're just looking for the points of intersection between those two graphs. That's all. Like I'm gonna show you what I mean. So y is equal to sine x. That's y is equal to sine x. And y is equal to 9 plus 2x. Yeah, so Nikolai, the solution will be the what?
The point of intersection. Wait, so that's basically it?
Yeah.
And it's 4 max for that? I
Yeah.
thought that whole set working for it.
No.
Ah, okay.
So I could send you what I did for this question.
Yeah, you could. Now, a lot of you guys, another way to you could have worked the question, you could have say sine 2x over cosine 2x is equal to 1, and then you have find tan 2x is equal to 1. you could probably say let 2x be equal to n or something, and say you have tan n is equal to 1. You'd find n, so that'll be tan inverse of 1. Where's tan inverse of 1? Somebody tell me fast, where's tan inverse of 1?
45.
45.
Right? And that in degrees would be, well, that in degrees is 45. In radians is really pi over 4. I think. Check that for me.
Yes, sir.
So here what? Let's find the other solutions now. We want to figure out where tan is positive. Wait, if you recall, everything positive in the first quadrant, only sine positive in the second quadrant, only tan is positive in the third quadrant, and only cosine is positive in the fourth quadrant. And our reference angle is pi over 4. When I do the question, when I'm actually doing this topic, I'll go over this in more detail. But my first answer would be pi over 4, and my other answer would be found in the which quadrant?
The third quadrant.
The third quadrant, right? So as you can see, we have 180 degrees, which is pi plus pi over 4. So somebody tell me fast, what is pi plus pi over 4? So pi,
125 degrees.
wait, now tell me in radians.
5 over 4 pi, sir.
So that'll be 5 pi over 4, yeah?
Yeah.
Yeah, because pi, you can write pi as 4 pi over 4. And so that'll be 5 pi over 4. And so these are your two values for n, but you had to recall that n was equal to 2x. So if you actually want to find for x, you're going to have to divide the two answers by
2.
By 2. And so x would be equal to pi over 8, and the other value for x would be 5 pi over 8, which is what I believe you got here graphically. Yeah. So this is another way you can do it fast using tan, but I feel like this is real work.
Is that real work? You can check what I've done yet.
I'm scared to see what you do. I thought you would do like that. No, you do the same way as me. Michael, you do the same thing I do.
Oh, yeah.
Yeah, what? You divide 12 by cosine 2x, and you find tan 2x is equal to 1. Yeah, the exact same thing. Yeah, that's fine.
That's how you then have like in different revolutions and the solution after it look different.
Nah, I do that same thing, watch.
Oh, yeah.
Yeah, we do the exact same thing, Michael. Exact same thing. But I hope you all understand something. Anytime I have one function equal to another function, the solution will just be represented by the what? Virginia, see you unmuted. Anytime you have one function equal to another function, the solution will just be a what?
The points of intersection.
Oh, that's all. That's all. The points of intersection. So, Nikolai, I hope you understand anything now.
Yes, sir.
And Nikolai, look what they said. They said hence. What does hence mean?
Like from the previous question that you answered already.
From the previous question. But I know for a fact, a lot of you guys would not be thinking about points of intersection when you see this.
Nope.
I know that.
No, sir, I saw those word 4 marks, and I didn't think just reading it from the graph would I get the whole 4 marks now.
Excuse, sir. You know what I
Yeah.
thought this was?
What?
I thought this was the identity matrix, like how you had to get this side is equal to that side.
Yeah.
Yeah.
Nah. A nice question, boy. A nice question. To see who know this stuff real good. But people are here in the Zoom right now. How much of you guys knew that when you put one function equals to another function, you're really just solving simultaneously and you're looking for the point of intersection?
Well, I learned that in school.
So I think some of us figure it out from the last maths exam that came. They brought a question similar to this.
Okay. This is the 2025 exam, eh? Latest one.
Oh yeah, this is it then.
Yeah. I just retype the paper to make it look a little nicer. Put some colors on thing, you know what I mean?
So,
That
would it have different questions that would have like the same concept of what we just did here?
Yeah. A guy actually sent a really nice question from the 90s. We can look at it if you want.
Yeah, let me look at it too.
Oh, yeah, maths is the best, but I can never get fed up of doing maths. I don't know how excited maths make me. I wish I could have just transferred that love to earlier. I know you're not much of the exam for sure. I mean,
So you would have to charge for that, you know?
low key, yeah. I would have had to charge for that.
Excuse sir.
Yeah?
I could love maths when I pass it too. And I have ways of doing it. One, you could either do my exam, I could just make your hair curly and your pigmentation a little less like a darker color to me. And just walk in that exam and pass it for me, sir. Yeah.
So
Excuse
basically,
me.
for Michael Jackson and
Yeah, you could do that on a
So I'm not sure if I missed it, but how did you figure out how to draw the graph of itself?
By the way, guys, wait, if you want the detailed solution for this, all you had to do, head on math vibes, just look up add maths. I don't know if you'll find it though. For like add maths 2025. I wonder if you can find it, boy. Wow, that's crazy. That's crazy. That's crazy. Big up, big up, big up, big up. Right? You just press this. And yeah, explain the question in like extreme detail. Right here. Yeah, boy.
Excuse sir.
But I will explain it in this class, but just saying now, just saying. If you want the in-depth solutions, right on my YouTube channel. Alrighty. Yeah. Yeah. Somebody was saying something?
Yeah, so you just do applied maths for Cape? Well, teach
Nah, I don't do applied maths, but I'm looking
damn.
into getting teachers to do that for me. Like teachers that I trust, obviously. Yeah. I could teach pure maths and applied maths, I just do all the time. So all the time. Yeah. And I
yeah,
have
but
like
I
a
had a year
much
degree.
what's that again, Michael?
No, I was gonna ask if it ever had a year if they brought a tan graph. Because I didn't
I
see that.
imagine they come this year.
Yeah,
That would,
I know how to draw it, but yeah.
Don't see Danas.
no, it'll be fine, it'll be fine. The tan graphs look like and it approaches have an asymptote as it approaches 90 degrees.
So I can never remember the name for that.
Asymptote?
Yeah, for
I
some
know how
reason
to
I
see
was
it, but I don't know how to spell it.
Oh, I see. But here, well, let me just show you how to plot this graph quick now. I'll go and show you like a real sketch method to like plot it. Alright, are you ready for the sketch method? I guess we taking a little detour. I guess we taking a little detour, guys. Guess we taking a little detour. So here we're gonna do, right? I'll how about like sharp? I was in sharp. What? Come to me, boy. I playing up. Hey,
you're converting.
no. Hey, make sure you have your Casio calculator by your side. If you have a sharp calculator and you're doing hard maths, you hate yourself bad, but real bad. What you doing now for? So,
I had was to go quite down south to buy a Casio because nobody had no Casio.
hey boy. Big up Shiva one time. So here what I was saying, guys. Could you guys tell me like the main points you would need when plotting a trig graph? What are like the main angles you typically deal with? Right, like 0, what else?
Pi
Okay,
over
like
4.
0, 90, or 180,
360.
360? Oh.
7, 360, right? Now, here what I saying, here what I saying, all right, here what I saying, right? Now, I want you guys to look at this over here. You have an angle multiplier. If you have an angle multiplier, it's going to double the amount of revolutions you have from 0 to 360. And let me explain why. If it's 2x, any angle I put there is going to be multiplied by
2.
all you understand what I'm saying, right? If you put in an angle there, it's going to be multiplied by
2.
Alright, obviously if I put in 0 degrees, that's just going to be 0. Big up Paul from our right science. Yeah, that would just be 0 degrees. If I were to put 180 into this trig function, what would it take it as?
360.
360. And from 0 to 360, I have a full what?
Revolution.
A full revolution. So here what I'm saying, right? Aren't these the typical angles you would use when you plot on a regular graph?
Yes, sir.
But seeing how we're dealing with 2x, you know what I'm thinking to do? I thinking that maybe I should divide these by 2.
So, sir, the whole thing will cut the periodicity in half, basically.
Yeah, that's correct. It'll cut the periodicity in half. That's what we'll do. Yeah. Because you would have 2 periods in the same amount of angles, in the same range. So here what I'm saying, right? Do you guys understand that we'd have a full revolution between 0 to 180 degrees?
Yes, sir.
So I'm going to ignore 270 and 360 for now. And just focus on 0, 90, and 180. Now between 0 and 90, you have what?
45.
And between 90 and 180, you have what? If you don't know, just add 90 and 180 and divide it by 2. That'll be 135.
Oh, sorry.
That's okay. It'll be 135. 90 plus 180 is 270, and 270 divided by 2 is 135. Now, I want you to look at the if this would help you, convert these angles here to degrees. To convert an angle to degrees, remind me, pi just means how much degrees?
180.
180.
So this is 180 over 4, which is what?
45.
45.
I don't want to put the approximation sign, 45, right? What is 180 over 2?
90.
90.
35 over 4 is?
$135.
135.
And well, obviously pi is 180 degrees, right? So,
Yes.
okay, hear how easy this is. I promise you, it's real simple. This real simple, I swear. So, they want me to draw a graph of sine 2x, right? All you had to do, guys, is just plug in. You could, if you don't want to work in radians, it's fine. You could just, in the calculator, you're just going to put sine 2 by 45. What is sine 2 by 45? Sine 90. Where's sine 90?
Radians, sir?
Sine 90 is?
1.
Again, sine 90 to be 1?
Yes, sir.
Yes, sir.
Okay. So that would be over here then, right?
Yes, sir.
Sir.
Okay, here we are. Listen, I'm confused. I don't like that confusion. Here what I'm saying, guys. If you have a function and the function is sine 2x, we would look at this in maths. Remember, if you have a function and you want to get an output, we're going to plug in
The input to
X
get the
value.
output.
x values. Isn't this the x-axis technically?
Yes, sir.
Yes, sir.
Yeah, so all I'm going to do, I'm just going to plug in the angle, which is 45. So that'll be sine 90. Where's sine 90?
1.
So in other words, when I plug 45 into the function again,
Oh, yeah. 1.
again, what? So that's my first point over there. And if you want, you could also generate another point. Remind me, guys, if you put 0 into this function, where's sine 0?
0.
0.
0. That'll be over here. Right? Let's look at let us quickly look at pi over 2. So pi over 2 is 90. So in the calculator, you're gonna put sine 2 by 90. What's sine 180 degrees?
0.
0.
0.
Are you getting that right? So that'll be 0.
Yes, sir.
Okay. Are you sure are you with me so far or not?
Yes, sir.
Yes, sir.
Okay. And in the calculator now, you're gonna put sine 2 by 135. What's sine 2 by 135?
And that's 1.
Sine 240, which is
Negative 1.
Negative 1. Oh, this is real easy, you know. I'll even see how simple this is. I think I've already seen the shape of the graph for me.
Yes, sir.
Yeah.
And where's sine 180? Well, 180 by 2.
0.
0.
0, sir. 0.
So the person that asked me to sketch this, this was a guy. Who was that? I want to explain it back to you if you're so
Whatever. So
confused.
ask you to do the same thing too, sir.
Somebody was saying that they didn't fully understand how to draw the graph. I want you to unmute and talk to me. If you're still confused by anything, that's okay. Just tell me, I'll go by it again. If you're confused still.
I understood up to where you are right now, sir.
All right, so DeAndre, do you understand that if you want to generate points, you're going to take the input, the x value, and you're going to plug it in, and that will give you a y value. So, our function, what is our function? Well, they want us to plot sine 2x and cosine 2x, right?
Yes,
So,
sir.
let's just say you want to plot the graph of y is equal to sine 2x. Starting off over here, what is your angle?
From
If
the
you start,
right 0.
if you're starting at the origin, what is the angle? Yeah, help, that's a bit, but it's 0, 0. This is 0. That's 0.
Okay.
Wait, you know that, right? So like at the origin, it's 0, 0.
Yes, sir.
Right? So over here, the angle will be what?
0.
It'd be 0, right? And I'd plug that into my function, so I'd get y is equal to sine 2 by 0. And what would that be? Plug that into the calculator in degrees or radians?
If it's in radians.
You can put it in degrees if you want. Make it all simpler for you. Yeah, so in the calculator, I want to put sine by 2 by 0.
So that would be 0.
Right, so tell me, right, DeAndre, when the angle is 0, the output is?
0.
Good, so that's 0, 0 over here, right? Because for a function, a point is an x value followed by a y value. So the x value is what we plugged in, so we plugged in 0. And when you plug this into your calculator, you got to output at what?
0.
Good, so 0, 0. That's my first point. 0, 0 is my first point. Right? What is the next notable value that they told us?
Pi over 4.
Pi over 4. Pi over 4 is 180 over 4, which is 45 degrees, right?
Yes.
So we're going to plug that into our function. So that'll be y is equal to sine 2 by what?
45.
Right? Which is y is equal to sine 90. What is sine 90?
Just nothing radians. Because I'm getting 0.89.
Oh, no.
No,
Pay calculator in degrees. Pay calculator in degrees. I'll say how to work it in degrees to make it a little simpler. Make sure you calculate it in degrees.
So 1 second.
So Nikolai, if they ask you to graph, you're good, right?
Yes, sir.
You're just using a calculator. That's all. Yeah, DeAndre again, Drew.
Yes, sir. Start getting 1.
Right. So when the angle is pi on 4, which is 45, and you plug it into your function, you're getting what?
1.
Right. You understand?
Yes.
Right? When it is pi on 2, which is 90 degrees, I'm going to put that into my function. So that'll be sine by 2 by 90. So plug that into the calculator and let me know what you get.
Zero.
Good. So at pi over 2 is 0. So I'll put it over there. You following?
Yes, sir.
Right. The next value is 3 pi on 4, which is 135 degrees. So in the calculator, you're going to put sine 2 by 135.
-1.
Right. So when the angle is 3 pi on 4, I'm going down to -1. So that's this point over here. And you could start to see, DeAndre, that it's starting to look like a what?
It's making not, I want to use the word revolutions, but
Yeah, it's making a revolution, and this is the sine graph.
okay.
This is sine 2x. And if you wanted to plot cosine 2x, it's the same process, right? It's the exact same process for cosine 2x. So let me try to plot that quickly. So everybody in class, are they okay with sine 2x? Until they see any shape of it?
Yes, sir.
Cool. Cosine 2x now. Cosine 2x, we tackle that quickly. If it's cosine 2x, then we're going to start off with cosine 2 by 0. What that will be?
1.
Starting off over here, 1. Right? The next angle of interest is pi on 4. So that's going to be called cosine 2 by pi on 4. We know pi on 4 is 45, yeah?
Yes.
So where's cosine 90?
0.
So I'm going to put that point over here, yeah?
Yes, sir.
Tell me, DeAndre, you understand or no?
Yes, sir. I understand now.
Well, here what DeAndre, I want you to tell me how I should plot this one over here. So pi on 2 is 90 degrees. So I want you to plug that into the cosine 2x function and tell me the output.
-1.
Are they agree with him? -1?
Yes, sir.
Everybody with him or not?
Yes, sir.
Yes.
Okay. Then we have 3 pi on 4. 3 pi on 4 is what degrees again?
135? Was it? Yeah. I think so, yeah.
Right? So
Yeah.
that'll be cosine 2 by 135. Where's 2 by 135? What's cosine 2 by 135?
0.
0.
So that's gonna be right here, yeah? Right here.
Sir.
Yes, sir.
And well, lastly, we have the 180 degrees. So that'll be cosine 2 by 180. What would that be?
1.
1.
1. So easy peasy lemon squeezy, guys.
Yes, sir. I always thought this was difficult, because I never really looked into how we plot this thing now, sir.
DeAndre, you see it or not?
Yes, sir. I learned it in school, but I didn't actually practice it. So that's why I was confused.
Same
But
here.
explain them.
No problem. Easy with your calculator. And well, watch it. So this over here is a cosine 2x graph. Kinda bad, but yeah, whatever. And this over here is a sine graph. And so let's see any points of intersection right here and here. Watch. Are you seeing it or no?
Yes, sir.
And that would represent the solution for sine 2x is equal to cosine 2x. This would be pi over 8, and this would be 5 pi over 8. Yeah, easy. While we at it, let me do the I want to wrap up integration, guys. I want to wrap up integration. So let me answer this. Any volunteers to answer this question?
Yeah.
I could do it.
All right. What she do?
All right. All right. So, who's this?
Maya.
Maya. Okay, no problem. So Maya, I gotta leave that square root there.
No, you go and change it to in brackets 2x plus 1 to the power of a half.
Cool. And what form is this in? What form is this in?
ax plus b to the power of n.
Right. Ax plus b to the power n. So it come like we're gonna do the reverse at the shortcut of the chain rule. That's what we're gonna do. We're gonna do the reverse. And so if you do the reverse, you'll have to do what to the power?
Minus 1.
Nah,
No,
you
add 1.
integrating.
Sorry. Add 1.
Add 1 to the power, and then that'll be divided by?
A by the new power, which is n plus 1.
Good. So let's apply that over here. So tell me what to write.
So 2x plus 1 in brackets to the power of a half plus 1, which is 1.5.
Right?
Or,
And
or 3 over 2.
right, that's true. I would put it for working, so I wouldn't confuse anybody. And then
And
that
at
would
the
be
bottom, you're doing 2 by, in brackets, a half plus 1.
Mariana, let me know if you understand it.
Plus C.
If not, Mariana, tell me. I'll try to go it over again. Mariana, if you're still here, let me know if you understand it. Can I hear Mariana? People in class, can you guys recognize that this and this is in the same form?
Yes, sir.
There was a guy in class that was having trouble. Lani, can you see that this and this is in the same form?
Yes, sir.
Lani, tell me what A is. If you're comparing it, where's A?
2.
Where's B?
1.
Where's the power?
A half.
Good. So if you see something like the square root of 2x plus 1, you're going to convert that square root to a power of a half. Right. And so we added 1 to the power, which is a half plus 1, and a divide. So A is 2, and the new power is a half plus 1. So we're going good so far. What next, Maya?
So in brackets 2x plus 1 to the power of 3 over 2 all over 2 multiplied by 3 over 2 and plus c.
There's more we could do. What's 2 by 3 over 2?
3.
And I have a question, right? If I have something to the power 3 over 2, consider we had a to the power 3 over 2. Utilizing the rules for indices, wouldn't that be a to the power 3 raised to what power? Correct, because power to power means you have to what? Power to power means what?
Multiply.
Yeah, Maya. So, do you understand that this and this is the same thing?
Yeah.
Good. And so, you're probably saying, so why tell them that? Well, I'm saying that because we could write that 2x plus 1 to the power 3 over 2 as 2x plus 1 to the power 3, all raised to what power?
A half.
You can see why we're doing that just now. And well, in the denominator.
That's the end. Why are you doing that?
Oh, so I wouldn't, final answer wouldn't be a fractional power. And yeah, you can see what I mean just now. And where's 2 by 3 over 2?
3.
And if I have something raised to the power of half, what do I mean?
Square root. So by this time, yeah, we square root. So.
No, I think I honestly believe that if you simplify it up to this point, it should be fine. But I would always recommend my students to go the extra mile and do this.
Okay.
I confuse you, you understand these steps?
No, I understand.
Okay, good. So raising something to the power half means what?
Square
People in
root.
class. Not just Maya, but people, a lot of people in class. Raising something to the power
It's
half.
square roots.
The square
Any
root.
number.
Right, so if I have 2x plus 1 to the power 3 over 2, I could rewrite that as 2x plus 1 all to the power 3, which is entirely raised to the power half. And so it becomes the square root of 2x plus 1 all cubed over 3 plus c. That is a day. Okay,
So
let's move on. I feel like I got a little 3 marks.
Definitely.
yeah.
Yeah, for sure.
Okay, good. Hey, do say when you see the exam that you don't know how to do a square root and thing, as soon as you see square root,
Half.
right? If you saw cube root, what that will be?
A third.
It's
If you
it.
if you saw cube root 2x plus 1 to the power 2, what that will be?
A third multiplied by
Power
half.
2 to 3
Wait,
over
a
2.
third multiplied by 2.
Yes. So those stick. Convert it as something raised to a power and then deal with it accordingly. Over here now we have sine 2x plus 5 cosine x. Who's a call with this one, boy? I know it had somebody with trouble. Hey, Kevin over here. Kevin, you there? Kevin, you alive? Can I hear him, Kevin? Anybody want to help more with this question?
I don't mind.
All right. So Nikolai, if I integrate sine 2x, what that'll be?
That will be a half. No, minus a half cos 2x.
Oh, minus a half cosine 2x. And if I integrate 5 cosine x, what that'll be?
It will be 1 over 5.
Whoa,
But
whoa, whoa. Whoa. Take your time. Take your time, Nikolai. Take your time. They don't want to tie up, but don't let them tie up. It is 5
oh,
times
wait.
cosine x.
Wait, it could be 5 sine x.
Yep.
Right.
And we mustn't forget the
Plus c, because it's not bounded by 2 points.
good. And just like that, you get 3 marks. Yippee!
Easy marks.
So, did I get 6 marks just like that? 6 marks just like that.
6 marks in the bag.
Yep. Well, if you like, I get 3 marks, eh?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Badness. Hey, let me move on to area now, no? So, finite integration. All right, cool. So when I say definite integral, it means I have a upper bound, upper bound, no?
Lower bound.
Right. And you would typically see it like this. So, integral of AB. And for this to work, B needs to be what than A? Less than A or more than A?
What I need?
Yeah. Because it's the upper bound, right? It'll have to be more. F of x dx. And that would be equal to the integral of f of x, which is denoted by the capital Fx. And you're going to plug in your upper bound and your lower bound. And that'll be equal to f of b minus f of e.
Excuse, sir.
Yeah, Nikolai?
I remember last time I know I was supposed to do a question like this. Instead of understanding, I tried to memorize it, and that did not work.
Okay, memorization or no. You want to wish them Sharon good luck? Let's see. You want to wish them good luck?
All right, good night. Good luck in exam.
Thank you, good night.
Thank you, thank you.
Yeah.
Say some prayers for we.
Okay, will do.
I got light some incense for you. Yeah, I got light some incense for you. I'm saying I'll praise the word. So let me tackle this now. And you
Yes.
know, you use definite integration when you're trying to find for what?
The area under the between the 2 points or something. Or
Area.
on the graph.
Right. So hey, let me not dilly dally, jump straight into it.
Yes, sir.
Right? Who wanna help me with this question?
Yeah, me. There you go.
All right, give the question. I'll read from it.
Figure 1 shows the region enclosed between the x-axis, the y-axis, the curve y is equal to x squared plus 2, and the line x is equal to 3. Calculate the area of the shaded region.
Oh, I forget I draw this. I literally draw this by hand. Oh yeah.
Aye.
Yeah, what? Well, as I draw this in, oh god. Yeah, boy.
Huh. You gotta take your time, sir.
Yeah, dedication, boy, dedication. Right. So when you read the question, they're saying figure 1 shows the region enclosed between the x-axis. This is the x-axis for those of you guys that didn't know. The y-axis, for those that didn't know, this is the y-axis. And the curve, this is the curve, y is equal to x squared plus 2. And the line x is equal to 3. So here what? If we want to find the area of the shaded region, we need to find the upper bound and the lower bound. Don't look at it, don't look at it. Stop looking, stop looking.
Yes, sir.
Stop looking.
Oh.
Are you being very naughty here? Being very naughty. So, Nikolai, can you tell me the upper bound?
The upper bound is x is equal to 3.
Right. And what will the lower bound be?
X is equal to 0 because it hit that line over there.
Are you
But
seeing that? Yes. Are you seeing now or no?
Yes, sir. Yeah.
A lot of students would have had a quote unquote hard time figuring out what the lower bound is. As you can see, the lower bound is the y-axis, and we know the y-axis is just x is equal to what?
0.
Good, x is equal to 0. So, Nikolai, to find the area, it's just going to be the integral from what to what?
Upper boundary and lower boundary. So it'll be b over a. Well, b on top.
What, we just jump straight into it. What is the upper?
3.
3. Upper is 3. What's the lower?
0.
Right? And what is the curve?
Y is equal to x squared plus 2, but we will just say x squared plus 2.
Good. So let me start.
Yes, sir.
How is this going to look? Well, I'm going to, as soon as you start to integrate, put your square brackets, please. So, Nikolai, how are we going to integrate that?
We'll add 1 to the power and divide by the power, so it'll be x cubed divided by 3 plus 2x. And then we put on the outside the 3 on top and the 0 underneath.
Everybody with me so far or not?
Yes, sir.
Yeah.
Sir.
Yes, sir.
All right. This is add mass, not mass paper one. And
So,
then we're going. Yeah, someone, you were saying something?
the 3 and the 0, right? That's from the y-axis and
No, those are the
oh wait, the x. Okay, right.
Yeah. So here what, right? Shivan? We are integrating with respect to x, so the bounds are going to be defined by the x-axis.
Yeah.
So x is 0 and x is 3. And so to work this out, hey Cameron, big up yourself. To work this out, we have to plug in the upper bound into the integrated function. And so what's that going to be, guys?
It will be 3 cubed divided by 3.
Right, 3 cubed over 3 plus
2 in brackets 3.
Minus
0 cubed divided by 3 plus 2 in bracket 0.
Right? Now here what tell it? This whole thing, this whole thing gonna be what? That whole thing is gonna be what? That whole
0.
thing. That whole thing is
Because
gonna be.
multiplying 0 will result in 0.
And what would this work out to be?
15.
15.
All I had to get is marks, right? So 15, and it'll be 15 units what?
Squared because it's area.
Exactly, 15 units squared. And so again, now 4 marks easy.
Yes, but before, no.
But this, I feel like it's one of the more straightforward things, right? So here we're seeing, guys, you're integrating with respect to x. So your bounds are going to be formed by x is equal to 0, x is equal to 3, x is equal to n essentially. So like, they could ask you to find the area bounded by x is equal to 2 and x is equal to 3, you know. They could ask you that.
Yes, sir.
Right.
People being naughty, they see the answers.
Yeah, they've been very naughty. So we did one area question. Let's do another. Let's do a harder area question. Who wants to help me with the harder area question?
So I could have done that, and somebody would have done the easier one.
Nicola, you're just getting too excited, buddy.
Nah, I had to pass this hard maths, sir. I had to put in the work.
Nicola, after all this said and done, I'll do an interview with you. Like you will be like, mom, you'll be like inspiration for the future generation.
Yeah,
You know
right.
what I mean?
I'll put a lot of life-changing events and some life-saving advice.
Who wants to do the harder type of question, mama?
I would have say me, but I done do one already.
Yeah, you already do one out now. Any volunteers to do the harder type? All you're sticking, boy. The exam is Monday, you know. Hey, the exam is Monday. I find out
If
you're
nobody
sticking.
doing it, sir, if nobody doing it, I could do it. There you go.
I guess Nicola, you gonna do the question mark again.
Yeah.
Here's a nice one. Here's a nice one. Why they sticking so far, boy? The exam is Monday. Like I'll be afford to be shy and thing. Or have shame and thing. Like you had to do what you had to do to get grades. Right? So Nicola, get this a read from me.
Using the integration method, calculate the area of the region of the first quadrat under the graph y is equals to 3 sine x.
Good. So here what? I know we're gonna stump you guys. You're gonna read this and you're gonna be like, oh, panic. What do they mean by first quadrant? What? What do they mean by that?
That is where all the sine, cosine, and tangent is positive.
Everything is positive.
Yeah. But even simpler than that. So to answer this question, maybe you might want to do a little sketch, a quick sketch. So for sine x, right? So here we're gonna do a quick sketch. In the first quadrant on the graph y is equal to 3 sine x. No problem. So does everybody understand that the sine graph looks a little something like this?
Yeah.
And if we're talking about the first quadrant, we're talking about from which angle to which angle?
Which angle to which angle?
90 degrees.
Yeah, Nikolai, remember? 0 degrees to.
Ah, like that. Okay, yeah, 90 degrees then.
So the first quadrant would be the part of the sine graph between 0 and
90 degrees.
right. So Nikolai, you understand that, right?
Yes, sir.
Okay, so Nikolai, to figure out this quickly, remind me, what is sine is of 0? Sine of 0 is 1.
That was 1. That was 1.
Man, the
Zero.
sine graph, that
Oh, that
was
was 0.
Another angle we could potentially look at is 45. If we
And
want to do a sketch, right? Where's sine of 45?
Again, root 2 over 2. But I don't know if that is considered as half or
What is your 2 over 2 jump?
0.7.
0.70. Well, 0.71.
And then we could look at 90 degrees. What's 90 degrees?
That would be 1.
Right? So you guys understand on the part we're looking at. Wait, you sure?
Yeah, sine 90 is 1.
90 is 1, sir.
That's true. So, one second. One momento.
They would give you marks for your marking down, like sketching the graph and everything.
Yeah, well,
Sketch.
a proper sketch would be nice. So over here is 0. Over here is 360. And I know over here should be 180.
Yes, sir.
I know sine 180 is 0. Is it?
Yes, sir, that's correct because sine 90 will go in the middle and it'll be
Yes, sir.
the peak of the graph.
Yeah, but the sine 90 is 1.
Oh, I thought this is sine 90 is 0.
What? Nah.
That is why I was tweaking. That's why I was tweaking. I thought they say it was 0.
Oh, no. It was 1, sir.
Oh, okay. I'm not tweaking anymore. Good. So do you understand that this is what it would look like roughly speaking?
Basically, yeah.
So that would be bounded between
But didn't they say 3 sine x?
don't worry about that. The 3 sine x is just the amplitude multiplier. So instead of 1, it will really be what?
3?
Yeah. And instead of 0.7, it will be 0.7 times 3, which is 2.1 something. Should be. I think.
Yeah, no, 2.1.
Right. I'm running back the thing because I was like tweaking for a bit there. I was like, what? Oh, let's say 0. So they run it back again, right? In the question, they want us to find the area of the region in the first quadrant. Guys, if we're talking about the first quadrant, then we're talking about the part of the graph that goes from 0 to what?
90 degrees, sir.
Oh, you understand that or no?
Yes, sir.
Yes, sir.
Right. When you're doing these types of questions, you typically prefer to see it in radians, right? Just saying that out loud. So if it's in radians we're dealing with, it'll be 0 degrees to what?
Pi over 2.
Oh, well, yeah.
And if it's radians you're dealing with, you can put a rad, you can put that. I'm not sure if you guys did it like this, but this also means rad. I'll see on top.
Yeah.
Yes, sir.
So Nicola, you understand? This is like the area where to find, right? So like, wait, yeah. So this will be a pi over 2c. So we have to find this area over here. I'm running back one more time. People in the class, until you understand that the full sine graph would look like this.
Yes, sir.
Yes, sir.
Yeah.
Watch it. Watch. This is 0. This is 180. And this is 360. So wouldn't 90 be like right would be over here?
Yeah.
So this is what we had to find, that's what we had to find. Which is where you could see over here. This is what I draw. I'm gonna do all the roll call because I feel like a lot of you are confused. I need to clarify the confusion now. Liam, Aliyah, Adriana, Alicia, Amelia, Ari, David, Gabriel, Ishmael, Joshua, Kevin, Lani, Megan, Maya. How are people here, boy? Virginia. All you understand? Or no? If you don't understand, that's fine. I'll go over the whole thing. Yeah, tell me if you understand.
Don't understand.
I understand.
Isn't that just the angle formed?
Angle formed? I wouldn't really say the angle formed. But again, in the question, they said in the first quadrant. So immediately, it's from 0 radians to
90.
90?
pi over 2 radians, right?
Oh, sorry.
That's okay. So immediately I know that my upper bound is what? What's my upper bound? Come on, Nikolai, what's my upper bound?
The pi over 2.
And my lower bound is
0.
bam, 0.
So in
So
that advanced exam, you can see real graphs in that thing.
yep. So the area is just going to be 0, pi on 2, 3 sine x dx. So then they're gonna integrate. If I integrate 3 sine x, what will be, Nikolai?
Minus 3 cos x.
I feel like so much all I confused about the answer, you know. Any question, they say first quadrant. What do I mean? First quadrant, I mean 0 to 90 or 0 to pi over 2. That's all. So my lower is 0, my upper is pi on 2. That's all. The silence thing, I don't like that.
Yeah, sir, I understand, sir.
Okay, good. So we're going to plug in here, Nikolai.
We will plug in the pi over 2.
We're going to plug over here.
Well, we could put the same minus 3 cos, but this time it will be 0.
Right. What is minus 3 cos pi on 2?
I get in minus 2.99, but I never put it in radians.
Make sure it's in radians, otherwise you're wrong.
Serious?
Yeah,
So I
Nikolai.
guess 0.
Yeah, Nikolai, remember, radians is a different way of measuring the angle, and radians has to do with the ratio between the length and the radius.
I get 0.
Let me plug it in. Minus 3 cosine pi over 2 minus 3.
Ah, I did not do that one.
3. Again 3.
I would have gotten a 3. Well, I just only did the first one because I thought day 0, and you
No.
multiply it, the whole thing would have been 0.
Cosine 0 is 1.
Ah, yeah.
Anybody else get 3 or not?
Yeah, I get 3, sir.
Yes, sir.
Yes, sir, I
Yes,
get
sir.
3.
Yes, sir, I get 3 then now.
Good. So I have a question. If they say in the second quadrant, then if they say in the second quadrant, that will be from what to what?
90 to 180.
Yeah, 90 to 180.
So if they say second quadrant, right? Your lower bound will be what?
90. 90.
Yeah,
And the
but
upper bound will be what?
180.
180.
180.
But we typically don't write it like that. We typically don't write it. When we do the integration, we typically don't write it in
2
degrees. So
pi
let's
and
say,
pi.
So
let's
pi
say
over 2 and pi.
exactly. So you need to know how to deal with questions like that in case it does come. So here what? Oh, and let me see if I could show you something cool, huh? Give me a second. Okay. I want you guys to look at the so look at the area. I kind of is it? So I'm talking about like if you were to count it's not 100% accurate. It's not 100% accurate. Nah, it's not 100% accurate. Yeah, you might be able to see it. It's not 100% accurate.
But the point is still correct.
Yeah, it is correct. But like the point I'm trying to make is if you add up all the units, you'll get 3. So like what? You essentially what you have like essentially 1 here. You can like add up here and get 2, and add up the rest and you'll get like 3. So I'm trying to see. like it kind of looks like 3 units. Yeah. So I'm trying to say, it's not the easiest thing to see though.
So
But anyways, here what do this question. In the fourth quadrant, if you get negative area, that's fine. It just means that the area is underneath the x-axis. Okay? That's what it means. So okay, try this one in the fourth quadrant. So I'm going to give you all 3 minutes. Go.
So does it have to be in radians?
Yeah, write it in radians. Write it in radians. It's just
Okay.
the typical way in which you write it.
All right.
I so ready to just move on to trigonometry. Trigonometry is real vibes, but
sure, how to pass that trigonometry question, sir?
So I don't know if I make a mistake, but I get 0 for the area.
okay, 0. 9, I'm supposed to get 0. Because if you look at the fourth quadrant would be
Oh shoot, sir, I see my mistake. I used 180 instead of 270.
oh, yeah, let's take it down. If you're confused, I'll try to explain it back to you guys. Don't worry. I'll try to explain it back. I can see how it look confusing. I could see, don't worry. I could see how it might look confusing. All right, so you have 50
So
seconds.
the answer would be negative 3 unit square.
Negative 3 get.
Yeah.
And so that would just mean that the area is underneath the
The graph, the x-axis or something.
correct. So you'd say the area is 3 units squared underneath the x-axis. Because truth be told, it can't really have negative area. But it's negative because you understand that it's underneath the x-axis. So let me yeah, Nikolai?
Right? That means we in the back rooms.
Huh?
That means we in the back rooms. With negative.
Yeah, but we're in the back rooms. So I heard that somebody is confused. So let me explain something. You don't have a name on TikTok, so I can't really figure out who you are. But you could do a sketch if you want, but it's not the most important thing. The most important thing is I figure out what it means. Right? So somebody that is confused, I want you to come to the front of class and I'll make sure you understand after. If you're confused, it's a prime opportunity to understand it.
I confused.
No problem. So Gabriel,
Yeah.
by the way, your profile picture that looking like Power Rangers low key. But I wanna
No,
say that too. Oh no,
yes.
wait. And I think I know that's Kiss.
Yes, it is.
Yeah, that's Kiss. It
Yeah,
looked like samurai. It looked like samurai rangers or like some Power Rangers. When I was like, I see the guitar, I was like, that'll be Kiss.
yeah, it
You
is
watch
Kiss.
you watch the Scooby Doo movie?
I did. Oh my days, I
That's peak.
love
That's
that.
peak. That's peak. That's peak. That was a top movie. That was good. That was good.
It's so good.
So, like I old or something, or how I never hear about all these things.
I just know
This
Real Ball. I just know Real Ball. Yeah.
this
I
a really old band, a old, really old rock band, but they had a movie with Scooby Doo.
Oh, well, I real young then.
Probably, I mean, who
Nikolai, no, you just out dog because I haven't got anyone I know about that.
Yo.
please.
Hey, let me explain something. Nicolaitis be here on Zoom doing maths 99% of the time. So he don't no time for them kind of thing, you know what I mean? You know what I mean?
Kiss
Nicolaitis,
was the
Nicolai
movie.
is a man of sheer
Wait,
focus. He is John Wick.
wait, so Kiss is a movie or a person?
No, it's
It is
Kiss
a
Cake.
A band, bro. It's a
No,
band.
no,
it's a
no, 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 Nicolai. Kiss is
band.
Kiss Cake. That's Kiss Cake.
Yeah, guys, who don't love Kiss Cake?
But Nicolai, that's a band. That's a rock band.
I
It's
never
a
see that on the CSEC.
but they had they made a movie with Scooby Doo.
They live in?
Some of them live in. I think two of them died. That's how old it is. Holy moly.
Really?
I want to explain something, guys. Oh, you need meeting? Okay, good. So, if you
I
need meeting, talk to me. That's you on TikTok. That's you that saying, somebody saying, so I'm in
No,
the
no, no,
meeting.
no, no. I don't have TikTok.
Oh, okay. How you know what math vibes then? Because I typically be on TikTok.
No, no. I had a friend who was to watch it all the time.
Oh, okay.
I wasn't in maths. It's the maths one. A
Oh,
couple
the
yeah.
14 hours.
Yes.
Oh, yeah. No, peak. All right. So, Gabrielle, you need to understand that. So, okay, from 0 to 90 is the first quadrant. From 90 to 180 is the
Second quadrant. I understand that part. I understand the 90 to the 180 was the first quadrant.
if you understand this, then it's real easy. You go see.
Yeah.
Math
know
is
that.
never boring. Math is never. I did maths for 24 hours straight and I was chilling after. Maths is the best. I can
Right.
never get fed up at teaching and doing maths. Like, two of the things I love. You know what I mean? So here what? Gabrielle, we see in the fourth quadrant, right? In the fourth quadrant, we need to establish what are the limits in the fourth quadrant. So if we work in the fourth quadrant, what's the lower bound?
270,
270, and what's the upper bound?
360.
Right. We typically don't put the limits as degrees, so
It's in
270.
radian.
So
So
270 degrees would be what?
pi over 3.
Nah. Look, Mrs. Math Vibes joined. They got Mrs. Math Vibe one time. Nah, 270 would not be pi on. Remember, pi means 180.
Right, I know that.
So this will be 3 pi on 2. Because 3
Oh,
by pi is 540, and 540 divided by 2 is
to
270, right?
right.
And 360 would be how much pi?
360 would be 4 pi over 2.
Which is?
360.
You're not wrong, but I wanted to hear you say 2 pi because you say 4 pi over 2, but 2 into 4 is 2, so 2 pi.
So it's 2 pi over 2?
Yeah. No, it's 2 pi, it's 2 pi. No, you
Oh,
had to tell me 4 pi over 2, right? You had to
right,
tell
yeah.
me 4 pi over 2.
Right, 2 pi is 360. 180 times 2 is 360. Okay, yeah.
Yeah, so every quadrant is a 1. Yeah. You can think about it like this, guys. You can think about it like this. So this is 0 degrees, right? This is pi over 4. This is 2 pi over 4. This is 3 pi. Wait, what?
Isn't it? Pi
What's
over 2?
Wait, I'm
Is
trying
right
to
equal?
explain it in a like real simple way. So like you have 4, right? You have 4. And in total is what?
360.
2 pi.
360. Oh,
2
wait,
pi.
2 pi.
Yeah.
But
So this will be 0. This would be a quarter of 2 pi, so 2 pi over 4. Because total is 2 pi, right? So I cut in 2 pi into how much sections?
4,
Right, so that'll be 2 pi over 4.
right?
Um, yeah, this would be 2 over 4 by 2 pi. This would be 3 over 4 by 2 pi. And this would be 4 over 4 by 2 pi. So if you're confused, where's 2 over 4?
A half.
It's be a half pi. This is a half, and a half by 2 is what?
A half by 2 is that's 1.
1. So 1 pi, that makes sense. And 3
Yeah.
over 4 by 2 pi. Well, 2 into 2 is 1. 2 into 4 is 2, so that'll be 3 over 2 pi. And 4 by 4 is cancel off, and then you shall put 2 pi. So what? 2
Okay.
pi. So like 0, then a half pi, then 2 pi. What's in? Yeah, this is 0. Is a half pi. This is pi. This is 3 pi over 2. And it's 2 pi. Which is again, right? So we have total of 2 pi, and we cut it into how much different quadrants?
4.
4. So this would be 0, 0 radians. Then this would be a quarter of the total. This would be 2 quarters of the total. This would be 3 quarters of the total. And this would be the full thing. So that would just be what?
2 pi.
That would just be 2 pi. A quarter of 2 pi is literally just a half pi. 2 quarters of 2 pi is really just pi. And 3 quarters by 2 pi is really just 3 over 2 pi. Yeah. It's real simple. You can just memorize it. But I try to show you how to figure it out. So if I'm trying to figure out the area in the fourth quadrant, you need to identify that your lower bound is going to be what?
What my lower bounds would be 3 pi over 2.
And the upper bound would be?
2 pi.
Good. So if I want to find the area, that would be equal to the integral. I put the lower bound at the bottom, so that'll be 3 pi over 2.
Right.
Upper bound is?
2 pi.
And I'm going to integrate the function 3 sine x. So I'm going to say 3 sine x dx. You understand or not?
Yes.
So the next line you're going to integrate, right? If I integrate 3 sine x, what would that be?
Minus 1 over 3 cos.
Now,
Hmm?
what you're describing there is if you have something like any form sine ex. Okay, that probably confused you. Just summarize. If I integrate sine x, what would that be?
That'll be minus cos.
Cool. So here a way to think, right? So this 3 over here, that's a constant. So forget about that, right? It's a constant. So
Right.
that 3 is there. That 3 is multiplying by sine x. So forget about the 3 for now. If you integrate sine x, what would that be again?
Minus cos
Right, minus cosine what?
x.
Good. Upper would be 2 pi. Lower would be 3 pi on 2. If you want, you could simplify. So 3 by minus cosine x is just minus 3 cosine x.
Mm.
You understand or not?
Shouldn't you have it in like 2 brackets or something?
Yeah,
Like
yeah,
how
yeah.
it done before?
But I just simplified. it.
Okay. Yeah.
I'll give you more to do shortly. And now we could split it up. So I'd say minus 3
Right.
cosine 2 pi, then minus 3 cosine what?
3 pi over 2.
Right? And when you plug that into your calculator, hopefully you should get minus 3.
Okay.
You want to plug it in and make sure?
Yes, I will do that now.
So if a question like
Brief.
this come, I think I'll
The
let you handle
calculator.
it. Yeah, calculator had to be in radians. Had to be in radians.
So I look, you can't find the pi sign in my calculator. It's the Casio.
You have a Casio?
Yeah.
Second function and the exponent button.
Over here. So like you see how we have a yellow pi? Or not? Like right next to ANS. I'm pressing the button plenty of times.
Oh, okay. Yeah, I see it.
So I press shift that. It should give me
Okay.
pi. I don't know why they make the pi so hard to find. I don't know.
Because
Hold
I know
on.
in the colors go with buttons. I was like, where is the pi?
Yeah, where is the pi? Somebody eat the pie.
I was now going to say that.
Nikolai, you eat the pie. You're greedy, greedy.
Oh, my days big.
Still skinny, sir. I need more than one pie then.
That's to tell you how greedy he is. Man, I need one more than one. Hey. Right, so yeah, plug that in. I'm gonna know what's cooking. All right, so we're done with area. Do some volume questions now. Add maths is not something you could just come the night before and just, wing it. You have to be doing a lot of practice for add maths. Yeah, I get -3, so we'll go over that, -3. Now, if it's a negative, if it's negative, right? What does that mean? Well, let me show you guys what that means. So in the fourth quadrant would really be. So where is the fourth quadrant? Can you guys see this over here?
Yes, sir.
That is the fourth quadrant. Is it below the graph or above the graph?
Below.
Below.
Yeah, so what does this mean? So the area is equal to 3 units squared, and you would say below the x-axis. You guys understand?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so you were having some problems with 3 sin x. Gabriel, that was you, right? You was having some problems with that.
Yes, sir.
I run some couple examples then.
Okay.
If I integrate 9 cosine x dx, first of all, does it look like cosine 9x?
Yes.
No.
No.
I have 9 cosine x, which is very different from
Not yet.
cosine 9x.
Right. So just be 9 sine.
Yeah. If I integrate this, it would just be 9 sine x dx.
Right.
However, if I had something like the integral of cosine 9x, then that'll be what?
1/9
Yeah,
sine x.
sine 9x.
Oh, okay.
Yeah, I mean, if you understand.
I did. Because it come like with the formula with the ax in a sense.
Yep.
Okay,
And
yeah.
you need to have an angle multiplier. That's what we just call it, an angle multiplier, to use that one. And 9 is the angle multiplier. What am I doing? Oh. So yeah. Now, well, you know how to handle a question like this, right? If they ask you
Yes.
for the first, second, third, fourth, you know what you're looking at. So speed round. First quadrant, we're looking at which angles?
0 to 90.
Second quadrant, what are we looking at?
90 to
90
180.
to 180.
Fourth quadrant.
180 to 270.
270.
I say fourth quadrant, fourth quadrant.
Oh, 270 to
270 to 360.
And third quadrant.
180.
180 to 270.
All right, speed round. Tell me in radians this time.
Holy.
Third
Okay.
quadrant.
3 pi over
Pi
2.
over
Pi over 2.
Pi over 2.
Pi
Alright.
over 2.
It'll be pi to
Pi
so
over 2.
in the third quadrant that would be from 180
3 pi
degrees.
over 2.
Over 2.
It'll be from 180 degrees to
270. 3 pi over 2.
right, fourth quadrant in radians.
Right. 3 pi over 2.
2 pi over 2 to 2 pi.
Yeah.
Cool. First quadrant.
0 to pi. No, 0 to pi over 2.
Pi over 2.
Good. Nice. Cool. And anytime you're using radians, your calculator must be in
Radians.
Radians.
Yes.
Why am I yawning? Why am I yawning? That's crazy. Don't know why. Don't know why. I don't ever yawn because I never see the dawn.
So just don't yawn. That's it. Just don't yawn.
Wow, that's good advice. That's really sensational advice.
Well, call me motivational spokesperson.
Yeah, it should, it should. So guys, it's the same procedure for cosine as well, right? The exact same procedure. If they say like 3 cosine of sine 5x or cosine 7x and they say first quadrant, exact same thing, 0 to 90. Yada yada yada. Let's find the volume now. Let's do a volume question quickly and see how that's come.
Wait, so why we didn't put C?
Because it's definite integration.
Oh, okay, okay.
When you're doing definite integration and you have an upper and a lower limit, there's no plus C.
Okay.
All right, team here, no plus C. It's a good thing you asked that. Show that you actually understand.
So volume is the one with the limits, like they'll say as x tends to 0 or something.
Not quite. They wouldn't say 10 to 0. Well, let's do a question, huh? Let's do a question. So, who was that? You can do the question one. Who say that? David,
Me.
that was
David.
okay, big up yourself, David. So, get the question I read from her.
Figure 2 shows that the shaded region enclosed between the x-axis and y-axis, the curve y equals 4 minus x squared.
Right. So, can you see that we have a curve here?
Yeah.
Now, this curve is bounded by what? What is it bounded by?
The x and the y-axis.
Well, good. But we're going to integrate this function with respect to what?
Y equal 4 minus x squared.
Wait, that's not what I mean. So, like, okay, so we have a function here. Y is equal to 4 minus x squared. So, we have a function here in terms of what?
X.
Good. So, we need to find our bounds in terms of x. So, like, here's what I mean, right? Like, x is equal to 1, so on and so forth. So, what are my bounds? What are my vertical bounds?
2 and 0.
Good, 2 and 0. That's what I'm looking for. That's what I'm looking for. So, I have a bound here. Let's see, any bound or not?
Yes, sir.
Yeah.
And this will be x is equal to what?
0.
Right? And my other bound will be over here. This is x is equal to what?
2.
Let's see it or not?
Yeah.
Excuse me. Somebody named Troy is asking how is it 0?
All right, no problem. So, talk to me, right? This line over here is x is equal to what? This person that's confused. This is x is equal to
3.
3. This is x is equal to 3. This will be x is equal to
2.
this will be x is equal to
1.
but this could be x is equal to
0.
Will you understand?
Yeah.
Because it's a vertical line passing through 0 on the x-axis.
So, I have a question.
Yeah.
So the upper and lower points are based on where the curve ends?
You can think about it like that. So like the vertical line that it starts from on the vertical line and ends at.
Thank you.
So you see how it begins here. So say X, this is my lower bound, and this here will be my upper bound.
Oh. I understand. Thank you.
And if I take this shape and I were to rotate it 360 degrees, it would create a volume. It would create a volume.
Oh.
Yeah. So here, David, let me continue. So David, do you understand that my lower bound is x is equal to 0, and my upper bound is x is equal to 2?
Yeah.
All right, cool. So remind me, if I want to find the volume, the volume is going to be given by what?
That
Gonna
that
try.
really no.
All right, so the volume is going to be pi.
Right. Yeah, no that part.
Cool. And it's going to be a here.
2 and 0.
Well, I give you the general formula, right? General formula.
Yeah.
Right, where b is more than e. So let's apply it to this question. So that's going to be pi integral a. What's a?
What?
What's a? What can like a?
0.
A is 0, yeah. What is b?
2.
Right? 2. Cool. And y squared now. So our function was y is equal to 4 minus x squared, correct?
Yeah.
So we have to square that. So again, watch. If y is equal to 4 minus x squared, then how am I going to find for y squared?
Just square it. 4x squared times 4x squared.
Well, 4 minus x squared by 4 minus x squared. That's what you were thinking?
Yeah, that's what I was thinking, yeah.
Good. Everybody was thinking this, right?
Yes, sir.
Yeah, we'll be doing on paper 1 for maths. We have quite some time to wait, so yeah. And now they will be repeating the paper 1 questions for sure. So let's expand this quickly. So it's going to be 4 by 4. Then 4 by negative x squared. Then minus x squared by 4. And then minus x squared by minus x squared. So how's that going to work out? Tell me, David.
Just a minute. I'm still working it. So I have 16 minus 8x squared.
Yeah, you got 16 minus
Plus
8x squared.
plus x to the power 4.
For anybody that is confused as to how we got the minus 8x squared, right? I'm going to So 4 by negative x squared, that'll be negative 4x squared. And then you go have negative x squared by 4, which is another negative 4x squared. So you see, we've taken away 4x squared, and we're taking away 4x squared again. So altogether, you would have taken away 8x squared. Good.
Yeah.
So I'm going to replace the y squared bit with 16 minus 8x squared plus x to the power 4.
Yeah.
Is anybody confused, or you're with me so far, guys?
Yes, sir.
With you.
I have a question. If they said true a half a revolution, what you gonna do? If it's half
Half
a
a pi?
revolution. Yeah, that's all. That's all. I don't understand, right? If they say a half or a full revolution. If a full revolution is pi integral a b y squared dx, and half would just be half of that. You understand?
Yes, sir.
So let me work this out quickly. So you have pi here on the outside. They would integrate that from on the inside. Integrate the inside.
16.
I get x to the power 5 over 5.
Right? So I take my time, right? So 16x,
Yeah.
and that'll be minus 8x squared. You gotta add 1 to the power, so you can turn to 3 divided by
3.
Then you're gonna add 1 to the power here.
5 over, and you put 5 there. And 2 and 0. But I had to rearrange the equation to put the powers in order, but yeah.
That's not a problem. You can do that. They don't really care though. CXC don't really care. Like with these types of questions, the main thing is they get the correct integral and just plug in your values. But that's not wrong. That's 100% correct.
Yeah.
And that'll be over 3 plus 2 to the power of 5 all over 5 minus. I mean, the whole thing would just be what? That whole other thing would just be what?
0.
A whole other thing would just be 0. Anybody can tell me why the whole other thing would just be 0?
Because I'm multiplying numbers by 0, which results in 0.
Exactly.
Yeah.
So when you plug that into your calculator, what are you guessing?
I got 256 over 15.
Anybody else getting that? 256 over 50?
Yes, sir.
Yeah, I get it.
So Nikolai again, 256
Over 15. 1 5.
pi, and that'll be units what?
Cubed, because it's volume.
Good. Did you guys understand this or nah?
So it was easy, but like I said, I was trying to remember the answer rather than understand what to do in the question.
That's the problem. Yeah. Alright, so y'all okay with this?
So we
Yes,
get
sir.
a break or something like that?
Say that again, Nikolai.
Yeah. Are we getting a break in between or anything like that?
Yeah, they get a break just now, because I had to eat two, I had to eat two. Right? Right. So are you okay with this question or nah?
Yes, sir.
What about the rest of you guys? Yes or no?
Yes, sir.
Yes, sir.
Are there any other questions? Like one more question I could do on this.
So just do one more volume question. One more.
No problem. This question really easy though. Or do you think I can handle this one?
Yeah.
Yes, sir.
I believe.
Anytime they say y-axis, you can replace y-axis with x is equal to what?
0.
Yeah, anytime you see y-axis, replace y with x is equal to 0, right?
Yes, sir.
So it'll be equals to the x squared.
So that again?
So it'll be as like 0 is equal to the statement.
Okay, well, I feel I should do the question. Gabriel, let's do the question together. The rest of you guys can do the question by yourself. All right, take a screenshot or something and run the question by yourself. What's yeah. Yeah, Gabriel, we tried to work this question out. And this will be it from calculus. Right, so Gabriel, read the question for me.
The region enclosed between the curve y equals x squared plus 1, the x-axis, the y-axis, and the line x equals 2 is rotated about the x-axis through an angle of 360. Calculate the volume of the solid of revolution that is formed.
Right, do you remember how you would find the volume?
Y, I looked at,
Yeah, I remember this, right? So V is equal to pi
right?
integral AB y squared dx. So you need to identify your upper and your lower bound. So what's your upper bound?
0.
Nah. Upper bound is always bigger than the lower bound.
Oh, 2.
And your lower bound is?
What? 0.
Guys, I'll say it again, right? The y-axis The y-axis just means x is equal to
zero, right?
Yeah, x is equal to 0. That's what the y-axis means. Y-axis means x is equal to 0. And so that's why I said my lower limit was 0 and my upper limit is 2. Are you
Oh,
understand
wait.
that part?
Yeah, I think I understand from here now.
And
The curve y equals x squared plus 1, you have to multiply it by itself, and like we
yep,
did from, okay.
because you want to find y squared, so y squared would be x squared plus 1 by x squared plus 1. And when you multiply that by itself, you should get what?
One?
Now, so to expand this, you're going to say x squared by x squared.
Wait.
You're going to say x squared by 1. What next?
X squared by x squared is x squared.
Now, x squared by x squared is x to the power of 4.
What we
Because you have the same base. Okay.
right?
And you're multiplying. So you're going to add the powers. If you're not seeing it like that, a way to understand that x squared means x by what?
X by x is x squared.
Right? And you're multiplying that by another x squared, which is x by x. So you're multiplying x by itself how much times?
4 times.
Right, so x squared by x squared is x to the power of 4.
Right.
Anytime you have the same base, and you multiply and you add the powers, so you both of your bases here are x. And so x squared by x squared is x to the power of 4.
Okay.
Right? And what is x squared by 1?
It's x
So
four
what's
plus 2x squared.
nah. Alright,
But
so
with x squared plus x squared, it gonna have like one is understood to be in front.
wait, wait, one second. What is 5 by 1? 5 by 1 is?
5.
So what do you think x squared by 1 will be?
Well, x squared.
Correct?
No, I'm talking about you add the x squared plus x squared.
Oh yeah, that will be 2 x squareds.
Right.
So I'll take my time. So that'll be x squared, and we're gonna multiply 1 by x squared. Then we're gonna do 1 by 1. So 1 by x squared is x squared. 1 by 1 is 1. So what's this gonna simplify to?
4 x squared to the power of 4 plus 2x
Wait,
squared.
you said x squared to the power of 4? No. You said x squared to the power of 4. No, that'll be x to the power of 4.
Plus 2x squared plus 1.
Right? And we're gonna substitute that over here. So that's going to be, if I integrate that gap, what would I write?
So no wait, 4 x to the power of 4.
Now, when you integrate, you add 1 to the power and you divide by the new power.
So is x to the power of 5 over 5?
Yep.
Plus 2x to the power, well, 2x cubed over 3
Right.
plus 1. But will we keep the 1 since we integrated?
When you integrate it and you have a constant, just slap on the variable to it. So like, we say
Okay, so
1x.
it's x.
1x, which is just x.
Okay, nice.
And
And
you
then
put
you
2
put
on
the
top,
2, 0 outside. Okay, nice.
right? And that's gonna be pi. That's gonna be 2 to the power of 5 all over 5 plus 2 by 2 to the power 3 all over 3 plus 2 minus the same thing. You can plug in the same thing, but we know, Gabriel, if I plug in 0 everywhere here, that would just make everything here 1.
Equals to 0. That whole
So
thing would be
just it's minus 0. So the only part I really need to work out is this part over here.
right.
So plug and take calculator and let me know what you get. You have a sharp or a Casio?
No, I have a Casio.
Okay, good. Plug in from a fast and let me know what you get.
We plug in the minus 0 also.
You have to plug in the minus 0.
Okay. We're supposed to get decimal.
I would prefer if you write your answer as a fraction.
Okay. Then I give him a fraction.
You have to press S to D.
Yeah, no, but then I give him a percent and then I give
They just given like the mixed number times pi. They're not giving you like a full fraction.
That's okay, I'll show you what to do.
I got a full fraction.
So 2 to the power 5 over 5 plus 2 by 2 to the power 3 over 3 plus 2. Again, 206 over 15. What you might have to do is you might have to
Yeah,
press.
and then you had to put multiply by pi and also.
Yeah, but you don't have to. Okay, in AdMaths we write our answers in exact form, so you just have to work out the fraction part, and it's just for multiply by pi. Yeah. It's not like you're calculating the answer, no? It's not like you're calculating the actual result. You're just writing the answer as a product of pi, a multiple of pi. So you work out the inside and you get. So if you are getting 13 and 11 over 15, and you want to get the improper fraction, you're going to press Shift S to D, and you should get 206 over 15. And so your final answer is just going to be 206 over 15 pi.
So I still not getting that.
Now the units cube. You're forgetting exactly like me.
Yeah,
What are you getting now?
I getting this. Just I could put on my camera and show you.
Sure.
I getting this. Wait, let me see. I don't know if it like
No, I
enough
can't see it.
focus, and I'm gonna unblow my background and see.
So let me see where you plug into your calculator.
Wait, let me lower my brightness and see.
Gabriel, I didn't know it was you, no. I thought it was somebody else. Yeah, but I thought it was somebody else the whole time,
I
boy.
had to bring back my purple sheet just. Wait, oh my days, it empty. It like how I think it empty back out. Let me see if I could redo it and I'll show you after.
Plug in the exact same thing I plug in, exact same thing I plug in. Yeah.
2, 5.
So are the rest of you guys all get through?
Yes,
Yes,
sir.
sir.
So,
But so we're gonna take our segue, come back, gonna finish kinematics. Tomorrow we're gonna grind trigonometry. Do a bunch of trigonometry questions. And maybe like at 10 hours tomorrow.
For
I want to
sure.
do I want to do trigonometry and what else? Because I'll finish trigonometry. I'm speech
Well,
again.
I don't know nothing. I only do know one thing in kinematics because my teacher only did one session of kinematics and I don't understand it still.
Okay, well, we're gonna do that
one
just tomorrow.
question. One.
I want to, tomorrow we're gonna do trigonometry and what? What I want to do tomorrow.
So I wouldn't mind if we do sequences.
That's a short
Yeah,
topic. That's
sequence
not
and
Would
series.
you be able to explain the box on, I can't remember the name of it, but the box on,
Box and whisker.
Box and whiskers.
yeah,
Yeah, that's not a
just
problem.
quick thing because I don't understand that.
That I feel like that one's one of the simpler ones. So like
The, the box just represent like Q1 to Q3?
Yeah, and this is the lowest observation. And is the highest observation. That's all. And like, question, guys, is this looking positively skewed or negatively skewed? What do you think?
Positive.
Yeah, it looking positively skewed because like it looks as though most of the data is where
On the highest side, which is positive.
positively skewed. So
Oh wait, it depends on the line.
yeah.
Okay.
Okay. So 206 over 15. Make sure you're getting that. But that is essentially for calculus. Are you have any questions? Are you want me to clarify with respect to calculus?
So I know this is usually a topic everybody good in, but you could go through probability.
Probability. So the plan for today is really kinematics. So that one had
Well,
to be
so not
something before
today, but
it.
like in the later sessions or whatever.
That's a problem. That's not a problem. I really wanted to do the whole syllabus, but it would be good if you all could like come up with a list of the challenging topics so I could put full emphasis on those. Or the night before, just practice. So I hear people saying
Because
series and
my
people saying
whole
series and
problem,
sequences.
so my whole problem is that
Yeah,
I'm
for
really
sure.
good in everything except statistics and probability.
You learn everything other than that?
Yes, sir, I'm good in every single thing except that.
Okay, no problem.
The sum and product rule, sir, with the alpha plus
Alpha.
beta.
No
Oh wait,
problem.
I as our boss at Alpha Beta. So you're not going through logs, right? Or you are?
I want to go through logs because a lot of you guys having trouble with logs.
Yeah,
Yeah.
please go through logs. I need a refresher now.
Yeah.
So let me make like a tier list, right? Because real people who I help with series, my pencil just died. So when you
What
make a tier list,
exactly is that series thing you're talking about?
so I hear people saying series and sequences. I hear people saying logs. I hear people saying probability and statistics.
So for me, it's all because my teacher never teach for the whole of Form 5 and Form 4.
Hey boy.
Yeah, so my teacher was non-existent. You cannot say
So
this.
I basically teach myself the whole of hard maths.
Hey boy. Well,
The fraction thingy was the functions, my bad, functions.
functions they don't really test that much anymore in almost.
Okay.
So how about APs and GPs?
I series and sequences, no problem.
Oh, okay.
So I never do that.
You never do that thing before.
Okay.
Well, which
I
school
wouldn't
is
mind
this?
touching on vectors.
High school?
Which school? Yeah.
Old Tech.
Well, tech. Okay. I'm on my old tech actually. Yeah.
Yes, sir. You want to put up a whole table in the chat about all the topics that we could possibly do in AdMaths?
Do that from hey, vectors and odd maths is the easiest
Alright.
maths now. Vectors and odd maths is the easiest of the easiest maths.
One question.
Yeah, I just need a
I
refresher that as well.
Excuse
No
sir,
problem.
where to put the chat? The thing in the CSEC AdMaths chat or the Behave Children's chat?
Wait, it's in the CSEC odd maths chat.
Alright.
I noticed that the people that are doing odd maths are really causing any ruckus. Everybody here kind of serious.
I mean, so is hard math.
Oh my days. The bruh guy.
You no
Nah,
longer
I ain't feel to go come here for hard maths. I ain't feel to go come
Bad.
here for hard maths.
So
I feel like
bad.
Jabari, ole. That's Jabari, you know, that's Jabari. That's Jabari. No, that's Jabari.
That was so funny, but like out of time and at the same time. When he came in clutch for like when we had asked, that was the only time when he was funny.
Yeah. Low-key funny. I need to get like a trusted person with a soundboard to like play sound effects.
So you could get one.
I could.
Yeah, but he wouldn't have like time to actually play it because he don't even check the chats.
You gotta get a Steam Deck though.
Yeah. So when you like posted on your status about your laptop tweaking out on the so much group chats. I won't lie, my WhatsApp was not loading at all.
No, but like
Mad.
my laptop. No, but I can imagine like my laptop is extremely powerful. Like I could play like games while having multiple streams doing yada 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 whatever, and it wouldn't budge. But like okay, I'll check activity monitor and like it had like 80% of my CPU still free. I don't know why WhatsApp was bugging. I think it's just our WhatsApp problem. I think it's just our WhatsApp problem.
Nah, it's just
Honestly.
WhatsApp.
Yeah. So here what? We're gonna take a little break, come back in 30 minutes.
Boom.
We will start back 30 minutes. So we'll reconvene at 9:30. Call at 9:30.
So before we go, I can ask a question.
Sure.
So you see how the last ADMATS exam came really weird? Like it came how the really older papers used to come. Do you think that like this year paper would be normal, or you think it would be similar to the one that came last year?
I'll tell you the safest response. I really don't know. I really don't know what coming, you know. All I could say is learn your work, so whatever come, you're good. You're prepared.
Well,
But
I feel
Okay,
they can
so
bring some shittiness.
but like I can give all some we could probably do some old time questions if all you want to prepare yourself. Yeah. It had this real old it had this question from the 90s I did see. It looked real nice. Let me send it forward.
After that maths CSEC exam, I believe anything possible to come in the maths exam.
Well, actually, the unit one, unit two pure math students find the exam was real easy. It's actually real easy exams to be honest. Yeah. So if pure math was easy, I have a feeling hard math's gonna be chill. Yeah, if all I want to do maths during all their break, or they could tackle this question. Yeah, they could tackle this question in the meantime. Cool. Yeah, go and get some food and thing, guys, when we come back here at 9:30. Yeah. You guys, are we back?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
I feel a little more tired than usual. Cause like I don't find all I give my energy. Hey boy. I need to like my vampire and I need people energy. For me to be energized, I need people energy. So they gotta give me some energy, you know what I mean? Yeah boy. Like all the tired too.
No,
Yes,
sir.
sir. We had POB today, the exam.
And I had to leak the paper too. That's why I here.
The
Yes, sir. They
easiest
might
paper they
correct
go
using
leak,
the
sir.
paper one alone.
Out of all things, POB boy, they can leak the math paper. Boy.
Sir, disclaimer, you do not condone leaking of any papers.
Yeah, should I say that? But I just say now, if they were to if something did have to be leaked, why POB? Out of all things, why POB? That's what I say.
By the way, sir, you're gonna go through the question you post in the group chat.
Yeah, all the want me to do that? That question really easy, you know. That question is so easy. So
Sir,
easy.
I did like the first part, but like I don't have a graph book on now right now, so I didn't do the rest.
Okay. I'm gonna get my I'll look up on the camera and think, you know, give me some energy. Late night, going into the late night sessions, you know what I mean? Oh, I need to like get inside. Ugh. Well, they want to just dive straight into kinematics or do that question, Hassan?
I say
You
go
could do the
kinematics
question,
one
sir.
time, you know.
Do the question first, sir.
I really want to see how that working. No problem. Once I the live again. TikTok keep on number live boy. One mom TikTok. TikTok playing
Nah,
up boy.
I don't think they like it, sir. I don't think they like it.
I think they're trying to hold him on. Like trying to prevent my growth, stunt my growth. They can't keep me down though. Can't keep me down. Can't keep me down. My vibe to the world. Right. Everyone that question there. Light work question. Like I will tell you guys, I will promise I will tell you guys when we see a hard question. But so far, most of the questions we've been looking at are easy. Yeah. All right. My bad, wrong chat. So I want to collide send boy. Somebody said 1997.
So somehow here wasn't even a thought yet, sir.
I wasn't even born yet, why saying? Boy, I wasn't even born yet, so you know what I mean? It's crazy. Let me tackle this question. People on the TikTok, how are you all? Are you all good? I sat back the lively. Right now we jamming art maths. Right down till we lie down. You know what I mean? That's what we doing. Ooh. You go till a little 12 o'clock now. Tomorrow we go and grind it out, grind real work as well.
Yes, sir.
Because you all have to destroy that art maths paper. All right? Everybody here, I got how to get that one in art maths.
So when you eat it, it's get like real extra energy.
Yeah, when I eat, you know, I get some energy here and there. Yeah. Energy for me does work different from energy from the average person. I feel like as soon as I eat, the energy just goes to my brain one time. It don't stick, it don't stick. Like here, say, as soon as I mention the word art maths, the numbers on TikTok they just go pew plummeting look. Yeah, boy. Nobody does do art maths, boy. Like nobody does do art maths. Nobody does do art maths. That's tough. That's
Everybody
tough.
running from advance.
Yeah. Me know what maths do all, yeah. Art maths was my night in China, mama. You know how much depression AdMats really saved me, boy. AdMats was like my coping mechanism, boy. Gabriel looking at me like, what?
So you
Coping?
do add maths to get out of depression.
Yeah, boy. I used to grind AdMats. I was AdMats boss, you know. Well, still is AdMats boss, but right.
So add maths
So,
get me into depression.
That's
so you
crazy.
prefer art,
For
maths, or
real.
physics?
AdMats. I prefer maths. Maths is the best. Maths is the best.
But we
Maths
could all agree art maths is better than physics.
I love physics though, but maths is the best. So we have a function here defined on a set of real numbers by f of x is equal to sine x plus cosine x. Is my son here, Nikolai? Son. Hey, well, let me send this link to my monitor and get them. Tell them give me some energy. Right, boom, boom. Hey, Bali, good night, good night. Add maths straight down. So we lie down. So we have a function here given by sine x plus cosine x. And they're giving us a table here. Cool. Okay. Bali, we should do a live at time where you teach me POB or POA or something. And I should do a live teaching you maths. That will be vibes. That will be real vibes. What you say? Yeah. So x, f of x. All I wanna see man try to do POB or POA.
That'd be interesting.
Yeah.
So
That
that
would
would be
be
like
fun.
a walk for you though.
Keep in mind, I never touch that in my life. I never do anything with that in my life. Never.
That would be genuinely entertaining.
Well, I
Think
will
you'll do
organize
good
it
in POA.
badly. Nicholas, I say Nicholas. Nikolai, you there? My son there, boy? My son leave my boy.
So the man probably coming up here and thing.
Hey, you don't know yet. Hey, no, that's so true. I remember how Nikolai just take people, yo. Yeah, boy. Nikolai always ready, you know. Hey, cool. Right, this question is high key easy. So, they want you to complete the following table for f of x to two decimal places, right, chat? That's what they want you to do. So, for a function, if you want to get the f of x or the y value, what you have to do? Somebody tell me.
So you have to substitute the x value into the function.
And I gain all that. I need the energy. If I don't get any energy, that's why I just end this. No, I need the energy. I'll give me the energy now. Give me the motivation to keep pumping. Right? So if it's a function, all you had to do is take the x value, put it into the function, and you'll get the y value. That's all. So how am I going to get this?
What you say, sir?
So how am I going to get this value over here?
So you substitute negative pi over 6 into the function.
That's all. I see that's how I get in if we round that off to two decimal places, what do you get?
0.37.
Right? So I'm plugging 2 pi on 6 now. What again there?
1.37.
1.36.
So that'll be 1.37. And I'm gonna put 5 pi on 6 now into the calculator.
So it would be negative 0.37.
Verify that. Yep.
Yes.
Before I do anything, let me just plug this into the calculator to see what we're dealing with. See what let's graph the function. So we have y is equal to sine x plus cosine x. Can't find my x, like Nikolai take. Nikolai, boy, you finish school me here?
That one too, boy, sir, boy.
Nikolai.
Yes, sir. Yes, sir. Sir, I had to look sharp for the camera, you know.
Oh, Nikolai just cracked me up earlier. I don't know how Nikolai just cracked me up. Nikolai's moving around nonchalant. Let me just check something. 2 pi over. Okay. Yeah. Let me verify something. No, my calculator. Where's the calculator at? Alright, cool. Let me just verify something. So, sine. Right. Right. Cool. Yeah, well, this looking fine. Yeah, this looking fine. So, using a scale of 2 centimeters to represent pi on 6 radians on the x-axis and 5 centimeters to represent 1 unit on the y-axis, draw the graph of f of x for minus 2 pi on 6. Okay, so essentially the way to draw the graph for the values we just calculated. You see this notation over here? It just means that the values for x are going to exist within the range minus 2 pi on 6 and 5 pi on 6. So let me just get a graph paper real quick. So I have a graph paper somewhere. Copy. Yeah, who want to do this question, man? Any volunteers?
I don't mind. What is this, by the way?
They wanted to do the question from the 90s. So
Ah, okay.
I obliged. Copy. Paste. Yeah, so Nikolai, what scale do you want me to use?
A scale of 2 centimeters represents pi over 6.
Right. Okay. I'll just go and guesstimate. Give me a second. So like 2 centimeters to represent pi on 6. Pi on 6. 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6. Okay, that shouldn't be a problem. Cool. And then
Yeah, I must say
5
it's the negative
centimeters.
side, eh? So yeah, we consider that as well because we have negative 2 pi 6.
Don't worry, don't worry, don't worry. It's fine. What's Nikolai, what does do, right? I would say like 5 pi over 6 minus 2 pi on 6. and that would produce 7 pi on 6. So I need to have a minimum, cover a minimum of 7 pi on 6. So that's why I'm counting. So like,
Oh, okay.
like it's gonna be pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, 5 pi on 6, 7 pi on 6. We have enough space. We don't really have to worry about space.
Calculate that.
Okay, so I could probably put this over here. Struggling to see that, but it's probably make it thicker.
Yeah.
Right? And most of my values are positive. So 1, 2, like so. If there's one thing I don't like the grafting, it just takes so long. This would be a y-axis, and this would be an x-axis. Cool. Our first, well, let me just do this quickly, right? So Nikolai, on the x-axis, every 2 centimeters is going to represent pi on 6. So well, this is going to be pi on 6. What is going to be?
2 pi on 6.
It's going to be
3 pi on 6. 4 pi on 6. And then 5 pi on 6.
then we have minus pi on 6 minus 2 pi on 6. Hi Lily, are you okay? Right? So
Pi
cool.
what?
No, I see people on TikTok now. I talk to people on TikTok.
No, I hear like somebody named Pi what?
No, hi Lily. Yeah, somebody on the TikTok. Yeah. Nikolai, what the blanket, boy? Pull out the blanket, pull out the blanket.
Oh, yeah, we're going to get our record.
Yes, sir, yeah, your partner Romano now here, boy. Yeah, boy.
Right, so
And we want you to use 5 centimeters to represent 1 unit on your y-axis. So okay. And 1, 2, 3, 4, 5. So this would be 1. This would be 2. Cool. 1, 2, 3, 4, 5. So be negative 1. Is anybody confused as to how I figure out the scale there? Have anybody confused by that?
Nah, sir.
Nah. Okay. So here what we should probably do, right? Plotting everything on the x-axis is gonna be easy. On the y-axis it's gonna be a bit more of a problem. So here what I'm saying, right? How much? Okay, we have 5 big blocks, right? We have 5 big blocks, and that's equal to 1. So that means every 1 big block would be what?
0.2.
Yeah, because 1 over 5 is 0.2. So 0.2. Okay. And if we have 5 small blocks equal 0.2, then what would 1 small block be?
1/10.
Well, 0.2 over 5. Yeah, where's 0.2 over 5? That's 1/10. What's 0.2 over 5?
I don't.
I get
1 over 25.
Oh, but
0.04, sir.
It gets 0.04?
Yeah, 0.04.
0.04 or 1 or 25th.
0.04. And let me just verify that. I'll just be 1 over 25. Yeah, 0.04 is fine. So the first thing we're going to plot is minus 2 pi on 6 minus 0.37. Okay. So this would be minus 0.2. This would be minus 0.4. So minus 0.37. That would be somewhere around here, give or take. We know that every small one is 0.04. So 0.24, 0.28, 0.32, 0.36, and well, 4. So that'll be like somewhere right here. Are you understand that or not?
Yes, sir. In between.
Yeah, it'll be like somewhere over here. So my first point is going to be right here. I'm gonna run through that one more time, right? So guys, we know that one small block is wagging. What is one small block?
0.04.
0.04.
Until you understand that or not, every small block is 0.04.
Yes,
So if that's
sir.
the case, watch 0.24, 0.28, 0.32, 0.36. So 0.37 gotta be here, somewhere here. Next one, we have minus pi on 6, 0.37. So 0.37, well, this will be 0.4. So 0.37 will be somewhere over here, right?
Yeah. Yeah.
Yeah, because Nikolai, 0.24, 0.28, 0.32, 0.36 had to be somewhere over here.
Yes, sir.
A little bit more now. I tell all you, I need the energy, you know. I tell all you as a vampire, I'm taking all the energy. And so I need she look like she gonna I see Gabrielle like she gonna laugh today. Ole, try to make Gabrielle laugh, try to make she laugh. Oh.
And then she could tell me I had to buy back she laptop or she device. No.
All right, then we have 0.1. Oh, this is a tough one. This is a real tough one, boy. Yikes! How you doing that? Okay, a no game thing right here. Right? Are you okay with this?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Then we have pi over 6, 1.37. So this is 1 over here. This over here is 1. This will be 1 point, well, this will be 0.2. This will be 0.4. So the 0.37 will be over here. Are you agree or not?
Yeah. Wait, what?
Yeah, because Nikolai, watch, remember, one big block was 0.2 to begin with, right? Nikolai, one big block was 0.2. So this would be 0.2 here, and this would be 0.4. So like this is really 1.2 and this is really 1.4. You understand?
Wait, we just went past the 1.37.
It will be over here.
Oh, we on the pi on 6. Are we?
Yeah, right now we on pi on 6 here. So what was it, Nikolai? This is 1. This
Right,
will be
right.
1.2, 1.24, 1.28, 1.32, 1.36, right here.
Yes, sir. I see it there now. I was following from the table that you sent us in the chat now.
Oh. So that's pi over 6. Okay. So that'll be right here. Okay. Then 2 pi over 6 is 1.37 as well. So that's gonna be the same thing. So you should start to make the realization of this. There's this low-key looking like a what? Low-key looking like a what?
A curve, like a
Yeah,
quadratic.
cool.
Like a quadratic, yeah. And then we have 4 pi over 6 is 0.37, which is right here. And then we have 5 pi over 6, which is what? Again, minus 0.37. Right, so I just plot all the points. Are you seeing it or not?
Yes, sir.
So
Yes, sir.
What are looking like, Ali? What are looking like?
Quadratic. And
And that-
A maximum.
yeah.
Yeah, maximum.
I feel like Ali, could I get these marks or not?
yes, sir.
Yes, sir.
Easy maths.
Eventually, sir.
Eventually. That's so real. That's so real. With the amount of drawing you had to draw. Oh god. One second. This is hard maths, by the way. I
So
want to try
just
to
try
take
to
it
rage bait, yeah? Because the amount of times they say is that much already.
for real, eh? Like some people don't even know hard maths exists, eh? Not gonna lie.
So I feel like people join in without reading the title of the lives.
Just imagine how much times people just do CSEC maths and just like do the question without reading anything. That's scary. Think about that for a moment.
It is. That kind of like song I like me before.
Yeah, Lucas, this is social studies. That's a very keen observation.
We're gonna learn slavery.
Area. Good night, good night. Okay. Actually, guys, I think this is English. I think this is English B, you know. Low key, I think it might be English B.
But
What is
sir,
it?
I thought we now find the chat for slavery day. And we know the rate and when it spike up and when it went back down and things.
Alright, are you okay with that graph there?
Yes, sir.
Yeah, I think I'll let you get our 6 marks, guys. Come on. I'll let you get our 6 marks.
Did I like free max going there?
Yeah. I don't think that's hard. I think I'll let you get our 6 marks.
Yes, sir.
I try my best to draw that. I really try my best to draw that. Yeah, you can join the Zoom. Just send my message via my number. Yeah, well, it had 24 people in the class. Not as much people as I'd hoped for. But we talking it out. Alright, cool. So we get with 6 marks. Well, so far, how much marks you have in the bag, guys?
9.
You have 9 marks in the bag. Wow. Then they're saying draw on your graph the axis of symmetry of the curve. That hard to do or no?
No.
No.
Yeah. I was going to find the midpoint and tell you one time, but then we could have just see it and draw it one time.
That's it right there. Are you seeing that or no?
Yes, sir.
Yes, sir.
And what would the equation for that be? That look like it's in the middle or what?
Pi over 6 and 2 pi over 6.
So that will be what the middle of that will be. So to do that, you're just gonna say pi over 6 plus 2 pi over 6. And you can divide that by 2. So altogether that will be 3 pi over 6, which is pi over which would be 3 pi over 6, which is pi over 2, so that'll be pi over 4. Let's make sure we get
Yeah,
pi over 4.
Also. Yeah.
I'll look at pi over 4 now.
Yes, sir.
So the equation for this would be x is equal to
pi over 4.
I'll live with more now.
Yes, sir.
Yes, sir.
Okay. Right, so far we have 11 marks in the bag. 11 marks. 11. Right? 11. So we draw the axis of symmetry, check. We write the equation of the axis of symmetry was x is equal to pi on 4. Using the graph, estimate, hey, look Sean, big up yourself, Sean. Sean, I carrying them back all the way to January 1997, boy. Yeah, boy. Use the graph, estimate the values of x in radians for which sine x plus cosine x is equal to 0. So guys, this is a real similar question to what come in maths. And y was equal to 3. So here we're saying, right, Nikolai? If you recall, sine x plus cosine x wasn't that the original function?
Yes, sir.
And we are trying to figure out where it is equal to what?
Is that 1 or is that 11? Oh, 0.
That's 0.
We're looking like 2, like 11 then.
Now I'll looking like 0. So here what happened, right, Nikolai? In other words, we are trying to figure out where y is equal to 0. How much of you guys knew that? If you have sine x plus cosine x is 0, you have to recall that sine x plus cosine x is the function, and that would be y. So we're trying to figure out where y is equal to 0. So to answer this question, what could I do on my graph?
Find y is equal to 0 and divide it up and find x.
That's all. So you're gonna draw a vertical or horizontal line.
Vertical. Because
Yeah, vertical.
Vertical, let's show.
Horizontal.
Yeah, not
Vertical.
vertical.
No?
No, horizontal, yeah.
Horizontal, because it's on the y-axis.
Let me explain something, guys. I'm going to draw a line here. This line is passing through what on the y-axis?
2.
2.
2. So in other words, that would be y is equal to
2.
2.
Right? This would be y is equal to
1.4.
1.4. So what do you suppose this is?
Y is equal to 0.
0.
Y is equal to 0. So in other words, we are trying to figure out where our graph cuts the y-axis at. I'm not saying why, sorry. Where the graph cuts the x-axis at. That's all we're trying to figure out where the graph cuts the x-axis, because again, guys, another way of saying y is equal to 0 is the x-axis. So you see this over here? This was another way I could say the x-axis. Okay, if you're confused, remind me, what will be the equation of this?
Y is equal to 2.
So y is equal to x.
Now y is equal to x will be a diagonal line. This over here, can't everybody see? We have a horizontal line passing through 2 on the y-axis.
Yes, sir.
Yes, sir.
So what would the equation for this be?
Y is equal to 2.
2.
So if you could figure that out, I know for a fact all you can figure this out. This is just y is equal to what?
0.
Right. Because what? If this is y is equal to 2, right? And it keep going down, it decreasing until it passes through 0. So the x-axis is just y is equal to what?
0.
Yes. All you understand that or no? Talk to me.
So it's basically just like I have a point on the x-axis and the y would always be 0.
Yeah. So in other words, they just want you to find the x-intercepts. Can you guys see what I'm talking about? Like this line over here, it passing through what on the y-axis? I don't think I'll see it,
So we ask us the two x values.
Wait, I'm trying to make sure that everybody understands that this is y is equal to 0.
Yes, sir.
Because it passing the y-axis at 0.
Exactly. Watch. This is 0 over here, right? This is 0 over here. So that is a horizontal line passing through what on the y-axis?
0.
Yeah.
So this represents y is equal to 0. Cool. And we are looking to see where our function cuts that. So I'm seeing it cuts it over here. And it cuts it over here. So what are my answers?
The midpoint between -2 pi over 6 and pi over 6.
I looking like minus pi over 4.
I can check it,
Wait, that'll be minus 3 pi over 6, which is minus half over pi. Yeah, like minus pi over 4. I will confirm that though.
Will you say your answer was?
Yeah, pi negative pi over 4.
Right,
Yes.
negative pi on 4. Right, negative. So that's one of my solutions. And this other solution, that looking like that'll be 9 pi over 6. So that'll be 9 over 12 pi. 9 pi on 12. That'll be 9 pi on 12.
So I guess in 3/4 pi.
Right,
Same.
because if you simplify 9 over 12, you'll get
3/4.
3/4.
yeah. Because 3 could go into 9 3 times and 3 could go into 12 4 times. Yeah, so that'll be 3 over 4 pi. Right, so 3/4 pi. And those are your answers? Yeah.
Yes, sir.
What do you think?
So I'll explain back the question again. I'll explain the question back again. So they want us to figure out where sine x plus cosine x is equal to 0. So I want you guys to recall that sine x plus cosine x was a function. So in other words, we are trying to figure out where the function is giving us what? Where the function is giving us what?
0.
Right. So what we could do is we could go on the graph and we could draw a horizontal line at y is equal to 0, which is really just the what? Which axis? Which axis is y is equal to 0?
The
X.
Yeah, I just see x-axis. So in other words, we literally just trying to find the what intercept.
The x-intercepts.
That's all. That is all. So the answer for part 1, it would be x is equal to minus pi on 4 and 3 pi on 4, if I remember correctly. Minus pi on 4 and 3 pi on 4. And if you don't believe me, watch it. I know they don't believe me. No, some of them don't believe me. Like, what? This man's tweaking. So I have a question. If I plug minus pi on 4 into this, what am I supposed to get?
0.
I'm supposed to get 0. Let me see now. Full plus cosine minus pi over 4. So when I press equal, what I should get?
0.
Boom! Mathematical badness all here. And if I put 3, and if I put 3 here, okay.
So you're supposed to put that as a improper fraction, so
No, it's fine.
well then 0 then. Yeah.
Because Nikolai, the calculator interprets as 3 over 1 by pi over 4, which is 3 pi over 4.
Ah, okay.
Yeah. Yeah. So are you all okay with these answers? And can you see that they're giving us 0?
Yes, sir.
Yes, sir.
Good. Home for super mathematicians. Hey, you good? All right. So we're Gucci. Let's look at part 2 now. What part 2 saying?
The value of x for which sine x plus cos x has a maximum value.
Ah, we know how to handle that. When you see maximum value, you're thinking about y-axis or x-axis. You're thinking about x value or y value.
Why?
Thinking about y value. So, what is the highest value it goes up to?
1.4.1. Well, 1.41.
It kind of hard to say, you know. Kind of hard to
No.
say. They don't expect you to give an exact answer. Like Adri, boy, man, like Adri. Boy, Adri is plan, boy. Yeah. If you ask me, it kind of looking like 1.44. It looking like 1.44. Yeah. But you're not expecting a perfect answer because you know it's a sketch. Right? So are they okay with that?
Yes, sir.
Yes, sir.
Oh, but here what? You gotta be careful, eh? They didn't ask for the maximum value, no, they asked for the value of x, for which is a maximum value. So they're talking about the input for the function. What is the input for the function that would have given us that maximum value? You have to look over here. What is this, guys?
Pi over 4.
Yeah. And here what? If you actually want to figure out the exact answer, you could actually plug it in, you know. Are you understand what I say? No, no.
Yes, sir.
Yes, sir.
Well, let me see now. So let's plug that in into the function and see. Why? Wait, boy. The calculator had to do with that. Sine pi over 4 plus cosine pi over 4 1.41. So the actual answer would be like real close to over here. Like it literally is literally one. This is 1997.
Wait, sir, I just guessed that because I say 1.41.
That bad. But from the graph, you gotta say 1.4.
Ah, alright.
Yeah. Because I said using the graph estimate. But the answer for part 2, right? The value of x. So here's what they're asking us for the value of x. I'd have to plug in into the function to get the maximum value. Can you see that the maximum value occurs when x is pi on 4?
Yes, sir.
Good. And the maximum value from the graph is what?
1.4.
1.4. So the answer for the first part, I already said that. For the second part, the answer is just x is equal to pi on 4. And for the last part, what is the maximum value from the graph?
1.41.
And you will say that as the y value. Or you could say f of x. So you'd say f of x is equal to,
1.41.
well, they can't exactly read that out from the graph, so you could just say 1.4. And that is it. How much marks that was, boy? 9, 12, 16 marks.
So they should do that for
You ain't
2026.
getting that nowadays.
But that was really easy, right? It just look hard. People that wanted me to do the question, I realized how easy the question was.
Yes, sir.
Yeah. I just hear like one or two people, you know.
Yes, sir. Yes, sir.
Hey boy.
Yes, sir.
Nicola,
Yeah.
you had to make up energy for the rest of them.
Yes,
So
sir.
they sleeping.
Hey boy. Alright, let me tackle kinematics now, no?
Yes, sir.
So I'm gonna tackle the differentiation and integration aspect of kinematics first. I have a question. Only thing I can make, boy, is 10 to 15 and I don't hear nobody. I
Sir,
can
Yes, sir.
make
making it. I don't know about the
So we
rest of
can
them.
make, so we
Yes,
can
sir,
make,
I could make. I was waiting for
Make.
the start
I can make,
kinematics.
I can make, sir.
I mean, I feel kind of tired, but I can make.
okay.
Once you're willing, sir, I go in.
Yeah, I will in all the time, you know, but I don't want I just feed off people energy. If the energy dead, then I go be moving dead. You know what I mean?
So I got nonchalant fella now, so.
Hey. Chalant is the way though. Chalant, gotta be chalant though. Chalant. The ladies like that.
Apparently the X's too, sir.
Hey. I would say Nicola is more of a nonchalant kind of guy.
Yeah, for sure.
Right. So when we're dealing with kinematics, you need to know that T represents what? What's T represent?
Time.
Time. What does S represent? Look, Romano, come on live now. Come on Zoom now.
Distance.
Nah. Displacement. S is displacement.
So I thought D was displacement.
No. You have it tie up. Yeah, have it tie up. S is displacement. Yeah. V. What does V represent?
Velocity.
Velocity.
What does E represent?
Acceleration.
Acceleration.
So here what, right? Velocity is just the change in displacement with respect to
Time.
Time.
So v is actually just ds over
dt.
yeah. And acceleration is just a change in what with respect to what?
Change in velocity
Change
with
the
respect to
velocity
time.
to time.
That's all. That's all, chat. That's it. I mean, like, this is really easy, I feel. So, some of you guys confused, probably saying, "Sir, displacement is usually distance in maths." Well, yeah, we're not doing maths. We don't have maths. Maths is a bit more accurate to like physics and stuff. So, you should know that displacement is a vector quantity for what?
For distance.
Exactly, and velocity is a vector quantity for
Speed.
and acceleration is just acceleration, right? You could have acceleration, or you could have positive acceleration, which is just acceleration, or you could have negative acceleration, which we call what? What do we call negative acceleration?
Deceleration.
Deceleration.
Right. So cool. So here what? If I had displacement and I wanted to get velocity, what would I have to do?
Differentiate.
You have to
Get
differentiate.
velocity.
I would have to differentiate. Cool. If I have velocity and I want to get acceleration, what would I do?
Differentiate velocity.
Right. Let me go in the other direction. If I had acceleration and I wanted to get velocity, what would I have to?
Integrate.
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 If I had velocity and I wanted to get displacement, what would I do?
Integrate.
Integrate. Integrate.
And you know why this is mind-boggling? Let me explain something on it. And for a velocity time graph, to find the distance traveled, what does typically do, boy?
Just find the area underneath the graph.
Okay, let me cook. And when you integrate between bounds, where does find?
Just find the area underneath the graph.
Ain't no way. Oh, maths is just that goated, boy. Maths just that goated. Maths is just that goated, right? Big up maths. W's in the chat for maths. Maths is amazing. Maths is amazing. Ollie, have I thought about that before?
No,
What was that?
sir.
Was that sir?
All right. Nikolai, let me cook, right? So, Nikolai, consider you have a velocity time graph, right?
Yes, sir.
If you wanted to find distance traveled for a velocity time graph, what would you do?
If you want to find distance for velocity time graph,
If I want to find distance traveled for a velocity time graph, what would I do?
distance over time.
Nah,
No, the area under the graph.
the area under the graph, but now I in big boy shoes. I should know that integration allows you to find for,
The reverse of differentiation.
but you're not wrong, but integration allows us to find area under a curve or area under a graph. So Nikolai,
Okay.
that is why I'm saying if you want to go from velocity to displacement or distance, you would have to integrate because integration allows us to find the area under the graph.
So we technically finding the area under the graph anytime we going backwards.
Yes, integration
Ah.
is essentially finding area. If you'll ever look at some videos on integration just involves you finding f of x and some small distance dx, multiplying that and summing that. You see the integration sign? It kind of looks like a what? What does it kind of look like? What What letter?
F.
S.
It kind of looks like a S. So what integration actually is, right? Let me show you. Like, consider you had this curve, right? What integration actually does. This is what integration actually does. So like, integration actually, watch. This approximation. And I could like divide my graph into like small sections.
Yes, sir.
And dx is some small change in like some small distance. And if I want to get the corresponding value here, I would have to take the x value and put it into the function. So this would be f of x. This would be f of x. This would be f of x. And so integration is just summing these small divisions an infinite amount of time. And that would approximate, that would give you the actual area under the curve. That's what integration is. So you see this s over here, it actually represents sum, because you are summing all like the small like approximations, the small blocks. That's what integration is do. Integration allows you to find the area on that graph. And if you didn't know, this over here actually just means sum. You're summing those like small areas. If you guys go and study maths at a higher level, you'll see maths is amazing. Maths is the best. So I'll understand this, right? So displacement to velocity differentiate. Velocity to acceleration differentiate. If I wanted to go in the other direction, integrate. Yeah?
Yes, sir.
Yes, sir.
Let me look at some keywords here. If I say, I don't know how I had the energy, boy, but maths is getting me excited. If I say start at rest, guys, again, start. Start implies that the time I start at what? Time at what?
Zero.
And rest implies that I start off with a velocity of what?
Zero.
Right. If I tell you, actually, we just see when we do the questions. Let me just do a bunch of questions. I'll understand the concept already. We could just spam some questions. I'll give my specific year. Give my year, guys. Give my year.
2020.
COVID time.
2020 didn't have a. I write in 2020. Didn't have a paper.
2021.
2019. 21.
Let me do 2021 first. That's crazy. When I hear I write the exam in 2020, how will this feel, boy? Like, all right, I just see that, you know. Yeah.
True. Yeah.
Sir, just the other sir.
Should I give?
I was 6 years ago, sir. That not yesterday, sir.
I don't understand what you're saying.
You see, that was 6 years ago, so that wasn't the other day.
And that Loki was here like 6 years. Not far away, boy. Imagine how they ask me what year I write CXC and I say 90s. That's crazy. That's crazy. That's what I call craziness. Yeah. Dinosaur boy. Alright, who wanna help me with this question?
Sir, I want to help.
Scarlett. You know, wait, before we start, you know about Scarlet Witch? And like Vision?
Yes, sir.
You watch WandaVision?
No, but I know about it.
Oh, okay. Yeah, get a question I read.
Okay, a particle starting from rest travels in a straight line with an acceleration a given by a is equal to t squared, where t is the time in seconds. Determine the velocity v of the particle in terms of time t.
Alright, let me run it now. So they're giving us acceleration in terms of time. Cool. So they're telling us that a is equal to t squared. And in the first part, they want us to determine the velocity of a particle in terms of time. Now, in the question, they said the particle started from what?
From rest.
If they're telling us that the particle started from rest, then that is that gives us an initial condition, which is important. So at rest, what do we know?
We know that the time and the velocity of the time and the initial velocity is both zero.
This is important, eh? Alright, so here what
when we after we integrate a to get velocity, we would have to substitute the value of t and v to find for c.
Yes! Big up yourself, Scarlett. Big up. Boop, boop. Don't know. Right? So that's why we're looking for initial condition. Right? Because again, we gotta integrate. Why? Shivan, what is A? Remember, what does A stand for again?
Sir, A is the acceleration.
A is acceleration, right? But it represents what? Like in differentiation. What does it represent?
The distance over the time.
No. Acceleration is a change in velocity with respect to time. So acceleration is the same thing as dv dt. Yeah. Shivan. Okay, Shivan, think about it like this, right? When you think
Sir,
of
meant that makes I write it down, right? But come now, sir. Distance. Come on. Yeah, you know what I mean, now, sir.
no. I gonna give you the W, right?
Yeah.
When we say accelerate, we're talking about the rate at which we change the speed.
Yeah.
That's what acceleration is. So change in velocity over change in time. So
Yeah.
as you said, Scarlett, what would I have to do with dv dt if I want to get v?
You would have to change the power to 3 and then divide that by 3. So it would be t cubed over 3.
So we have to integrate, right?
Yeah.
I mean, because you've seen it, right? Acceleration is dv dt. And if I integrate this with respect to time, I'd get v.
Sorry, so what you say?
If acceleration is dv dt, and if I integrate dv dt with respect to time, what would I get?
You would get v, velocity.
Yeah. You've seen it, right? You've seen it. I can't believe anyone else seen it. You've seen it. You've seen why I see it.
Yes, sir.
Good. And that'll be equal to the integral of t squared with respect to
dt.
time. When I say with respect to, that means d. So just say the
Right,
variable.
yeah. I didn't realize.
That's okay. Integral of dv dt that'll just be v, and so that'll be equal to t cube all over 3 plus what?
Plus c.
Cool. And so now we could plug in our initial conditions. What's our initial condition?
0. So c would be 0.
Yeah, c would be 0. Okay, so Vinny, let me try to explain this again, right? So acceleration is a change in velocity with respect to time. So change in velocity with respect to time. So that's dv dt. Now, if I have dv dt and I want to find velocity, I'd have to integrate this as it would undo the differentiation, and that would give me just v. So if I want to find velocity, I need to integrate dv dt, which is acceleration, and I will get the velocity. Okay. And if you integrate t squared, you're going to add 1 to the power and divide. So t cubed over 3. And our initial condition was 0, 0. So I'm going to put v as 0, and I'm going to say t is what?
0.
So c is just what? Like I said, c is just what?
0.
Right, so v is equal to?
T cube over 3.
That's it? No, and the way to think about it like that. Now, Vinny, the way to think about it like that. What we're doing is, so yeah, a way to understand acceleration is just dv dt. So if I integrate dv dt, dv dt implies that I had a function for v in terms of time and I differentiated it. So if I integrate it, I will undo the differentiation to get back v. So I'm gonna integrate dv dt and I'll get v. Yeah, Nikolai.
Yes, sir. Is it? Wait, and we on? Oh no, we still on part 1. Because I now got to say, but look, t is equal to 2 as well.
Nah, this is for interval.
Yeah, my bad.
All right, so let me tackle part 2, right? All right, so in part 2, we want to calculate what?
The displacement.
Right, we want to calculate the displacement. So here's what I'm telling you. We just found an equation for v, right? And we know for a fact that v is equal to t cubed all over
3.
No, we also know that v is the change in what over the change in what?
The change in displacement over the change in time.
Good. So if I wanted to find for s, what would I have to do?
You would have to integrate velocity.
Exactly, because you've seen it there for yourself, right?
Yes, sir.
I'll get back s if I integrate. So we'll have to integrate ds dt and to get the actual answer, I'm going to integrate with respect to what bounds? What will be my lower and upper bound?
0 and 2.
So my lower will be 0, my upper will be 2. On the left-hand side, I'll just turn to what?
Sorry, sir, what are you saying?
On the left-hand side, I'm just going to turn to what?
S?
Yeah, I'll just turn to S, right? Because if you integrate ds dt with respect to time, you're going to undo the differentiation, and that's just going to leave you with S. On this side, however, we'll have to integrate. So if I integrate, I'm going to add 1 to the power. So that's going to be t to what power?
4.
Yeah. So that'll be t to the power 4 all over 3. And here's a hack, right? You can think of it as 3 multiplied by 4, 110. Why am I saying that?
So t over 12.
Or why am I saying that? Well, consider you have t to the power 4 over 3, right? Then you would multiply by 1 over 4. Because we know that dividing by 4 is the same thing as what?
As multiplying by the reciprocal.
Good. So we could just say 3 over 4 and done. My upper bound will be what?
2.
My lower bound will be 0. If you want, yeah, this is physics. This is physics. And so that would be t to the 2 to the power 4 all over
12.
minus
0.
and so 2 to the power 4 is 16. And 16 over 12 is
4 over 3.
this is art maths. But it is genuinely physics as well. Yeah. And what would the units for this be?
Meters. Well, wait, let me see. What was the units they had before?
They never specify the units.
Usually when it's a particle, it just be like centimeters, right, sir? Or something.
I wouldn't assume. So I'll just say
So just
4 over
put
3
units.
Yeah. So in the question, they wanted us to calculate the displacement of the particle in the interval of time t is equal to 0 and t is equal to 2. So therefore, this is an indefinite integral or a definite integral? Somebody tell me.
Definite.
Definite, sir.
Right. So if you need, this would be a definite integral. So here what? In the last question, we actually found for v. We found for v. Now I want you to realize that v is just ds dt. That's what v is. V is just ds dt. And so for us to find for s, I'll have to integrate this. But I'll have to integrate it with respect to the interval. So like, it'll be from t is equal to 0 to t is equal to 2. Why is this showing here? Good notes, behave yourself. What? I don't even know what that was for. But yeah, Vinny, so I hope you understand that to calculate the displacement, we have to integrate velocity. Why? Because velocity is ds dt, and that would give us s. And on the other side, you'd have to integrate what v actually is. So v is what is actually v? V is actually t cubed over 3, right? That's what v is. V is actually t cubed over 3. And they want us to figure out the displacement from this interval. So you have to find from 0 to 2. So you're going to integrate like normally. Then you're going to plug in 2. Then you're going to plug in 0. And you get your answer. Why do we need the intervals? We need the intervals so we could find the displacement at t is equal to 0. And to find the displacement at t is equal to 2, then subtract them. So this over here will be the displacement at t is equal to 2. And this will be the displacement at t is equal to 0. When I minus them, I'll get the displacement. Let me know if you guys okay with this.
Yes, sir.
Yes, sir, but I
Yes,
have a
sir.
question.
Yes, sir.
So sir, let's say they want us, or like they ask to find the distance and they didn't say displacement, right?
Same thing. Same thing.
Right. So, but let's say you get a negative value, right? Would you just like change your answer to positive, because if you have the negative, it kind of specifying the direction, which would make it displacement.
Um, so you could have displacement, right? So let me just say something. Let me just say, I had this box over here, and I displaced it 5 meters. That's distance. And then I displaced it over here. That'll be minus 5 meters. But the actual distance is just what's the actual distance in both cases? The actual distance is just what?
5 meters.
So you just say the positive. Because the distance just cares about the magnitude. Like you said, it does not care about the direction. So you'll just say distance. Right?
Yes, sir.
Or you have any here's something, it's 2019. Who wants to do the 2019 question with me?
I don't mind.
Sir, I could do it.
Alright, so right now I'm mainly focusing on the different derivative parts, right? The derivative and the integral parts. So who wants to do it, man? Scarlett just did
Sir,
that
I want to
question.
do it.
Scarlett wants to do this question, bad boy. Hey. Well, you just do one with me, so I'll give somebody else a chance. Who else want to do it, man?
I can do it.
Shivan?
Yeah.
Shivan, before we start, right? Remind me. Acceleration is a change in what over change in what?
Uh,
No, don't look in the book. Try to think about it logically. Acceleration is a change in what?
velocity over time.
Right, because when you accelerate, where you changing?
The distance. Oh.
Nah. Okay. If you're in a car, right? If you're in a car and your father press the gas.
How fast you going? How fast you going?
Exactly. So you're gonna change how fast you're going. So you're increasing your velocity. So A is really changing velocity over changing
Time.
And if I wanted to find the velocity, what would I have to do with dVdt?
You would have to integrate.
Integrated, because I would want to just get for V.
Mm-hmm.
If I have velocity, remember velocity is changing what over changing what?
This velocity is
Okay, if I ask you what speed
Sean,
is, where's speed? Where's speed?
speed is distance over time.
Right. So what is the vector counterpart for distance?
Say that again?
What is the vector counterpart for distance?
Meters?
Nah, insert you do physics?
Yeah.
Okay. In physics, what distance is a scalar. What is the equivalent vector quantity for that?
Oh, velocity.
Nah, displacement.
Oh, yeah.
Displacement is like the upgraded distance.
Yeah.
So you say ds over
DT.
right. Cool. And if I integrated this, what would I find for?
The displacement.
Good, the displacement. Cool, let me tackle the question now. So give it a read from her.
A particle moves in a straight line such that t seconds after passing a fixed point zero, its acceleration a is ms meters per second -2 question mark is
Wait,
given by
wait, 1 second. No, we just ignore the question now.
yeah is given by a is equal to 12t minus 17, given that its speed at o is 10 meters per second -1. Determine part 1 the value of t for which the particle is stationary.
You pick a nice question to do, boy. You pick a nice question to do indeed. So they're telling us the particle moves in a straight line such that t seconds after passing a fixed point. Okay, anytime you see fixed point, Shivan, okay, if it's a fixed point, then I'll start the timer at the fixed point. So
Mm-hmm.
at the fixed point, the time is what?
It will be 0 at the
Right.
fixed.
At the fixed point.
Yeah.
And they're saying its acceleration is given by E is equal to 12t minus 17. And its speed at O is 10 meters per second. So here what happening, right, Shivan? You would have had to so you have a particle and it's moving already, it's already in motion. So it's already in motion, right? It already has a speed. But only after passing the fixed point do you actually start the timer. So do you understand at the fixed point it already has a speed?
Yeah, which would be 10 meters per second.
Right. So I'm gonna call that V. V is equal to 10 meters per second. So at the fixed point, time is 0, but the velocity is what?
10.
Good, cool. Now they want us to find the values of t for which the particle is stationary. Now if it is stationary, what do we know?
That it did not move. Like 0, 0, 0. The distance equal to 0.
That's not true. I could have moved. So like here what I'm saying, right? Shivan, I could get up now, and I could move from my original position, and then stop at some random point. My distance would not be 0. My distance would have been up until that point where I stopped. So if I'm stationary, am I moving is the question. Am I moving is the question.
What if it's stationary? You wouldn't be moving?
I wouldn't be moving, so would I have a velocity?
No.
Think about it logically. You wouldn't have a velocity, right?
Yeah.
So Shivan, if you're driving, right? You drive or not? Not yet.
So, Nikolai older than that, I will have to say.
Nikolai older than you. Nikolai is your partner.
Yes.
Oh, yeah, some good company then. Nikolai is a good fella. Right? But Shivan, when your parents about to slow down, right? And you just press the gas, and what you notice happening to the speed?
Oh, it would be dealing with displacement because it could either slow down.
Well, not necessarily displacement, but think about it, right? Imagine you're in a car, and I start to press the brakes. If you observe the speed gauge, the speedometer,
Acceleration, you would accelerate in the opposite, so you'll slow down.
right? And you notice that the speedometer does go closer and closer and closer and closer to what?
0.
0. So when you're stationary, what's your speed?
0.
Good. That's it. No, but think about it again. Imagine you're in a car and your parents are driving. When you press the brakes, you start to decelerate.
Yeah.
And you notice that the speedometer, the speedometer, imagine this is 100% and this is 0. The speedometer what would happen to it?
It would decrease and go anti-clockwise, yeah.
To 0, right? To 0. So when you're stationary, what is your velocity?
0.
0. Good. So guys, anytime they mention the word stationary, that means that your velocity is what?
0.
Guys, all you understand now. When I say stationary, I mean that the velocity is
0.
that does not mean the displacement is 0, eh? Enter can I move and then stop somewhere?
Yeah.
So if that is the case, then my displacement wouldn't be 0. So clearly we're not talking about the displacement, but the velocity though. Remember, velocity means a change in displacement with respect to time. So if I don't have a velocity, then I'm not changing. I'm not moving. I'm staying stationary. The change in displacement is 0.
Yeah.
So understand, if you see the word stationary, what does that tell you is 0? What does that tell you?
The velocity would be 0.
Good. Do ever forget the velocity is 0. And if you forget, think about what's happening when you're slowing down in the car. When you're slowing down, the speedometer is is eventually end up at 0, indicating that you've stopped moving. Understand?
Yeah.
Good. Whew. So for part 1, we're really talking about v is equal to 0. So, but Shivan, do I have an equation for v in terms of t?
Yeah, the acceleration.
No, that's acceleration. I don't
You
have
could
v.
you could use it to get
I could use it to get v. What would I have to do with acceleration to get v?
you would have to integrate.
I would
No,
have to
wait,
integrate it.
yeah.
Yes. Because acceleration just means what over what? What does it mean? Acceleration really means what?
Acceleration is displacement over time.
Nah,
No, no,
acceleration is a
over time,
change
sorry.
in velocity with respect to time. Remember, acceleration is change in velocity with respect to time. And so
Yeah.
you can see it clearly now. If I integrate that, what would I end up with? So
12
if I integrate, if I integrate, I would just end up with what?
the dv
V.
plus
V.
v.
I would end up with V. So this is one of the tougher questions. I'm running back again. So in part 1, they want us to find the values of t for which the particle is stationary. If it's stationary, then the velocity is
0.
0. So we need to find an equation for velocity and set it equal to 0 and solve for the values of t. So we have dv dt is equal to 12t minus 17. So Shivan, what would I have to do with this if I want to get v? I'd have to differentiate it or integrate it?
Integrate.
Right, so I'll have to integrate it. So I'll say the integral of dv dt with respect to time, and I have to do it on the other side as well. So that'll be the integral of 12t minus 17, and I'm integrating with respect to what?
Time? No, yeah,
Right,
time.
time. Because the variable here is what? What's the variable?
Time.
Time. Okay, so Shivan, if I integrate dv dt, that would just give me what?
V.
That would just give me v. And so v is going to be equal to the integral of this. Let's start to integrate. So that'll be what?
12t squared over 2 minus 17x. Oh, well, t. My bad, t.
And since it's indefinite integration, what I need to slap on?
Plus t. Plus c.
Plus c. And what is 12 over 2?
6.
6. Now this is where we need to find for c. To find for c, we look at any initial conditions or any conditions they gave us. So Shivan,
Put v equal to 0, then because
I wouldn't put v is equal to 0.
Oh, 10, sorry, 10. And t is 0. My bad.
Good. Guys, if you all recall, at the fixed point, you start any timer. So at the fixed point, t is equal to what?
10.
T is equal to 0, and your velocity is 10 meters per second.
Yeah.
So you write a statement here. At the fixed point, t is equal to 0 seconds, and your velocity, I might end it like around 12 or so, and v is equal to, remind me, what was v?
10.
So Shivan, what am I going to plug in here to find for c?
The output v is equal to 10 equals to 6 open bracket 0 squared minus 17 open bracket 0 plus c. Then work out that equals to 0, and then c will be equal to 10.
Good. So what's my final equation for v then?
V is equal to 6t squared minus 17t plus 10.
Good. Let me know if you guys understand that.
Yes, sir.
Yes, sir.
Tricky. So anytime you see at fixed point, then you start in your time, right? If you see fixed point, that is where you start in your time. Right. So I'm giving you guys some time see if you could figure out the values of t for which the particle is stationary. Again, if it's stationary, we know what we're dealing with there, Shivan. If it's stationary, what we're dealing with? If it's stationary, what are we dealing with? Displacement, velocity, time, what are we dealing with? Something is stationary.
So you want me to answer?
Yeah, you. Yeah, you.
My bad. You're dealing with the velocity.
And the velocity would be equal to?
0.
Right, so fix up. Find the values of t for which the particle is stationary. Anya, you're supposed to be in the Zoom meeting grinding hard maths, girl. Anya is sticking. Well, true, we thought you already need it, but big up yourself. Big up yourself.
So didn't any question say 4 seconds as well? In the fourth second.
Yeah, I gotta explain that one. That's a tricky one. That's a real tricky question. 2019 was the hardest year, as well as with 2017.
Okay.
Yeah, hopefully all you don't get people like 20, like that. 2019.
Hmm.
In our timing, I will review alpha, beta, in our timing. Right now, we're just focusing on kinematics. We just finished integration and differentiation. So we're looking at application of that, which is kinematics. Okay, I'll get through.
I believe so.
All right. All right. So let me start. Let me look now. Anybody get any answers they can tell me?
12 and 5.
12 and 5. No. No.
I get 5/6 and 2.
That's correct. 5 over
Same.
6 is the correct answer. All right. So Nikolai, wait, Shivan, you're writing the exam this year too?
Yes, sir.
Yeah, all right. Well, let me ask you. So
Sir,
Shiva,
how fish factorize, sir? I using the quadratic formula, sir. Yes, sir.
all right, let me try to tackle this, right? Yeah,
It is the AC method, but I mean,
let me do that fast. So A by C. So that'll be 6 by 10 and 60.
see, yeah.
So we're looking for two numbers that would multiply to give me 60, but add to give me minus 17. What by what is 60?
6 and 10, you could multiply 6 and 10.
So that again?
You can multiply 6 and 10.
6 and 10, but that wouldn't work. That would give me 16. Think again.
20 and 3.
20 and 3 wouldn't work. 20. Because
20
like,
and
20 and negative 3.
nah.
5.
So that again?
12 and 5.
Okay, you're cooking. Not just 12 and 5 though. Because 12 and 5 is positive 17, but we want to get negative 17.
7, negative 5.
Negative 5, yeah.
Right. So it says negative 12 and negative 5.
Yeah.
Guys, where's negative 12 plus negative 5?
Negative 17.
Negative 7.
Right. So we're going to write V is equal to 60 squared minus 12t minus 5t plus 10. So we're going to put on the Great Wall of China in the middle. Right? I'll put on the border. Hey boy. Alright, so we are going to factor out what's common between both of them. So what do we have in common between 60 squared and minus 12t?
Factors out the a t and also a 6.
6 and t, right? So I'm going to pull out 60.
60, yeah.
If I pull out 60 from 60 squared, what would I write?
Minus.
Now, was it t? Because
Yeah,
Shiva,
t
what is
minus
what is 60 by t?
6t squared.
Right, we get back 60 squared. And what would I have to multiply by 6t to get back minus 12t?
Minus 2.
Yeah, minus 2, that's correct.
Yeah.
And here's a trick, right? If it works, then you're supposed to get the exact same thing over here, t minus 2 as well. And so what would I put here to get back minus 5t?
5. Well, negative
Now,
5.
if I put plus 5, I'll get plus 5t. So I'll
Negative,
put
negative 5.
negative. And if you want to verify it quickly, what is minus 5 by t?
Minus 5t.
What's minus 5 by minus 2?
Plus 10.
Good. So we could factor out the t minus 2. So what I write on over here?
6t minus 5.
Right? And we know at the stationary, when it's
T
stationary,
equals 2.
this will be equal to 0.
Yeah.
If you want to join the Zoom, just send me a message via WhatsApp and I'll hook you up. Right? I'll send me a message on WhatsApp and I'll add it to the Zoom. Right? And from here, Shivan, we can say that t is equal to 2. And we can say that, well, 60 is equal to 5. And, well, t will be equal to
5 over 6, which is 1 and 1/6.
You can leave your answer like this, that's fine.
Right.
And the unit for time here is seconds. So let me know if you guys are okay with that.
Yes, sir.
So the particle is stationary. At t is equal to 2 seconds. And okay, this is on the trickier end of the spectrum. And we're not done yet. This question is really, really tricky. Remember, Chris come to the live at the start and he said 2019 was a dread paper? Yeah, 2019 was a dread paper. 2019 was one of the hardest papers. I don't know what happened in 2019, but there was dread in 2019. Real dread. Right? Earlier okay with the question though, or like, want me to explain back anything?
No, sir, I get it.
That's really good.
Let me do a quick recap. Anytime you see at a fixed point, what is time?
0.
Right. If I tell you stationary, at a stationary point, at a stationary point,
Velocity is 0.
the velocity is 0. Good. Cool. Let me answer part 2, which is a harder question than the first one. Nikolai, I feel like you want to help me with part 2.
Yes, I don't mind.
So Nikolai, when I say in the 4th second, my guy, the 4th second, I know for a fact okay, hear what, Nikolai. They want me to find the distance, right? First of all, they want me to find the distance, agree? The distance.
Yes, sir.
In the last question, what we had find?
We had find for velocity.
Find for velocity, right? Let me just write that down somewhere. So v was equal to 6t squared minus 17t plus 10.
Yes, sir.
V was equal to 6t squared, I think, minus 17t plus 10, and?
Yes, sir.
Okay, and now they want me to find distance in the 4th second. Guys, when they say 4th second, do they mean 1 to 4?
Nah. 4. Just 4.
No.
0
1
to
to 4?
No, the 4th second will take place from what to what?
0 to 4.
0 to 4.
Nah, hey, from 0 to 4, you'd have the 1st second, the 2nd second, the 3rd second, and the 4th second.
So
4 to 4?
Now, 4 to 4 will be 0.
8 to 4?
Nah, boy. We're guessing at this point. All right. Here what we gotta do. Here we're gonna do before we do anything, right? So Nikolai, V represents what over what? The change in what over the change in what?
the velocity over time.
Nah, that represents the change in displacement with respect to time.
Oh, displacement. Okay.
This is hard maths, but is an application in physics, kinematics. So we are trying to find the displacement, which is really distance. So what would I do with that dsdt? I'd have to do what?
Integrate it to get distance or displacement.
Exactly. I'd
Displacement.
have to integrate it. But we need to figure out the upper and the lower boundary. That's what we need to do.
So when it be the 0 to 4 then?
Nah. Again, Nikolai. Let me draw a number line for you, right? So they could see exactly what I was saying. So when you now start, the time will be 0 seconds.
Yeah.
Then it will be 1, then it will be 2, then it will be 3, then it will be 4. Yeah, I will be doing a physics live before the exam, a 12-hour physics live to be certain for free. I don't teach chemistry, unfortunately. Yeah, boy. Real people want me to teach chemistry, boy. Nah.
So,
Hey, chemistry, dirty. I don't like chemistry. Granted, I did get my distinctions in chemistry, but I don't like
Yeah,
chemistry.
can I help you with the chemistry, you know, sir?
Okay.
so CSEC was wicked, sir, because of her chemistry, right? After ADMAT, so like not even a day break, sir.
Same day after, like immediately after.
No, the day after.
The
Like,
day after.
maths is 1 p.m. and chemistry is 9 a.m.
right after on the Tuesday. That is mad.
Wow. Wow, that is crazy. Huh. So Nikolai, hear what I'm telling you, right? Nikolai, hear what I'm telling you. So Nikolai, can you see this is from 0 to 4?
Yes, sir.
All it was telling me 0 to 4, right? 0 to 4 would not be the 4th second. That would be the 1st second plus the 2nd second plus the 3rd second plus the 4th second.
Yeah.
So a way to understand that this is the 1st second from 0 to 1.
Uh-huh.
This is the second from 1 to 2. So what do you think is the fourth second?
4.
3 to 4. 3 to 4, yes. 3 to 4. That's correct. So this is the first second. This is the second. This is the third second. And this is the fourth second. I know for a fact 90% like kids was not gonna figure this out.
No.
3 to 4. So you need to integrate the velocity from 3 to 4.
Oh, now I understand why they do that. Because
The
it is
fourth.
distance and you're finding the area.
Yes. And they're saying fourth second. That would be from 3 to 4.
Yes, sir.
Oh, yeah, understand or not?
Yeah. Yes, sir.
Yeah, they come like the fourth quadrant thing.
Oh, yeah. I see what you mean. I see the connection that you're trying to make there. Yeah. Big up you for that one. Clock it. So when I integrate velocity, which is ds dt, I know it's gonna give me what?
Distance. Well, the
Can I
speed
give
of
it this? Yeah. So we need to integrate this now. People in the Zoom, how much of you guys would have figured out that your lower limit is 3 and the upper limit is 4?
well, before no. Now, yeah.
I don't have anybody on YouTube. I'm gonna see if I have anybody on YouTube, but I don't know. Is there anybody on YouTube? 28 people on YouTube. That's crazy. I wasn't expecting that. Yeah, people on YouTube are looking at it now. How much of you guys would have figured out that the fourth second meant 3 to 4? How much of you guys would have figured that out? That is 3 to 4. Let me know people on YouTube, people on TikTok. I have 7 people on TikTok. All you would have figured out the 3 to 4?
7 people live on TikTok.
Yeah, boy. Otaku grass. Yes, I am still alive. Nah, sir, that's too hard. But after today, I want you all to understand this, right? Here's what I'm saying, guys. The fourth second, Nikolai. Okay, Nikolai and the rest of people here, they have to understand this. From 0 to 4 seconds, how much seconds we have, Ole? How much seconds we have?
4.
Gabriel, from 0 to 4 seconds, how much seconds we have?
0 to 4 is 4 seconds.
That's what I'm saying. Mikkel, Shivan, Megan, right? Amelia, Lani, Virginia, Dejan, I don't know how to say your name. I'll just say Williams. Sarah, look, Sarah, you here? I didn't know you was here, Sarah. God, boys, in quiet. Where's Celine? Celine's supposed to be here.
I don't know, so I study in geography.
Oh, you said in geography.
That one even worse. Like geography and advanced on the same day? Nah.
Yes, and
Geography.
chemistry the day after.
I am dying. Geo and adverts on the same day. And chem the day after. I had a
Yes,
new
I'm
CSEC.
fried, sir. I'm
Yes,
fried.
allegedly. CSEC.
Olha, what Geo Live or Geo Live.
So I will come to support, sir.
National Geographic, boy. National Geographic.
Yes, sir, I'll come to support, but I'm not doing geography.
I need the chem, son.
I would.
Hear what? I would try to teach a chem class. I would try to hold one chem class. I'll try to do
Sir.
like a solution or something.
Sir,
Yeah.
I'll help you out with that, sir.
You know what I could do? I would try. So that again, like speaker society, big up yourself, bro. Yeah. Wisdom?
Focus more like moles. That is
Moles?
give trouble.
The reason I do real good in chemistry because I good in maths. And I guess I could show the math hacks.
Because you find to one and find the concentration.
That easy. That thing real easy. Just math. That's a maths question. That's a maths question. If I teach you the chemistry, I would teach you the math way to do it.
Yes, sir.
Right.
Yeah, that's different.
So here what I say, hey, look, DJ boy, DJ Allen boy, Daniel, big up yourself. So here what I'm telling on it, right? From 0 to 4 seconds. How much seconds it have?
4.
4 seconds.
Right,
4.
Nikolai. Any first second when I take place from 0 to 1?
Yes, sir.
When the second when I take place?
From 1 to 2.
That is. I feel like I could figure that out. I
So
feel like
yeah,
I could
it
figure
could,
that
it
out.
could be real easy now. Now that we understand it.
Boy, when I tell you it have 4 seconds, then this will be 1 out of the 4 seconds. So first one, this will be I'll could do this now.
So reference
Yeah,
it
yeah, yeah.
like 0 to 90 and then 90 to the 180 and then the 180. Just reference it to that. I think they could get it.
All right, I'll watch this, right? Watch this. 0 degrees, 90 degrees, 180 degrees, um, 270 degrees, 360 degrees, right? Right, chat?
Yes, sir.
If I ask you the lower bound and the upper bound in the first quadrant, what you gonna tell me?
From 0 to 90.
0 to 90. But if I ask you for the bounds in the second quadrant, what you gonna tell me?
From 90 to 180.
It's the same concept over here, no? We have 4 seconds. We have 4 seconds. We have 4 seconds. We have 4 seconds. So the first one will be 0 to 1, then it would be 1 to 2, and it would be 2 to 3, then 3 to 4.
Yes, sir.
So question, if I ask it in the 8th second, that will be all my upper and lower bound be.
From 7 to 8.
7 and 8.
7 to 8. Yes. Yes. Good. Nice. And so if I integrate 6t squared minus 7t plus 10, what's that gonna be, guys?
You'll get 12t cubed divided by 3.
Whoa. Not 12t cubed.
You could get 2t
Oh,
cubed.
wait, no. My bad. You're supposed to add one and then. Right.
So
Yes,
60 squared over.
So wouldn't it be cubed?
Yeah. It would be cubed. By 3, right? Then minus 70. T to what power?
2. Well, it'll be squared.
All over.
2.
Good. And then plus 10. 10 what?
That would be t.
10t. So S would be equal. Well, I could let me simplify before I do anything. Well, I know this can't simplify to what?
That would be 3t cubed.
No, 2.
My bad, 2. Sorry.
I think we're getting a little sleepy, chat. I think we're getting a little sleepy.
No. That's only toxic. You know.
Sleep is, as you said, sleep is a concept.
I don't want to be encouraging too much toxic work habits. I feel like I just really be pushing my body to the max. I don't want all it to kill all itself.
Biology says otherwise.
No biology.
There's one thing, by the time I leave this earth, my name gonna be all over the earth, you know. I gotta make an impact. I gotta make a good impact.
Of course.
I gotta live on
I would
forever.
like to hear, sir. I would like to hear.
I gotta live on forever, my guy. I gotta be immortalized. You know what I mean? All they young, all they should aim for the stars. All they should make something of themselves. Right? Focus. Hear what? I'll give all the advice. If all they like cutting hair, if all they like football, if all they like cricket, school is important, yes, but I telling you, focus on whatever you like. Focus on whatever you like and make it your whole life. Put your whole heart into it. People are not gonna support you at the start, but when they see you making it, they'll be like, oh yeah, I know you did like that, you know. When I now start this thing, nobody believe in me, boy. Nobody believe in me. I had to buy my own equipment and thing. I had to work real hard. But no, everybody will be like, wow, you know, I see you in that sticker with Terry David and Cohen Springer and thing on it. I see like a video that's what I'll be like, well,
Yeah, the side eye look.
I'll be like, I know that reach is big. You just didn't believe in me. But I believe in myself though. So I can't say what I wanna say. Wait, I already word. H Y yeah. Anyways, back to the maths. Yeah, I mean, people what I'm trying to say is if you passionate about something and you love what you do it, focus on the 100 and 200%. The success will come in on timing, but if you're obsessed over it and you make it your life, success had to find itself at some point. Yeah.
Who talks it?
People say school is the most important thing. School is important, but it's not the end all be all for everybody. For me, it was the end all be all because I like into academics and maths. So I focus heavily on that, but that's not gonna be the case for everybody here. Some of them have much bigger things lying in the world that does not relate to maths.
Yes, sir.
I make a little motivational video.
So where you was going right there could have stand for Holy Youth Math Club.
Say that again?
Where you wanted to write could have stand for Holy Youth Maths Club.
Okay, yeah. That sound good, that sound good. But like people is really be telling you you can't make it, when you make it, they can't be like, booyah,
Sir, they
in
could
your
be a
face.
best friend. Sir, they could be a best friend, sir.
Yeah, boy. So plug that into the calculator
I
and
get
catch me
49.
later.
I get I
49.
get 49.
49 over 2.
For the whole thing?
Yes, sir.
Yeah.
32 for the first one and 15 over 2 for the second one.
Oh, and by the way, if I didn't know, I'll Cassie, your calculator, Cassie is very helpful. And she could like do the whole thing for you to make sure you answer correct, by the way. So this is a hack I used to do, right? I used to write this line. Oh yeah, I used to write this line, okay? I used to write that line and I used to plug it into the calculator.
Well, I mean, I did do that. You see, like with the sum of I is equal to something and then R is equal to something, and they'll tell you to go with the pattern of the square roots. No, with the square numbers.
Yeah.
Right. I just plug that in the calculator and get it too. But I know I lost like 3 marks because I put in the answer without any working.
Yeah, to be careful.
Yeah, but
So you have to big up Stunner too, sir, because
Sunway
like
goated, you know. Sunway, Quast, all of them goated. Yeah.
yes, sir. Yes, sir. Sunway is another goat as well.
Yeah, Sunway, Studmark, goated calculators, Quast too. Yeah, but Oli should get 49 over 2 granted he did everything correctly.
Yes, sir.
Which is 24.5. No.
Yeah, yes, sir.
Is it?
Yes, sir.
Serious?
yes,
Yes,
sir.
sir.
Okay. Sometimes my brain is just look at numbers and see the answer and then I'll question like how you get her. Be like, how you get her? The brain is truly weird, you know. Like truly weird.
Yes, sir. For example, the biology paper released and somebody went and did a video on it. And some of those questions I guess and it ended up coming correct in the exam, sir. So
Make
I
up
get you.
yourself.
Yes, sir.
You gotta make up yourself.
Yes, sir. Like it's a 50-50 gamble. They take all your money or you take all your money.
Yeah. Nicola, you go play when you like, turn 18 and thing, you go play with. I feel like you owe it.
Nah, that you wasting money, sir. Nah. $20 gone and $20 gone and nothing, sir. Nah. Them taking
Right.
my money and robbing me.
I never play with in my whole 22 years of life.
Yes, sir. Don't do that.
Never play
I'm gonna
with
rob
it.
you instead of you getting something.
So we just looked at one of the hardest questions in the whole 11 marks in all. 11 marks. 11 marks is a lot of marks. Yeah, guys. So let me do a summary. If you see at a fixed point, you see time at a fixed point.
0.
Does it mean that at a fixed point, time will be 0, but does it mean the displacement will be 0?
No.
No, sir.
No, sir.
And could I be moving before?
Yeah.
Sure.
Does it mean that the velocity will be 0?
No.
No, because it could be moving already.
Yes,
If
sir.
it could be moving already, right? What about the acceleration? Does the acceleration have to be 0?
No, I don't think so.
No. The point is, right? At a fixed point could be like a reference point, like I want to just take a measurement for. But the particle could be moving already, you know. And if a particle is moving, it would have velocity, it have acceleration, and it would have displacement if it's moving already. But at a fixed point, you say the time is 0. If they ask you something like find the displacement in the 21st second, how you gonna do that? Or be my upper and lower bound?
20 and
Lower
21.
would be 20 and 21.
Right, and I would have to integrate what? V, S, or A? If I want to get displacement, I'd have to integrate what?
Velocity.
V, with respect to?
Time.
Time.
Badness, mathematical badness. Here what?
So,
I'll give all that question to Don and call it a night. Alright? Because I'm feeling tired, low-key tired. So when we come back tomorrow, we will just do some graph questions and starting trigonometry. Strong. Starting back at 3. Real grind. We're gonna real grind work.
trigonometry is probably my weakest point right now.
Alright, noted. I'm looking for a tough question for you guys.
Didn't you see the syllabus? Well, the format did change after 2018.
That's what I given in 2018.
Ah.
Yeah, so try that question for me there, guys. I gave it only 5 minutes. Which kind of illegal because this whole thing is with 12 marks. Let's see what. Oof. Guys, at the rest points, where you know? At 3 p.m. I'm having 3 p.m. tomorrow, guys. 3 p.m. At the rest points, where you know? At the rest points, what do you know?
Velocity and time is both 0.
Well, not necessarily. I know that the velocity is
That's what
0
you say at rest, right?
at rest, but and I could walk. Okay. You said
Oh wait,
you
no,
said
no.
that
So I think I understand.
like
Like if you decelerate to rest or something.
you're like okay, if I was moving before, and I would have and time would have passed by. So when you rest, time
Yeah.
would be 0. But you see, okay, the statement is start at rest. If it's start at rest, then the time is 0 at rest. But rest in of itself, it just means that the velocity is 0. That's the only thing it really means. People on YouTube chat, I see you all tomorrow, 3 p.m.
Sorry, I'll make a game. I go on.
Michael, you alright?
I go on there real tired, so.
Wait, boy. Alright, Michael. You will do this
Thank you.
question. Answer it tomorrow.
Alright, tomorrow though.
Take care, man. Later.
Yeah,
Have a blessed night.
same to you.
Yeah. All right. All the people on YouTube, tell your auntie, tell your uncle, tell your sister, tell your brother, tell everybody. Math 5's gonna be doing well. Ad maths lives. Better save the ad maths people. You know what I mean? She's my blanket day, boy. Yeah, what the blanket day? I get the blanket, boy.
So this hoodie, this
You mute yourself.
this hoodie is real comfortable. I can't lie. Like it's real comfortable. It
Okay.
have cushion in it, so like they all fur.
Okay, wait. Well, I want to make a little TikTok after this. I'll go make to make a little TikTok.
Don't mind.
Okay. Badness. I tell you, genuinely, if you have a dream, believe in it. Nobody gonna believe in you. You gotta believe in your dream for the longest while until you make it. Then people will start to believe out of nowhere.
So,
Yeah, talk to me.
this file that you have with all the questions from each year, you make this yourself?
Yeah, I did.
Oh, alright.
Kind of crazy, you know. Watch.
Mm-hmm.
Yeah.
You think I should do this for me? Or good, be of time.
Say that again?
You think I could do this myself?
Yeah, you could, but you can't do it now.
No. I find I better to answer the questions.
It take me like a month to do.
Huh?
Yeah. Because I do back all the
Yeah.
diagrams and the graphs and every single thing, you know.
Oh.
That is dedication right there.
Yeah, people have been sleeping on MATLAB for the longest while, but the amount of work I was putting though, it's crazy. It's crazy.
Alright. Thanks.
And these questions, yeah, they can answer. Can answer. Hello, Rajiv Dwarika, number 2. Can you hear me? There's a Rajiv Dwarika, number 2 in the meeting.
Really?
Melodia, pick up yourself. And I have a feeling it's Mrs. Mark 5, but she had talking. By the way, the time is up, eh? The time is up. Who wanna run this question with me?
So I don't mind.
Nicola, you never mind.
Yeah, I don't mind, sir.
That's the energy I like. That's the energy I like. That's what we're talking about. There we go. Nicola, you such like a role student, if that makes sense. Like, you're so dedicated. I'm telling you, like, Chris from after question.
Yes, sir.
The Chris know everybody know you, Nicola. Everybody know you, boy. Everybody know you, boy. Everybody know you. Everybody know Nicola. I tell you. Everybody know Nicola. Nicola, boy. Right. A particle moves in a straight line so that its distance s meters after t seconds measured from a fixed point. Aha, back again with this fixed point thing. What we know about the fixed point?
I know two things supposed to be 0. Is
Nah,
either
just one. Time is 0.
time.
And is given by the function s is equal to t cubed minus 2t squared plus t minus 1. So this function over here is going to give us displacement with respect to time.
Yes,
So
sir.
in part 1, they want us to find the velocity. Do we have velocity, guys?
No, sir.
What could I do to get velocity though?
Differentiate the displacement to get velocity.
So if the displacement is t cubed minus 2t squared plus t minus 1, what would I have to do with it to get velocity?
Differentiate.
Yeah, differentiate.
So I would, ds dt. And that would give me what?
3t squared plus 4t. I mean minus 4t, not plus. Plus 1.
Good. And we want to find the velocity, granted that time is
2. So
2.
let's substitute 2 into the equation. I got 5 for that answer.
Yeah, I also got 5.
Badness. And then we find f for velocity here, so that'll be ms minus 1, right?
Yes,
Yes,
sir.
sir.
Cool. Let me tackle part 2 now. In part 2, they want me to find the values of t when the particle is at rest. Aha. If the particle is at rest, what we know? Shivan, what we know? I call him the man, I call him Shivan. Shivan, tell me this one.
Every particle at rest
Yeah.
means that the acceleration,
No,
the velocity
the
is
velocity. The velocity is
0.
good. Remember what I tell you? Imagine in a car, when you press brakes, what does how to slow down? What does how to go down?
The gauge is speed gauge.
Speed gauge, right? Speedometer. It's go to 0. Right.
Yeah.
So when the particle is at rest, we're going to set v equal to what?
0.
Alright, so that's going to become 0 is equal to 3t squared minus 4t plus 1. And we had to do what?
I factorize this. So
Right? Gonna factorize this. Although, you know, you could factorize this all the AC method, right?
Yes, sir, that I
yeah,
did.
That'll just be 3t by t and 1. To get 1, that'll just be 1 by 1, right? But I'm noticing that again minus 4, so maybe I should put minus 1 here and minus 1 here. And that's it. Watch, 3t by t is 3t squared. 3t by minus 1 is minus 3t. Minus 1 by t is minus t. That'll give me back the minus 4t. And minus 1 by minus 1 is what?
a positive one.
So I'd say 3t minus 1 is equal to 0. And I would say t minus 1 is equal to 0. And so 3t
Will
would
be
be
equal to a
A
quarter
third.
and not a quarter, a third, and 2 be equal to 1.
and that's going to be seconds. So the particle is at rest at the following times. When the time is a third of a second and the only time is 1 second. Cool. 4 marks for that, Dolly. That's crazy. That's low genuinely crazy.
It's 6. Well, oh no, 4 for that question. Right.
That's easy marks, boy. I read easy marks.
Yes, sir.
Part 3.
The
The
distance
distance between the rest points. This is a nice question, man. This is a nice question. So if you want to find the distance between the rest points, and what will I do?
I use 1/3 t into the original equation, which is the displacement.
Yeah, I did the same thing.
And then at a minus the, well, when I find the displacement, when I put t is equal to a third.
Good. So you plug in 1. You plug in 1.
I plug in 1 and I plug in the 1/3 into the original equation, which is the
Good.
displacement.
Good. I'll understand, right? Because the original function gave us displacement. And so if you want to find the distance between the two rest points, you plug in the times into that and you find your displacement for each, and then you just minus.
Yes, sir.
So let's find what the displacement is. Let's find what S is when t is equal to a third. Let me start off there. So I'd say S is equal to a third cube minus 2 by
T a third squared.
Plus
1/3.
plug and take calculator and I'm know what you get.
I got minus 23 over 27.
Wait, what are you guys getting?
Minus 23 over 27.
Yeah, that I get.
Minus 23 over 27.
Yes, sir.
Okay. Let's find what the displacement is when t is equal to 1. So somebody work out from 1. Tell me what you get.
I got 1. Like, no, minus 1.
Did anybody else get that?
Yeah, I get the same thing, sir.
Okay. Cool. I'm gonna verify that. So S is equal to 1 cubed minus 2 by 1 squared. And that'll just be plus 1 minus 1. You gonna tell your mommy I teaching better than she? Hey, next thing you get me in trouble there, boy. Somebody on TikTok says, so I go and tell my mommy that you teaching better than she.
Well, first to begin with, your mother smart. Well, the mother smart because to teach art maths, you gotta have a good foundation in maths.
Yeah. Hey, Anna, your mother real smart. Anna, your mother just teach art maths in school. I watch him moving on in chat. Yeah, Anna, your mother teach art maths in school. Oh, yeah. She mother teach art maths in school.
What?
Which school? Which school is that?
So when this live done, like when you cut off the live, I will say a statement.
What's
Well,
your statement?
I thought run through my head, yeah.
Nicola, you're scary, you know.
No. It's just a thought now, so like when they say what school she from?
Yeah. So let me show you how to tackle this question, right? So everybody getting -1 meters.
Yes, sir.
Right. So if we want to find the distance between these two, how we gonna do that, boy? Let's
Yeah,
scratch away the
minus.
alphabet. We just minus, that's all. That's all. So the distance, that would literally just be the -23/27 minus -1. And what is that gonna give me?
I got 4/27.
Yeah, I
Anybody
got the
else?
same thing.
Good. That'll be 4/27 meters, right?
So this question wasn't so bad. It just
I
take
don't.
me like twice, so maybe a third time to read it.
Oh, let me tackle part for you, right, Pat? The last one is a lovely question. So, the time at which the maximum velocity occurs. Earlier, make the connection, right? In differentiation, we talked about the maximum and the minimum. The maximum or the minimum occurs when what?
Repeat.
The maximum or the minimum occurs when what? Think of like when you're doing
Y.
differentiation.
It reaches
Derivative.
point.
When it's equal to 0, the change in dy dx was 0. Remember?
Yeah.
Okay, yeah.
Yeah, so if we want to figure out the time at which the maximum velocity occurs, then here's what I'm going to do. So Nikolai, tell me, right?
Yes, sir.
Well, in this question, we have S, right? We have S.
Yes, sir.
So what are you thinking to do?
Well, wait, the velocity is 0. So we put that equals to 0. No.
No. Here what I'm saying, right? Okay, I want to let you think, right? I want to let you think. When something has reached its maximum velocity, is it accelerating anymore?
No, sir.
No.
No.
Think, right? No. And if something reaches its maximum height, and it would like stop accelerating and then it would for a second, it would stay stationary and then it would start falling again.
Yeah.
Yeah.
Yeah, so anytime they ask you for maximum velocity, what I want you to be thinking about is acceleration.
So, say differentiate velocity.
Right, so I would differentiate velocity with respect to time and I would set that equal to what?
0.
Yes. Right. I'm running back again. Earlier, if something has reached its maximum velocity, hasn't it reached terminal velocity, meaning that it's not accelerating anymore?
Yes, sir.
Good, I hope you understand that.
Yes, sir.
So,
They say
right?
run that back.
Somebody say run that back?
Yes, sir.
All right. Let me just say you throw a ball, right? You throw a ball. And it would accelerate, and then it would reach out. Okay. Um, the person, okay, you doing physics or not? The person that said going back, you doing physics or not?
He say yes.
Okay, let me get another example, right? Do you know about terminal velocity? Now, yeah or no?
Yes, so terminal velocity is like the
Sir.
maximum the maximum speed that the sun can hit when the upthrust cancel out with the when it object falling.
Right. Okay, that's really the best example to use, right? Sarah, imagine you throw something into the air, right? You throw something into the air. And when you throw
When
it,
the weight of it cancel out with the upthrust, then it can't get any faster than that.
exactly. So like you can't get any faster, and that's it. That's its maximum velocity. So here was some another example. Imagine you throw a ball into the sky, and to get the ball moving, you'd have to enact a force And by doing that, you'd create acceleration. F is equal to ma. F is equal to ma. So F is equal to ma. When you enact a force on the ball, the ball is going to start to accelerate. Yeah?
Yeah.
Sarah. So if it start to accelerate, eventually it will reach its maximum velocity. And when it reaches its maximum velocity, wouldn't it have accelerated as much as it could?
Yeah.
And then, so at the maximum velocity, the acceleration is actually what?
Equal to the option. Wait, can you repeat that?
At its maximum velocity, the acceleration is actually what?
At the obtuse.
And the acceleration is actually just zero.
Oh.
Because
Oh yeah.
because like it like if you think about it like this, okay, you know about
Yeah, the graph will plateau. Yeah.
you know about kinetic energy and potential energy?
Yeah.
You reach your maximum kinetic energy when you use up all your
Potential energy.
yeah. So like it's the same concept here. Maximum velocity would happen when you quote unquote use up all your acceleration. So let me know if you understand that.
Yes, sir.
Yeah, so maximum velocity occurs when the object is not accelerating anymore. Because Sarah, if it has reached its maximum velocity, okay, so Sarah, when something has reached terminal velocity, right? What do you think its acceleration is?
0.
Zero, because is it changing? Is the velocity changing with respect to time anymore?
No, constant.
It's constant, right? So at maximum velocity, the acceleration is
0.
because all of the forces would essentially be at equilibrium, but it would still be
Yeah.
moving. There's a misconception people have, Sarah. In physics, people think that if the forces are the same, like it wouldn't be moving, but technically it could be moving. It just you wouldn't experience a change in motion. Like right now, Sarah, we are moving. Like we are literally spinning. But because the acceleration is fixed, we're moving at a constant velocity. A constant velocity, right? Because we're moving at a constant velocity, are we experiencing the rotation of the Earth?
No.
No,
That makes so
because
much sense. That's so cool.
from our reference frame, right? We are experiencing it as it's stationary because the Earth is spinning at a constant velocity. It's like how you be in a car, right? A car would be like going real fast. It's only when it mash a brake you realize how fast it was going. You know what I mean?
Yeah.
So maximum velocity occurs when the acceleration is literally zero
0.
because it can't accelerate anymore if it reaches maximum speed. Yeah, if you understand what I'm saying, it cannot accelerate more. So acceleration is zero. Yes, I am from South. Can you guess which part of South? So yeah, so the maximum velocity occurs when the acceleration is equal to what? Thomas, Sarah.
0.
Right, 0 ms minus 2, right?
Yeah.
Right, no, not correct. Yeah, not pina. Might as well be, but not pina. And so we need to actually find acceleration. And to find acceleration, you're going to differentiate the velocity with respect to time. So we had found the velocity to be this over here. So this was the velocity over here. And my iPad just froze. Damn it. Give me a second. Yeah, so I was saying we found the velocity earlier to be what? What did we find the velocity be earlier?
0.
5.
Wait, no,
Oh, 5.
that's
Oh, that okay.
this is the velocity we found
5.
earlier.
Yeah.
So this is the velocity, right? The velocity is just a change in displacement with respect to time. And so the velocity is 3t squared minus 4t plus 1. And so if we want to find acceleration, I would need to differentiate this, right, with respect to time. And what would I get?
3t minus
Nah,
4.
no, not 3t, not 3t.
6t minus 4.
Right. So you're gonna pre-multiply by the power. So you say 2 by 3 is 6. So that'll be 6t and minus 1 from the power. So that'll just be to the power 1. And then if you differentiate 4t, that'll be just 4.
Minus 4.
If you differentiate that constant, it'll be 0. So Sarah, I wonder if you're okay with this.
Yes, sir.
And well, we know that the maximum velocity occurs when the acceleration is equal to what?
0.
Right, so I'll say 0 is equal to 6t minus 4, and I'll solve for t. So if you move across minus 4, you'll essentially get 60 is equal to 4. So t would be equal to what?
4 and 6, which is 2/6.
Yep. Yep. Yeah, I'm gonna follow you okay with that.
So
Physics is really cool. Yeah, physics is really cool. Yeah.
You are gonna say this from now when they start doing the physics crash course. I'm hardly gonna I gotta real stop there and stuff because my teacher never teach anything. Like it was so bad. Yeah.
That's okay. Most physics teachers are bad. I don't know how they come. I don't know
So
why though. I don't know why most physics teachers are so bad. Like
when we
I feel
had
like
our
most
essays,
physics teachers just do explain it. Just do explain it. Just give you handouts until you learn that.
no, not even handouts, like nothing. Like 2 weeks before essay was due, he gave us like a bunch and was like, yeah.
Wait. Well, how much school is this? This is Tech.
Yeah.
Oh, all right. Well, that's it. Essentially we done for the night. So guys, if I talk about here, what's it? Everybody. Let me open up the YouTube so I can see people on YouTube. Oh, we still have 30 people on YouTube. Yo, you in trigonometry tomorrow? Don't worry. We have 30 people on YouTube, boy. That's surprising. So here what I'm saying, guys. If I want to know, if I ask you about maximum velocity, what we know at maximum velocity, what we know.
Is your acceleration?
Acceleration is 0. Yes, acceleration is
0.
because if I'm traveling at a maximum velocity, can I accelerate anymore?
No.
No. So the
No.
acceleration is 0. Next question. If I want to figure out well, there's another way they could ask it. If I want to figure out the region where it have constant velocity, or looking for constant velocity, what does constant velocity mean?
At rest.
Nah. Constant velocity means you're moving at a fixed speed.
Speed is constant, yeah.
So the acceleration would be equal to what?
0.
0.
Yeah, because if you're going at a constant velocity, you're not changing your speed. Right? So your acceleration is 0. If I ask you for at rest, what does at rest mean?
You're not moving.
The distance is equal to 0 or the displace. No?
Does it mean that time is 0?
No.
No.
No. If I say start at rest though.
Time is 0.
Time is 0.
Time is 0 and displacement is 0. If I tell you something like the 9th, find the displacement in the 9th second. We're gonna do
8 to 9th.
8 to 9, sir.
and you're gonna integrate what?
The displacement.
No.
No, the velocity. Because
Velocity,
Yeah, because remember, velocity is the change in what over the change in what? Remind me.
the change
Change in
in
acceleration.
Displacement over time.
Right. Velocity is ds over dt. So if you want to find for s, you gotta integrate it. If I want to find for acceleration, and I have V. What do I do with V?
Find the
Yeah,
change.
differentiate. No.
I differentiate, yes.
Oh, okay.
Yeah, because acceleration, remember, acceleration is dv dt.
Yes,
So if I
sir.
have V with respect to time, and I want to find for acceleration, I'm going to differentiate it with respect to time. Cool. If I want to figure out where a particle is stationary. What does stationary mean, chap? Stationary. What does stationary mean?
Displacement is 0 or distance is 0.
Yeah. Well, actually, no, Nikolai, that was wrong. Nikolai, okay, here what you imagine, right, Nikolai? Imagine you're driving a car, right? You're driving a car, right? When
Sir,
you press the brakes, what has happened to the speedometer?
it is decrease.
It is decreased, and when you stop, what does the speedometer read?
0.
So when you're stationary and you're not moving, what would the speedometer say?
0.
So when I say stationary, I'm really talking about the what?
The speed.
Exactly, the speed or the velocity. And so when I'm stationary, the speed or the velocity is equal to what?
0.
Exactly. Earlier, don't forget that. If I say the word stationary, what does stationary mean?
The time and velocity is 0.
No, it does not mean the time is 0.
The
Because
velocity.
Nikolai, Nikolai, if I stationary and time could be passing.
Yeah, true.
Yeah, watch, Nikolai, look. Study stopwatch.
Yeah, I don't want to watch out of timing right now. Yes, sir.
Somebody play the Black Beatles mannequin challenge. I don't know if you know about mannequin challenge.
Huh?
Now, I'll let you, I wouldn't know about
Ah,
that.
sir, I know.
Sir, I pick Vine and sir, I pick Vine.
Yeah. Black Beatles got the really rolling. She thinks she love me. She thinks she trolling. That girl is a real. You don't know.
I hear about this song, but I never really searched it up. So.
Oh, hey, mannequin challenge. But Nikolai, I hope my point is proven, right? If I stay like this, is time gonna be 0 or is time gonna pass by?
Time is gonna pass by.
Exactly. So when I say stationary, what does stationary mean?
The distance.
No, it does not mean distance.
Velocity is
The
0.
velocity is 0.
Yes, the velocity is 0.
Okay.
I don't know why earlier. Okay, I feel like
Right.
it's a relatively straightforward one to understand. Again, Nikolai, if you are Nikolai, here, what? Imagine in a car, right, Nikolai? Imagine you're in a car.
Yeah.
Imagine in a car. Vroom, 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 vroom. You know that song?
Yes, sir. I hear one song.
Right. So Nikolai, imagine that this is a speedometer, right? And you have 100 here, and you have 0. When you press the brakes, what would happen to the speedometer? When you press the brakes?
It'll go to 0.
Exactly. And when the car is at 0, when the speed is 0, the car is at
Stationary, stop.
exactly. So when I'm talking about stationary, I really just talking about what?
The velocity.
The velocity. Yes, because velocity is a vector quantity for speed. So quote unquote, you could use it quote unquote interchangeably in maths. But you should know it's not the same thing. But Nikolai, when I say at stationary, I saying that I was saying stationary.
That the velocity is 0.
Exactly. That's what I'm saying. That is what I am saying. Cool. All right. Cool. That's the day. It's a good session, guys. Tomorrow we go you can do the graph questions and we'll start trigonometry. So yeah, guys.
Yes, sir. You could always watch the table, the poll that I put up in the chat. The majority of people who chose the subjects that they want to do.
I'm gonna check that. Before I go, don't forget the TikTok. Survivors for art maths. Yeah, boy. Watch everybody on the camera now, eh?
Of course.
Wait, eh? I should play the mannequin song.
You should say.
That girl is a real practice. You know what? We go stay still and I go like pan the camera. Yeah. All right. Put on the camera, guys. Put on the camera. Put on the camera.
The copyright is a real thing, so I mean,
So that again?
it is a
Oh yeah. Well, it's TikTok. It's TikTok. TikTok would allow me to play this song.
Yeah.
Right. So I'll put on the camera there. There we go.
So you find the song good? Like the song that you just sing there. Like it's sung good. Okay, like from your perspective, it was so good, but my perspective.
She think she
What's the
love
name?
me. I
What's
think
the
she
name of the
trust
song, sir?
that girl is a real proud. What's that?
So what's the name of the song, sir?
Black Beatles. Somebody song again.
Okay, but so check out the survivors is boys more than females, male more than females.
Oh wait, the name of the song is Black Beatles. Yeah.
It is.
Black Beatles. That is a mannequin.
Yeah.
And we was like talking about that from before, so it was like it have more females than admats, but like look how it have more males in
It's
each
only the guys that survive.
Yeah, that just because the girls went on sleep early.
Oh yeah.
Not-
Hey, sir, this song is not too bad, sir. Actually,
That's up.
I know you good. I know you good.
Black Beatles got the belly rolling. She thinks she love me. I think she trolling. That girl is a real proud piece of no.
So tell me why my Zoom service upgrading and I'm gonna disconnect in like 20 seconds.
I
Oh,
get
yeah,
that same
yeah.
thing
No,
too.
it's
Yeah,
still
that
not.
13
disconnected
seconds
also.
work.
Let me
Ten,
go. Let me go fast.
Yeah,
Wait.
7, holy
These are the